Okay, good morning, everybody. Welcome to day 3 of the 2026 AIAA Design, Build, and Fly competition, or DBF for short. I am EJ, your host. I'm the flight line commentator for this weekend's activities, but I have Meredith here from the AIAA talking about a recap for day 2. We had a lot of action yesterday on day 2. That was actually pretty good. There you go.
Yes, we did. We had 88 teams fly yesterday, which was awesome. So we really picked up the pace. And I think part of that was because we had a lot of mission 1s where they're just doing 3 laps in 5 minutes. So they don't necessarily use all the 5-minute time. Whereas mission 2, they're trying to maximize the number of laps so that they can get their ducks and pucks flown and maximize their income. We really picked up the pace. It was good to see so many flights out there.
Absolutely. So we did see some mission 2s, but those mission 2s, despite them being like it's a criteria, right, for mission 2, they have to instead of like mission 1 being 3 laps going around the track, mission 2 is how many laps you can do in 5 minutes.
Right.
So despite we did have mission 1s, but we had a lot of mission 2s, and despite that, we still nailed 88 flights yesterday. That was really good.
Incredible.
Really good. We're cooking right now. And hopefully we're going to see more action today, right?
Yeah. Well, also we completed 37 ground missions.
37 ground missions.
So that's a good number, but I expect today it's going to really increase. Our ground mission is going to be very busy.
Yep. So we have mission 3s coming up today where they actually have to tow a banner around. And they have to tow a banner around, the collegiate teams have to tow a banner around the track, and they have 5 minutes to do as many laps as they can. They have to deploy that banner after takeoff and keep going and then drop it and then land. And whoever does the most laps is going to get paid the most. Now, speaking of that, I've been understanding from what I've been looking at, I've been reading the rule book all weekend, and I've been looking at teams getting paid, teams getting paid. And it sounds like teams are operating a Bush airline here, right?
They are.
So they get paid, right?
They do. They have to get paid in what we call duck coin.
Duck coin.
So you can see it right here when they complete mission 2. There's a lot of math that goes behind, the formula, and
we don't do math in public.
We don't do math in public. Yeah. So,
they get paid.
Yeah, they're getting paid in
that's
duck coin.
That's how this goes.
Pretty cool. Yeah.
All right. So we'll see how many duck coins get awarded today. Meredith, thank you very much.
Yeah.
All right.
Sounds good.
So, as is tradition that what we've been doing here over the past couple of days, we have the big dog coming in. This is Clay Morey right here. Clay, how are you?
I'm doing well, EJ. How are you today?
I'm great. What'd you think of day 2 on the flight line with me?
Day 2 was a lot of fun out there. The weather was perfect. We saw some amazing flights and some pretty incredible crashes as well. It was an epic day.
Yeah, we saw a lot of ups and downs, to make a pun. People are going to go crazy at me for that. Sorry, but we had a lot of ups and downs, a lot of great flights. But, the teams that crashed, they're repairing their planes here in this hangar, and they're going to get ready to go today. That's what we're going to see, right?
Yeah, yesterday was kind of the day of the duck.
Yeah,
today is where more or less the rubber hits the road, right? So it's banner day, if you may. But let's dig in a little bit to what that means. I was just talking with the committee over there. We were looking into the rules that you said. We saw some really interesting things yesterday, and I talked to a couple of the teams that had very large capacity airplanes. And so the Technological Institute of Buenos Aires, University of Southern California, these had max capacity systems. You were talking about 150 duck
and that's a lot
capacity.
When you think about it. You think a little rubber duck, it's like, that's not a big deal. 150 of them is no joke for a plane the size that we're flying here.
Plus a ratio hockey pucks.
Yeah, exactly.
So, and that affected some of the plane stability. You could see some of that. And those large capacity planes, not as quick, right? Not as quick around the course as someone like Ljubljana.
But that shows the trade-offs, right?
A dart.
And
dude, so just nuts. To go through a little bit of what that ranking looks like for the for the live stream viewers out there, USC right at the top of the list right now. They had that huge wing design where you could put the ducks actually in the wing of the aircraft. Which was a beautiful design.
Fuel in there, right? It's electric.
Royal Melbourne Institute of Technology. The Australians are hot on the heels. They were our second place finisher last year. They're coming back. They're looking for some revenge and try to get to the number 1 spot on that. University of Akron coming in 3rd, and they had a very nice flight yesterday. Then we got UW Seattle, the Technological Institute of Buenos Aires. I'm not going to try to do it in Spanish. We kind of got memed on that one yesterday.
Should I try?
You want to do it? Go ahead.
Universidad Pontificia Bolivariana.
Wow. Then mic drop, right? I'm not going to drop the mic.
I'm not going to lie.
All right. Then we had Ljubljana, which had this unbelievable fast plane. University of Texas, Dallas.
Yep.
Virginia Tech. University of Notre Dame, which always has a strong showing here. They always bring a giant team. And UCLA rounding out that group. So that's an incredible top 10 list. But the banner is a really interesting one today because
definitely different.
There's a whole formula around the length of that banner and how many laps they can do around the course.
Right.
And so it's worth more than day 2. So the viewers really need to pay attention to, on a competitive basis, what are we looking at here? So you can see some teams out there practicing this morning, literally running around the outside of the hangar here with giant banners to see how they're going to fly.
Got to do some simulation.
A little sim. And we're going to see how this goes today. It'll be interesting to see the unfurling of those banners.
It's going to be great.
It's always dynamic here. We always have a really interesting wrinkle that the organizing committee throws in.
Yep.
And by the way, let me thank the organizing committee, the volunteers that are here. We have over 50 volunteers and committee members here on site. We had dinner with them last night. They're an amazing crew. They've been doing this, some of these guys, for 30 years, and it's incredible.
And it's not only that, it's the other volunteers that are judging these projects throughout, like going up into the competition. There's hundreds more after that, on top of the on-site personnel. It's
over 100 judges that are reviewing the technical designs on these aircraft. Even before they get here, they're doing a ton of work.
Yep.
And we want to thank everyone there. If you're viewing and you're a judge, thank you so much. And then, of course, we couldn't be here without our hosts and sponsors. So Textron Aviation, Cessna, and Beechcraft. And we've got a whole host of other sponsors. We've got other companies that are here doing recruiting here on site.
Yep.
We want to thank all of the companies that are involved in DBF, because without you guys, we wouldn't be able to make this happen.
Absolutely. All right. Well, Clay, I'll see you out on the flight line
today.
Yeah, all right, man.
Cool.
Thank you very much.
A great day.
It's going to be great.
Perfect weather.
Got good weather, good winds. All right. There we go. Day 3 has commenced for the 2026 AIAA Design, Build, and Flyer DBF competition. Let's head down to the flight line and we'll see where we go from there.
It's more like one of way out there. That's where we.
Wonderful.
If you go that way, make sure you go over the yellow bit.
And mission 2.
They're counting down.
All right, hey, good morning. I'm Clay Morey, CEO of AIAA. We're here in the hangar. Teams are getting ready to prepare for Banner Day, but I wanted to interview a few of the top teams that are out there. This is the University of Ljubljana. They've got an amazing plane. It was probably the fastest plane that was on the course yesterday. Yep. And we've got the team leader right here with us. Why don't you introduce yourself to the viewers?
So my name is Jacob. I'm the team leader of Edward Rusian team, our team from University of Ljubljana, Slovenia. We have a great legacy here at this competition. Our team is actually named by Edward Rusian, the pioneer of airplane manufacturing in Slovenia, and we try to build on that legacy with our planes here at DBF competitions.
So this is an incredible plane. I imagine it's all composite structure here?
Yeah, so it's all made from carbon fiber, and maybe some other guys can answer some more questions about that later. But yeah, so we build on sharing the knowledge, sharing the expertise through the generations, to really get amazing manufacturing techniques and just build on that knowledge year in year.
I noticed here it's got like shark fin on here, and dorsal fins, like it's a killer shark here. Is that intentional?
No, these are just the antenna covers.
Okay,
but they look really good.
But they look pretty cool, yeah. All right, and how is your plane so fast? What's the power plant in this thing? Because it was moving. You did 13 laps yesterday, yeah?
Almost. Yeah, we missed the last lap by just a few seconds. But then we compensated for that by doing some crazy maneuvers in there. But yeah, so the power train is a trade secret.
It's a trade secret, okay. Well, that's good. Secret sauce.
Yeah, that's the secret sauce and the secret juice inside. Yeah. So
okay.
But yeah, it's built for endurance. Like both missions this year are 5 minutes long, so it's built to last in the air, but it still pulls through a lot, some very high speeds.
So, do you have a strategy for Banner Day? Because there's a complex formula, numerator, denominator, length of the banner. How does that look for you guys? We
are very proud about our simulations. They are really thorough. So we program everything ourselves. We have a nice program for calculating all the mission aspects, and we have a pretty good strategy, I think.
This is awesome.
But we'll see it in the sky. So
we'll see in the sky. The proof will be in the sky today. Well, thank you guys for coming. How many people on your team?
So we have 15 members here.
Wow.
Who are able to travel to the United States for the competition. But we have around 40 members in total.
40 members
so
total.
Yeah, there's a lot of our members watching at home. Also leaving comments in the stream, and we are very happy for all the support.
Shout out to the people back in Slovenia.
Yes, and also shout out to all the members back home who helped us build this plane. Their effort is as important as ours here. So
it looks fast sitting on the ground. Let me just say, this plane looks fast just here. Yeah, impressive. Well, hey, thank you.
Yeah, thank you.
Congratulations. Good luck today. All right.
Can you show the patch?
Yeah, sure.
Yeah. So this is our patch. It has the name Brvinc on it. That's something I haven't mentioned yet. That means an ant. So that's a dialect word for an ant in Slovenian, and it really got us impressed when towing the banner, which is much larger than the size of the aircraft. It really had this analogy, like an ant carrying much larger loads than itself. So
fantastic.
You can have that.
Thank you.
You can put it on your jacket.
Thank you so much. Yeah. All right. Good luck today.
Thank you.
It's AIAA Clay. I'm back here in the hangar. Thanks for joining us. We have Alexandria University that's here with us. It's their second time competing in DBF. They were with us in Tucson last year. I want to have you introduce yourself and tell us a little bit about your aircraft.
Yeah, that's great. I'm Amr. It's my second year in DBF. Before DBF, we used to participate in SAE for several years. I'm the vice leader of our team. It's called 19th team from Egypt. We are the only team here from Egypt, so it's great representation for our country. So yeah, basically for our aircraft, we call it Phantom. So our aircraft is very Mission 2 focused, so it carries a lot of ducks, precisely 42 ducks, and it carries around 14 to 12 hockey pucks. So yeah, for our design, we focus for, as you can see, the fuselage is very large.
Yeah.
Yeah. Our motor, our thrust weight for Mission 1 is around 1.05, 1.1, around that range. So yeah, that's basically our design. It's very all made of wood basically. We all manufactured ourselves from every single board basically. We make it out of multiple types of wood and parts of carbon fiber, but of course it's very hard to get carbon fiber in Egypt actually. So yeah, we try our best to use the materials that we have to get the best result possible.
Fantastic. So today is banner day. You guys are going to fly a pretty big banner?
Yeah, it's
okay.
2 meters by 4. Yeah.
And who was the banner? Who was in charge of the banner design here?
All of us are kind of hands-on.
Everybody's hands-on.
Yeah, everybody's hands-on.
So you designed. You said you used some kind of computer simulation to put this thing together for how it's going to look. And
Yeah, and then we designed the dimensions, and we put on the design and everything. Some were responsible for the entire mechanism, and others were responsible for the design. We had some trouble with the design, and we fixed it last minute as well. But everything so far is good.
All right. Well, it looks like it's going to be a beautiful day out there. I wish you guys all the best. Thank you for coming all the way from Egypt.
Thank you.
This is it's special that you guys are here competing.
Yeah,
thank you. All right.
I don't know. Which one's the stabilizer?
Top of the remote, second from the right. Should be all the way up.
It's gauge for DOS.
What mission is this?
M1.
M1. Awesome.
Valid. Three laps. Sounds so simple. When they put the flag up, say flag or turn or something. Yeah. Must be cold too. Dude, bouncing.
No. Who you listening to? We have a truck out here.
Okay, welcome out here to the flight line. Once again, I'm EJ, a host here at the 2026 AIAA Design, Build, and Fly competition here. We're out here on the flight line where flights have already begun. We already got a plane teed up and ready to go. Right now we have Columbia University up, getting ready to fly here on the flight line. Let's see what they can do.
I was like, it's going to just time lapse all night long. Whatever, it's going to be a cool video of stars, right?
All right, ground crew's working with the judges. Photographer's got to get in place.
Right. I only have that issue with the sun.
All right. All right, so we're just waiting here momentarily.
Yeah.
Waiting for everybody to get in position. We got Columbia University flying their Mallard today.
Let me see here. Hey, Gage.
The winds actually aren't too bad today. We do have winds at our backs again from the commentary box, which means we got a crosswind on the runway. There's also been a couple of flights here before I actually got out to the flight line. It's a little bit of a walk from the hangar to here, but I did see a couple planes not land correctly, we'll say. It turns out that pilot lost the plane in the sun. The sun's a little bit low on the horizon. It's still a little bit early morning here in Wichita. So some of the planes got lost in the sun, and they
Good to go, Kevin.
found the grass. Now we say touch grass, but we don't want to touch grass like that.
The lens doesn't look too badly dirty.
Okay, so once again, Columbia University is just waiting here. We're waiting on the last team to clear, I think, and then once they're clear, we'll be able to fly. So we're flying the course in reverse to what we flew yesterday on day 2. The course is reversed, and it's the same track that we were running on day 1, where we're taking left-hand turns through turn 1 and turn 2 instead of right-hand turns. The reason why, like I said, is because the winds today are coming from the southwest. They're coming from the southwest across the runway. On the first day, on day 1, we had a very strong headwind coming from the south. And then on day 2, we had a headwind coming out of the north, and then that eventually, by the end of the day, trended westward. So it was north, then north-northwest, then northwest, and then by the end of the day, when we ended day 2, we had winds coming straight west. And now the winds seems to have gone south there. They're coming out of the southwest now. So if you can see the plane right now, it would be on the front right part of the plane. Recovery trucks from the last team that found the grass, that was WPI, I believe, making their way off of the runway for Columbia University and the Mallard to fly. Okay, ground crew's putting the fuse into the plane to arm the engine. Flight control surface checkout here. All right, pilot signal's ready to go, judges are ready to go. Okay, there we go. Up in the air, that crosswind's a little tricky on takeoff. But Columbia University's flying. Oh, turning around, that crosswind's tricky. Going through turn 1 and turn 2. Oh, doing a loop. Oh no. Oh, they recovered. They recovered. You still got it. Oh no. That crosswind got him. Like I said, winds are tricky today, very tricky. You got a nasty crosswind on the runway. Anybody that's favoring a lighter design or a lighter airframe, they're gonna get blown around. It's not what we want to see, but we gotta go get the recovery truck. It's turning immediately around, getting ready to go out and recover the plane. Okay, while the recovery crews are going out there and recovering the aircraft, we're gonna go back up to Clay in the hangar doing more interviews.
Hey, AIAA Clay here back in the hangar. We're here with the University of Tennessee. Kyle, tell us a little bit about your plane and what your team's do. How many times have you been competing here?
The team's been competing since I think 2017, but none of us have competed before.
Okay,
this
so
is
all
completely
first time.
brand new too. Yeah.
All right. Well, tell us a little bit about your design.
Yeah. So the plane, we just kind of want to put we tried to optimize for lift. Our prototype didn't fly, so we wanted to make sure we kept a whole bunch of wing area. We didn't want that to be a limiting factor. We didn't really have time to change it, so we were really trying to maximize for putting stuff in there.
Yeah.
And then after moving CGs around, we actually had to keep the engineering mind going. It was a tough time getting things placed. and making sure we could actually haul the weight.
How many ducks can you fit?
So we got 18 ducks and 6 pucks.
18 ducks and 6 pucks. All right, 3 to 1. Yeah. All right. And carbon fiber design here?
Yeah, carbon fiber. We got 1 layer on the wings. Most of the fuselage is only 1 layer because we had so many on the prototype and it weighed so much. We were like, let's just make this thing flimsy and patch it as we go. So we have reinforcements in different spots, like around the wing spar, where the wing connects, where the tail connects, and stuff like that. The rest of it, you can see it's actually flexing a little bit as they handle it. So we have to be very careful about it. But our plane only weighs about 11 pounds empty.
Now, do you guys drive out here? You fly out
We
here?
drove.
You drove.
Yeah.
All right.
We took a couple UT rental vehicles and drove all day on Wednesday.
Exciting.
Yeah.
Exciting. Well, like one word, what you describe DBF. How's it been?
Really challenging.
Yeah.
One word is challenging. I would say really challenging because we basically have a box of scraps in a basement room, and that's where all of us work. This is the whole team. I think we're missing one person right now. He's at Home Depot. Okay. So this is the whole team, and they're all working on the plane right now, and this is kind of how it works for us. So like we put in 12-hour days, we put in like 60-hour weeks, and this is like a senior capstone project for us more than it is a club. So we are managing our whole class load, taking tests and stuff like that. We'll finish the exam and then run straight to the room and keep working on the plane.
Oh boy, man, DIY aircraft.
It really is. Yeah. And like none of us have built a plane before, none of us has flown before. We've all taken like one class on how airplanes fly. A couple of them are AEs, a couple of us are MEs.
Okay, nice. All right. Well, hey, thank you guys for coming out.
Thank you.
We're glad you're here.
We're glad to be here.
All right, go Vols.
Go Vols.
Okay, welcome back to the flight line here. We're looking at the ducks here on the airplane. The next university that's up is the Hong Kong Polytechnic University, flying their Mission 2 flight. So they got cargo on board. And then while that's going on, we also have recovery operations from the last flight. Columbia did not had a result they didn't really want, I don't think. But plane looked to be relatively okay. But that's the beauty of this. They're RC planes. You can put them back together, and that shows the technical challenge. Well, actually, not the technical. It's more, I'd say, the more adversarial challenge there of this. Like you're fighting some adversity here. It's not easy coming out here on this runway, flying this plane around and doing these missions. But engineering's about improvise, adapting, and overcoming, right? So that's what they're going to do. Okay. Once again, the next team up is Hong Kong Polytechnic University, team number 60, flying the SLDPK. Okay. Okay, ground crews are in position, pilot is in position, observer is in position. Once again, each team is only allowed to have 3 people out on the runway, actually. So the team has to be able, the rest of the team has to be able to watch from the spectator booth. They only have 3 people out on the runway. You can only have a pilot, a ground crew, and an observer. And right now, Hong Kong Polytechnic University's, they've opted to reverse direction here and fly the course clockwise instead of counterclockwise, turning the plane around 180 degrees. Once again, we have a nasty, nasty crosswind today. Which means there's winds blowing across the runway, crosswind, right? That makes flying a little bit more tricky than we've had over the last couple of days. The last couple of days we had winds coming out of the south. Now this runway that we're on goes north-south, more or less. And the winds have the last 2 days, except for the very end of day 2, the winds have been basically aligned with the runway. That makes for headwinds and tailwinds. Tailwind's a little bit of a tricky thing. Headwind is what you want. Airplanes, these RC planes and real life airplanes want to go into the wind. All right, we have the clear from the judges to go. Last team has moved. Hong Kong Polytechnic arming the plane, the observers vacating the runway. Okay. Engines are on. SLDPK is up in the sky here. Once again, they've opted to fly the course clockwise instead of counterclockwise, so it was a reverse to the last flight that you've seen here. All right, so once again, they're flying mission 2. This is their cargo mission. They got over 60 ducks on board. This is 3? They have 3 ducks on board? Okay, 3 ducks and 1 puck on this one on board. All right, doing the 360-degree turn. So Hong Kong Polytechnic University has opted for the 3 and 1. So they are actually carrying three ducks and 1 puck. That's the minimum cargo requirements, but minimum requirements aren't necessarily a bad thing. There's no upper limit to, there's no maximum requirement for the amount of ducks and pucks that you can carry, but you can make more money if you carry more cargo. Just because they're not carrying a lot of cargo here doesn't mean they're not finding other ways with the plane to make money. Once again, the DBF challenge is all about finding trade-offs. You know, where do you want to put all your ducks? Do you want to put all your ducks in one basket or another? Or on your plane? It's up to you. That leaves the competition pretty open-ended, and that allows for a lot of different designs. A lot of teams will go about approaching this very, very differently than others. Okay. Hong Kong Polytechnic negotiating that crosswind very well, very well. Going into turn 1. Turn 2. Now this is a cargo mission. This is mission 2. They're moving ducks and pucks. And the idea here is to do as many laps as you can in 5 minutes for the cargo mission. Plane coming around, back over the runway out of turn 4. Flying very straight, very nominal flight there. Okay, 180 degrees through turn 1 and turn 2. Leveling off. Everything's looking real good, and it's as I was saying on day 2 yesterday. This is the idea. This is ideal. This is what you want. You want no news here. You want a nice, smooth flight. That seems to be what we're getting here from Hong Kong Polytechnic University. Teams calling out how many laps have been done. You can hear that through camera mic. Once again, the whole point of mission 2 and mission 3 is to see how many laps you can do in 5 minutes. Now, mission 1 is just a flight test requirement, as we've seen over the past couple of days. Mission 1 is just doing a flight test. You do 3 laps, but you have 5 minutes to do 3 laps. You got to complete it in 5 minutes. Mission 2 and mission 3 are really about seeing how many laps you can do with cargo, and later, when we see mission 3 flights later in the day, a banner. All right, great flight here from Hong Kong Polytechnic University. Plane's cutting perfectly through the air. They're still going to have to negotiate that crosswind on landing, but the flight thus far for them is going very, very well. Once again, the ground crew's communicating, the observer communicating to the pilot how many laps he's done there. Okay, coming in for a landing. Hong Kong Polytechnic negotiating that crosswind beautifully. Beautiful touchdown there. SLDPK back down on the ground in one piece. Okay, very good. So as that plane taxis back over to the runway, I'm actually going to toss it back over to another hangar interview with Clay back up in the hangar. So take it away.
Hey, I'm AIAA Clay. I'm back here in the hangar. I'm here with Embry-Riddle Aeronautical University. By the way, I think the only team with aeronautical in the name, maybe, that's here in the competition. These guys are the Daytona Beach edition of Embry-Riddle. We have two teams here. But this is an amazing aircraft. Wadi, why don't you tell us a little bit about what you got here?
Yeah, so this is APR. It stands for Platform for Economical Release and Yank Towing. We have designed it to be optimized for maximum payload and to tow the biggest banner possible as efficiently as possible. We went with a conventional design because it's been a tried and true.
And named after the famed platypus of TV fame?
Named after APR, a platypus from Phineas and Ferb. The name came about because when we designed it with the wide fuselage, it looked like a platypus, and APR just fit right in.
That's fantastic. So how many people on your team here?
So we brought 28 people with us.
Wow.
Back home we have upwards of 200 members, so quite a large team. And
did you guys drive? Did you fly? How'd you get in?
A lot of us flew here, and then we...
Look out behind. Plane coming through.
A lot of us flew here, and then we had a small team drive the plane here,
nice.
So we could bring extra backups and parts as well. So it's been a blast, and I'm really proud of every individual that has helped with this project.
That's fantastic. So a big shout out to the Embry-Riddle students back home that are watching on the live stream. This is an amazing design, maximized for bucks and ducks. The banner, how big is the banner you think you're gonna tow today?
Our banner is a couple of feet long.
Yeah?
Yeah.
All right. All right, well, hey, thank you guys for coming. We're happy you're here. They told me some stories about helping out the other teams. That's the spirit of DBF. Thank you guys for being a part of it.
Thank you so much.
Cool.
Okay, we're back here on the flight line where the University of South Alabama with their JAG airplane, team number 59, trying to do mission 2, is having a little bit of trouble negotiating that crosswind. They did have a little bit of trouble on takeoff, but they are on the clock, so they're going to keep going. Oh no. Oh no. That's not what we want to see. Well, they tried. That, once again, that crosswind is, it'll get you on takeoff and landing here. Plane is safed. Looks like I love the tenacity here. There we go. University of South Alabama putting Jag Air on the runway for a third takeoff attempt. Let's go. Let's go.
I can't have you work on it this way. Okay, you can't work on it. Angle it a little further right. Angle it a little further right.
They're having a little bit of trouble out there on the runway. You got it though. We got it. Third takeoff. It looks like they might have a little bit of trouble with a bent landing gear, from what I can tell. Maybe a stuck control surface or a stuck control gear or something. That plane wants to go fast and turn left, and that's about it. It's not a bad thing, but let's see. Are they going to throw in the towel? Or are they going to try again? Oh, I think they might be done for right now.
At least it's not a pile of bunch parts.
All right. Hey, good try, dude. Good try. You'll be back.
Yeah.
There you go. Once again, that was team number 59, University of South Alabama with Jag Air, having a little bit of trouble trying to get the plane up in the air, but plane seems to be okay. It's still in one piece. The plane is still in one piece. Now, I have Chris Horton back here with me.
Morning.
I have Chris Horton back here. Yeah, morning. How are you?
Good, thanks. How are you?
Good, man. We're on day 3. Who do we have next?
Up next is Team 61 from San Diego State University flying their plane Hutzlin. And they are on mission 2 with 3 ducks and 1 puck.
Another minimal requirement one. Okay. All right, Hutzlin's out there on the runway. San Diego State going for mission 2. Okay. Putting the arming fuse in. Once again, this is team number 61, San Diego State University, with their Hutzlin airplane, flying their mission 2, cargo mission 2. Right, trying to negotiate that crosswind, tails bouncing a little bit, but Hutzlin gets up in the air. Once again, they're choosing to fly in the counterclockwise configuration of the racetrack, which is basically just reversed from the way we've seen before. Now they're flying their cargo mission. The objective here is to do as many laps as you can in 5 minutes with your cargo on board. San Diego State's opted for the minimum requirements for cargo, which is 3 rubber ducks and 1 hockey puck. I'd like to add, for those mission 2 requirements, the minimum is 3. You have to carry 3 ducks and 1 puck, but you can carry as many as you want. I actually talked with the judges between day 2 and day 3, and this competition is about getting paid. It's about getting paid. If your plane can move more ducks, that's more paying passengers. If your plane can move more cargo, you get paid more. But that doesn't necessarily mean that that's the place where you want to make money. You could make money towing banners. You could make money moving passengers. You could make money having a plane that is easier to load and unload. It really comes down to the team. It's kind of open-ended, and that's entirely on purpose in the rules. It's kind of open-ended to see, you know, where these teams are going to put all their eggs in their basket, or ducks, I should say. Ducks, eggs. I mean, they're moving ducks, so we'll say put all your ducks in one basket. I think that's right. Which came first, the duck or the egg? That's the real question. It's a question for the ages. I'm sorry. San Diego State doing a great job with Hutzlin flying in the air on their mission 2. The winds today on day 3 are not nearly as bad as we had on day 1 and day 2. But we do have a crosswind, meaning the wind is moving across the runway. And moving across the runway doesn't make necessarily for bad flying conditions, but takeoff and landing is definitely going to be a challenge for these teams. We've seen several teams struggle with it this morning, as the winds seem to be coming out of the southwest here. But once again, below 5 knots, I'd say. It's not very high. Getting some slight gusts. It is a little breezy in Wichita. That's what I'm coming to understand from some of the locals around here. It's windy, a lot. And sometimes that makes for good flying conditions, sometimes it does not. But I would say we're erring on more of the side of good flying conditions today with how San Diego State's flying through the air with their Hutzlin plane here. Doing the 360-degree right turn because they've opted to fly the reverse course. Once again, the objective of Mission 2 here is to see how many laps you can do with cargo on board. Okay. Now, San Diego State with Hutzlin, I did say this before when we saw them fly on a previous day, they have a fuselage on their plane that's very, very long. That means their horizontal stabilizers and their vertical stabilizers are really, really far away from the center of gravity of the plane. And if they're further away, you're going to get a more stable flight. It's going to appear to fly nice and straight through the air. That also means that your control surfaces, the things that you need to steer the plane, are further away from the center of gravity, so they have more effective control moment, is what it's called. And it's making that plane fly beautifully through the air. Yeah, if you look at Hutzlin flying, their wings forward, main gear forward. Once again, all your vertical stabilizer, V-stab, and horizontal stabilizer, H-stab, are as far away from the center of gravity of the plane. If you think about it, it works kind of like a lever. You know, Archimedes said, you give me a lever big enough, I'm going to move the world. Well, they have a lever big enough to fly that plane around very, very easily. Judge's timer's going off here, completing the last lap. Now, San Diego State University with Hutzlin is going to circle around and come in for a landing. Once again, this is going to be a little bit tricky with that crosswind. Let's see if that long fuselage is going to pay off for them with this landing. Circling around, aligned with the runway. Oh, there it is. There's the crosswind. Come on, come on. One bounce. Feathering the throttle. But they bring it down. Excellent. Terrific. That was not an easy landing, but they did it. SDSU completes Mission 2 with Hutzlin. Great flight. Chris, you're back with me.
Back with you.
Who do we got next?
Coming back up next is, I've just lost my place. Team 62 with West Virginia University with their Golden Goose plane, and they've got 39 ducks and 2 pucks on Mission 2.
Okay. So that's Team 62. Okay. West Virginia University flying Mission 2 with 39 ducks and 2 pucks. All right, teams are moving out to the runway now as one team, as San Diego State with Hutzlin moves off. We got the Golden Goose with West Virginia University getting ready, staging on the runway for flight. Remember, the challenge here with Mission 2 is to fly as many laps as you can with your cargo aboard. Teams cheering on their teammates in the staging pits behind us. Okay. Golden Goose takes to the skies, negotiating that crosswind on takeoff perfectly. They've opted to fly in the track in the counterclockwise configuration. Circling around through turn 1. Golden Goose flying beautifully through the air. Oh, there seem to be some upper level winds up there. But the Golden Goose straightens out, going through turn 3 and turn 4, back onto the main straight. Once again, that crosswind gets pretty hefty. When you're going through the straight parts of the track, it's going to blow the plane left to right. So you might see these planes induce a little bit of roll to counteract that crosswind pushing the vehicle around. Circling around through turn 1 and turn 2. West Virginia University's opted for, as Chris was telling me, 39 ducks and 2 pucks. That's a lot of ducks. Little short on the cargo though, but to my knowledge, if I'm understanding these rules correctly, you can have as many ducks as you want, but you have to have at least 3 times 3 ducks for every 1 puck, but there's no limit on how many ducks you can carry. I'm getting a nod from Chris, so that means I'm in business. All right. Once again, the golden goose flying perfectly. And the reason why I bring up the point of West Virginia University with golden goose flying perfectly is that, you know, there's, like I said, 39 ducks on board, 2 pucks. That, you know, you wouldn't think about it, but for a plane this size, that's actually a lot of extra mass to move around. And more overall mass in your plane design is going to affect how the vehicle can fly. It could even potentially shift the center of gravity of the vehicle around. And shifting the center of gravity will change your flight characteristics. I was talking about a previous team, how their control surfaces were far away from their center of gravity, giving them more moment, more control moment. If you add cargo to it, that could potentially shift your center of gravity backwards and give your control surfaces less control authority. That doesn't seem to be a problem here for West Virginia, though. That golden goose is flying beautifully through the air. But that is something that's going to change the flight characteristics of the vehicle. And then obviously when we get into mission 3 later, you know, you deploy a banner out the back of the plane, that's definitely going to change how the plane's going to fly. The whole idea of DBF is to induce, have these planes fly conditions that are going to make them they're going to make them tricky. It's supposed to be a tricky goal, and you know, the idea is to really flex those wrinkles in the brain to see how you can overcome these practical aviation problems. Okay. West Virginia University with Golden Goose circling around for a landing here. Let's see how the pilot negotiates. See how this pilot negotiates this crosswind here. Circling around for a heading alignment with the runway. Feathering the throttle. Perfect approach. Rotation. Oh, that was nice. Great landing. What crosswind? You don't know nothing about no crosswind. Okay, and as West Virginia University lands their Golden Goose, I'm thinking we have an interview up in the hangar. So we got another interview with Clay up in the hangar, and we're gonna head back up in that direction to get that.
Hey, AIAA Clay, I'm back in the hangar. This time I'm here with the team from UCLA, the Bruins, the Flying Bruins. We have Peter here, who's the chief engineer for their team. Peter, why don't you tell us a little bit about your aircraft? It looks like it's built for speed.
Sure, absolutely. So this is Duck Duck Goose. This is our airplane this year. We're definitely one of the teams that's doing the 3 duck strategy. So kind of our big strategy for this year is that we're really focusing in on that ground mission, trying to get as low of a time as we can. And to accomplish that, we actually took the minimum payload possible. We took 3 ducks. We took only 1 puck. And we're actually going up for our next ground mission attempt very, very soon. We're up in about 15 teams or so, in about 10 teams. So that'll be very exciting. A big part of our score really hinges on that. So that was kind of the vision. And then of course, with a smaller fuselage, a more streamlined airframe, we're also able to really focus in on mission 3 as well. We're able to show a large banner, minimize the drag all around, and that's sort of what we're hoping to accomplish as well. So
interesting design philosophy compared to like USC and Argentina, where they went for maximizing the ducks in the wings or in the blended wing body. Ljubljana and you guys are taking this more approach for speed.
Yeah.
You know, Fury ground work here. So really interesting to see. So this is a carbon fiber structure here. Tell us a little bit about the design.
Yeah, that's right. So again, we always try to balance weight. We try to balance strength all throughout the fuselage and the rest of the airframe. Our fuselage is made up of wet carbon fiber layups that we do ourselves. We have 3D printed molds, and then we press the carbon fiber into it in 2 halves at first, and then we mate the 2 halves together along the center line. The wing itself, we buy a commercial off-the-shelf carbon fiber spar that's sort of the main flexural structure throughout the wing. And then we string wooden ribs down the quarter-wise direction and then put monocoat all across the top to sort of create this nice smooth aero surface.
It's beautiful.
Going over the top.
You told me you got a pretty big team here. Tell me about the team and how you guys got here.
Yeah, 34 people.
Wow.
So it was definitely, it's the biggest team we've taken ever. For many, many years, we had a team of about 10 to 15. Just last year, I think we went up to 20, then 25, and then now we totally blew up to 34. We have plenty more people back home as well, supporting us still from UCLA. But it definitely was a huge logistical challenge. Our admin team is super great. They've been working for months, organizing all sorts of housing and cars and all that. Many meetings that they took with our school representatives to sort of get all that sorted out. Many emails sent back and forth. So huge props to them for getting that sorted. About half the team drove here, so we had about 4 vans come out.
Wow.
Huge, 24-hour sprint all the way from California in one go. Pretty much taking shifts, doing all that.
That's part of it. That's the spirit.
Yeah, absolutely. It's the fun.
All right.
And then the other half of the team just flew in on Wednesday as well.
Fantastic. Well, this thing looks great.
Thank you.
Hey, by the way, congratulations on the women's basketball national championship.
Yeah.
National championship winners, UCAA.
Yeah.
Well, hey, good luck out there. We'll see how you do with this banner, but top 10 team.
Hopefully.
All right. So UCLA, there you have it.
Yeah. Thank you so much.
Okay, welcome back down to the flight line here where we have, Chris, who do we have? We have Team 63, right?
That's right. We've got Team 63 from Missouri University of Science and Technology flying their plane Pelican, and this is mission number 2 for them. They've got 24 ducks and 8 pucks.
There we go. There we go. Plane is already in flight here as we come back from that interview up in the hangar. So we have Team 63, the Missouri University of Science and Technology flying Pelican here. They have 24 ducks and 8 pucks on board. They actually have one of the more interesting designs that I've seen here. They have contra-rotating propellers at the front of the plane, meaning that there's 2 propellers up at the front. One is spinning counterclockwise, the other one is spinning clockwise right behind it. Now, why would you opt for that? Well, I mean, one, it's kind of cool. All right, it's kind of cool. I've talked to a couple of teams out here, and I've asked them why, what drove that design decision? They said, well, because it looks cool. I'm like, yeah, okay, that's fair. But what a contra-rotating propeller does in aviation is, well, there's a lot of technical mumbo jumbo behind it, but the idea is that one propeller is basically feeding the next propeller. It's breaking the air for one and feeding it into the second propeller, so the second propeller can actually force more air through the whole system, right? You end up getting more thrust from this. You do need a little more powerful engine, but you don't need as powerful an engine as if you had just 2 propellers. So if you had 2 engines, 2 propellers. This is 1 engine for 2 propellers. It needs to be a little bit more powerful to move those, but there is an advantage there. Your second propeller can generate way more thrust if it's right behind the first one. The other benefit of a contra-rotating propeller design is that you don't get a lot of gyroscopic precession from the plane. When one propeller is spinning, right, it creates angular momentum and what makes the plane want to roll. You don't have that problem with this type of plane with 2 propellers. The 2 propellers are basically, the gyroscopic forces are canceling each other out. And it makes for a nice stable design. I actually didn't talk about this when they flew Mission 1, but that is another benefit here. Okay. Missouri University Science and Technology, bringing the Pelican in. Perfect rotation, 2 gear touch, nose gear touch. Great flight. Great flight. The contra-rotating propeller. Spinning around. Oh man, that is definitely something to see. Look at that thing. That's cool. Plane's taxiing over towards us. Oh, he even went onto the taxiway. Nice flying. So once again, that was Team 63, the Missouri University of Science and Technology, flying their Pelican for Mission 2 with 24 ducks and 8 pucks. as they get off of the runway. I'm going to go back over here to Chris Horton. Chris, who do we have coming next?
Coming up next is Team 64 from the George Washington University, flying their plane, the GW Bush. This is mission 1 for this team. They got a late start.
Okay, mission 1. So we're doing a test flight now. Team. This is a test flight. Yep. This is mission 1 here for George Washington University with their plane, the GW Bush. Once again, that's Team 64, George Washington University, getting ready to fly on the runway. Now they have an overhead wing design here, engine up at the front, main gear up at the front as well. It looks like the airfoil design that they're using on their main wing does have a lot of downward deflection. This plane should generate a lot of lift at low speed with that airfoil design. Airfoil, if you're not into the technical jargon, what that means is the shape of the wing if you were looking at it from the side. All wings tend to look like a teardrop, but it's kind of a bent teardrop. The idea is that you want to make low pressure on one side of the wing, high pressure on the other side of the wing, higher pressure under, lower pressure over. That's Bernoulli's principle. That's how these planes generate lift. And if your airfoil kind of is more, your teardrop, so to speak, is more bent, you're going to generate more lift. But there's always a trade-off here. You'll generate more lift at low speed, but you generate more drag at high speed with that kind of design. Okay, arming fuse is in. The engine is working.
Anywhere you're comfortable. Okay. I like that.
If you really take a look at that side wing on the GW Bush there, it's going to create a lot of lift. We'll see. We'll see if it pays off for them. Once again, this is a test flight for this airplane. Okay, pilot says he's ready to go. There we go. We got the engines on there. GW Bush negotiating that crosswind. George Washington University is in the air for their Mission 1 flight. Just a little quick update on Mission 1 flights. The Mission 1 flights are timed, but it's not like Mission 2 and Mission 3. It's not about how many laps you can do. With the Mission 1 criteria, it's just a test flight for your plane. They got to do 3 laps around the course. And if you look at that plane flying around, it looks like it's kind of lumbering. Like I said, that's intended. That is what they're going for. Low speed with that wing is going to generate a lot of lift. We'll see when, but if they get back for Mission 2 and Mission 3, we'll see how much cargo they're going to move here with this plane. With that wing design, it's going to be able to generate a lot of lift. But not a lot of speed, but that's okay. If that's how you want to do this, you want to generate more lift, you want to move more cargo around, that's okay. It's all about the trade-offs. It's all about where you choose to score points here. There's no really wrong way to go about solving these problems as long as the plane comes back in one piece. Once again, that plane flying beautifully around the track. Coming up into turn 3 and turn 4, combination of those turns is a 180-degree turn back out over the runway. Okay, George Washington University on their first flight here. Okay, this is their 3rd lap. They're going to do a 360-degree right turn. All right, circling around 180 degrees through turn 3 and turn 4. To complete their 3rd lap.
Hey, AIAA Clay here. We're back here in the hangar. We're doing the ground portion of this competition. I've got Ferris here with me from Virginia Tech, the Hokies. They're getting ready to do the ground piece of this. You want to tell us a little bit about what we're about to see?
Yeah, so this is our ground mission for this plane. So this is basically we're getting the plane in and out of configuration as fast as we possibly can. So we're going to start off with loading our passengers and cargo, which we can see with this top hatch. We're going to have all of our passengers loaded in, and we got 2 bottom bays for our cargo.
And how many ducks can you accommodate?
We can carry 48 ducks and 13 hockey pucks.
All right.
And then.
And for flight missions, did you get through mission 2 yesterday?
Yes, we got through a successful M2. We flew 5 successful laps and landed pretty nicely. So we're hoping for a good crack at M3 later today.
How many people you got on your team here?
We have 19 people plus our advisor here today. So shout out to Dr. Saragini.
All right, very good. And I guess you guys got the award last year for like best comeback?
Yeah. It was M3. It was a bit of a struggle. We had 3 whole attempts on M3, and we were finally successful on the 3rd one on the last day of flight. That was a very, very exciting moment for the team, But I'm glad to be back. This is what we're here for.
And how did you guys make the trip out from Blacksburg?
Oh, by road.
By road. Everybody?
Yeah, everybody by road.
A couple of vans?
Yeah, we got 2 big old vans and a truck with the trailer to tow the plane and everything else.
Oh my God! All right. Yeah. And big support back on campus?
Oh yeah, we've had a lot of, not even on campus, all of our, we have a lot of family members here, so shout out to them.
I see some moms and dads in the crowd here.
This has been a huge turnout for family support this year, and it's been great. It's been really helpful. We wouldn't be here without them and all of the people back at campus supporting us.
That's awesome. That's awesome. Now I see like the ducks are different shapes, sizes, form factor is a little bit. So how do you accommodate that inside the fuselage?
Yeah, so part of our design was trying to get a one-size-fits-all kind of thing, right? Because typically in previous years when they've done these kind of passenger missions, they're very uniform, so you can kind of make one very simple system that accommodates all of them. But this year it was kind of a struggle to make sure that we're able to fit all of the unique passenger dimensions. So in our passenger cargo bay, when we open it up, there'll be little what we call egg carton trays, right? Not every egg is the same size or shape, so we figured, hey, let's slot them in longitudinally, and then on the top there's some foam that holds them in place.
Okay, here we go. We're getting ready to go. Ready?
Just ducks and pucks. 3, 2, 1, go!
So Zach's going to start by opening up all of our doors, and he's going to load the hockey pucks in our main tray. This is where the majority of our cargo is stored, and we're going to put one in the back after he loads this in. Though you'll see as we're doing the whole ground mission, he's going to do back and forth sweeping so that we're trying to minimize the amount of movement that we do back and forth across the plane.
And those go into compartments there under the fuselage?
More on this side. They're in the bottom half of the fuselage.
And then the ducks go on top?
Yep, right on top.
And you guys practice this many times?
Oh, so many times, yeah. Many late nights trying to get the different methods of opening the door down and all that kind of stuff. Optimal passenger placement,
technique.
Technique. Honestly, it's a matter of just being consistent, because if you go too fast, you're going to mess up the placement of a duck, and it's going to mess with the hatch closing, and if you knock one loose and you got to go get it, that's just time lost. So we decided that it's better to be more diligent about the duck placement and that kind of stuff. Yep.
Wow, that was amazing.
Yeah.
Woo!
I just didn't know what banner. Anywhere you want. Ready?
Taylor's our judge here. She's a pro at this. She's a DBF veteran and on our organizing committee. She does an amazing job.
Oh yeah, we've been chatting her up during the competition. It's been a pleasure talking with her.
She spends a lot of time and energy on this event. We're very pleased to have her.
Yeah, no, we are very thankful to all the volunteers that come out and help with this event. Obviously it wouldn't happen without them.
Yep. And that was fast. That was very fast.
That was very fast.
Pucks in?
Yep, pucks are out. Now he's going to work on getting this banner system installed. He's going to just shove it right into that little cloth that's going to be part of the release mechanism.
Mm-hmm.
The tricky part about this is that... Wow.
Woo! Yeah! Dude. All right.
Now this is the scary part. if this banner don't drop, release and then drop.
Slightly this way, so we can get the right. Okay. All right, just Floyd.
There's a servo wire loose.
Uh-oh. All right.
Let's go! Yeah.
Well, there you have it, Virginia Tech. Great,
Come here.
great ground mission. Dig. Let's get a little post-game interview.
Okay,
How was that? That was incredible.
That was awesome. I think it might be my fastest run ever. All the
Really?
time. Yes.
The unload was sick.
Yeah.
Yeah.
What was the time?
I have no clue. I'm too excited.
Oh man, that was beautiful.
Yeah.
That was beautiful.
Oh,
you have any family here?
I do. My parents are here. Shout out to them for coming out. Oh, this is my
Oh, there we go. This is proud mom.
She supports me on everything, so I really love her for that. Thank you so much. And thanks to all of our teammates for helping me throughout the entire competition. They were out there with me late at night practicing, so shout out to all of them. It's not possible without them.
Well, fantastic. Well, thank you. That was super impressive.
Thank you.
Yeah, really one of the best I've seen here.
Thank you, everyone.
All right.
Thank you so much.
All right, that was good. Thank you, Virginia Tech. Hokies, good luck out there today.
Yeah. Thank you, guys.
Welcome back down here to the flight line of the 2026 AIAA Design Build Fly competition. I'm EJ, sitting down here on the flight line, commentating on all these teams, doing the different missions. Now, we just had James Madison University come up with Duke Doggernaut carry. There was their mission 2 with 12 ducks and 4 pucks, but unfortunately, they seem to maybe have a control surface problem, or I don't know if the crosswind got them, but the recovery crews are out, needless to say, at this point. Now, the next team that we have coming up here is team number 66. It's the University of Sydney with their Project Humpback plane. They're doing mission 2 here, moving 48 ducks and 14 pucks. I was talking with Chris Horton a little bit earlier, and he was telling me that this is one of the missions that have the most amount of hockey pucks. Chris, you're with me now.
Yes.
How many, is this the most you've seen?
This is the most I think I've seen. That there's 14 pucks on this plane with 48 ducks.
That's a lot.
That is a lot.
That's a lot of extra
payload.
A lot of extra payload for sure. Thank you. Yeah, it's definitely going to be interesting, because once again, like, you don't think about a hockey puck being that much. You don't think about a hockey puck being that much extra weight, but it is, and it definitely affects how the plane's going to fly. Now, Project Humpback is actually getting ready to go out on the runway. Ground crews are arming the plane. The arming system is to activate the engine, to make sure that the engines aren't activated anywhere else but on the runway. That's one of the rules. You have to have a blade fuse to activate that. Okay, ground crews are moving away from the vehicle. Pilot is ready. Testing the engine, making sure the engine works. Project Humpback here is a tail dragging design, very long fuselage. So once again, that long fuselage going to make for a lot of stability. With your control surfaces and your stabilizers, your horizontal stabilizers, 2 on each side, and your vertical stabilizer on the top, them being further away from the center of gravity of the airplane is going to make the plane easier to control. Essentially works like a lever. There we go, Project Humpback negotiating that slight crosswind that we have. Once again, pretty much every team now opting for the counterclockwise rotation of the track here. All right, now they are on mission 2. University of Sydney is on mission 2 here, and what that is a cargo mission. We said a little bit earlier when I was talking with Chris, they have 48 ducks and 14 pucks. Now the objective here for mission 2 is to do as many laps as you can in 5 minutes. So you have to balance that weight of that cargo. You're putting all that cargo in there, the plane's gonna lumber a little bit. It's probably not gonna go as fast unless you have the propulsion, right? That all feeds to the design trade-offs that you get into with a competition like this, with a DBF competition. Project Humpback negotiating those winds, the crosswinds up there. There's a little bit of winds up there. They've gotten a couple of planes. We have a crosswind down here on the runway, but seems to be negotiating pretty well for 48 rubber ducks and 14 pucks. They're doing quite well. And of course, this is mission 2. Mission 3 is doing the same type of flying, but towing a banner instead of cargo. A banner will create all kinds of drag behind the airplane. We'll see how these planes fare with it. And then, of course, if you've been watching for a little bit, you've been seeing Clay up in the hangar. Clay Morey, the CEO of the AIAA, actually doing interviews with these teams and showing their Mission 4. Mission 4 is a cargo loading mission, for people that don't know, where you have to load and unload. You load your ducks, load your pucks, unload your ducks, unload your pucks, and then reconfigure the plane. Reconfigure the plane for Mission 3, loading and unloading being configuring for Mission 2. You have to change the configuration of the plane, and that counts for a lot. And that, once again, is driving the requirements here for these planes. They do leave it open-ended to an extent, and that allows for a lot of diversity of ideas. It's very interesting to see how the different universities attack these problems. But for the University of Sydney here, this team number 66 with Project Humpback, they are doing their cargo mission here, and the objective is to fly as many laps as you can around the track in 5 minutes. Obviously, if you can move more cargo faster, you get paid more. And that's the objective of this competition. That's how the winner is going to be discerned. Who can make the most money off of these missions? Ground missions, loading and unloading cargo, flight missions, flight tests, towing banners around so people can see them. That's all the things that you're going to profit from if you operated a small bush plane in real life. And that's the whole point, to simulate real life conditions here, to give these students the tools that they need to succeed when they get out into the aerospace industry. This also, we were talking about trade-offs. This also goes over a lot of systems engineering principles here. The systems engineering principles basically figuring out the rules, the rule set for what you're building, figuring out what you need to do, why you need to do it, and then incorporating that into your design. So, on top of hands-on experience, real life flight characteristics, just because it's a remote radio-controlled plane doesn't mean it's not flying like a regular plane would. Same conditions, same atmosphere as far as I can tell. We're not on Mars as far as I know. So you get introduced to systems engineering, a lot of aerodynamic testing, and a lot of design decisions. And that's ultimately how this works when you get out into the industry. These students, it gives great hands-on experience for the students with this. Project Humpback going through turn 1 and turn 2, circling around, 360-degree turn on the back of the track. Now, because they're flying in the counterclockwise direction, it's a 360-degree right turn, as opposed to 360-degree left turn if you're flying clockwise. All right, that prop up there stopped spinning there for a second. I'm not sure if that was a loss of control or what. The timer is up. Yeah, it may have been the wind. Yeah. So, University of Sydney circling Project Humpback around for a landing. Okay, coming around. Aligned with the runway. Engines are off. Good touch, couple of bounces. Project Humpback, down back on the ground with the 48 ducks and 14 pucks to its destination. Taxiing back on the runway. Great job. University of Sydney is definitely going to be happy with that flight. Okay, as they vacate the field, Chris, who do we have next?
Up next, we've got Team 68 coming from Rutgers University in New Jersey and New Brunswick, flying the Dragonfly, and this is Mission 1 for them.
Okay. Mission 1 for Rutgers here as the University of Sydney vacates the runway. Rutgers coming back on here. We've got cheers from the crowd there. I got it.
Yeah, we were at 116.
Yeah, no, I was like.
Now Rutgers seems to be opting for a biplane here. We did talk about that a little bit earlier.
That was them yesterday. They didn't fly though.
Yep. Yeah, Chris was telling me that they did get out on a runway attempt yesterday, but I do remember now they had some problems with that nose gear. Okay, once again, this is Team 68. This is Rutgers flying the Dragonfly. This is a Mission 1 flight for them. So the Mission 1 flight is just a test flight where you have to do 3 laps around the track. Okay, ground crews. Ground crew and the pilot figuring out where they want to position that plane. Once again, if you're just tuning in, first of all, we certainly appreciate everybody watching on the AIAA YouTube channel. Shout out to the chat over there. Thank you very much for watching. We do appreciate it. And then over on the Twitch stream, what's going on, chat? How are you guys? Hopefully you're enjoying this. It's a good time. This is really fun. This is a test flight for Rutgers here, but yeah, shout outs to everybody that's watching out there on the internet if you couldn't make it out here, out to Wichita. This is a fun time, this is great. I love watching these planes fly. Okay, ground crews have armed the plane, the engine is on. Once again, this is Rutgers, Team 68 with the Dragonfly. Rutgers opted for a biplane design and she's in the air. They didn't get off the ground yesterday. They had some trouble with the gear, so we didn't really get to see this plane fly, but now we are. And it is flying good. Going through turn 1 and turn 2 on the back stretch of the track, 360-degree right turn. Now with a biplane design, you got 2 wings stacked on top of each other. The idea is that you can lift more with a smaller surface area. That was a very popular design at the dawn of aviation. Actually, even into the golden age, about 100 years ago. Right when some folks came out here to Wichita and decided they wanted to make planes and made it the aerospace giant that it is now. Dragonfly is performing great here. It's into lap 2, 360-degree turn. Now that biplane is going to generate a lot of lift. Those wings are going to really keep that plane up in the air. And they've opted for a tricycle. Yeah, it's a tricycle landing gear there, meaning the center of gravity is about amidships, so to speak. Center of gravity being more halfway down the fuselage, meaning that you need a little bit of a bigger stabilizer to keep that thing flying straight. Note the larger stabilizers and control surfaces on the back of the Dragonfly. You know, a lot of people wonder, like, okay, why don't they make those anymore? Is it because it's a bad design? No, not necessarily. You get a lot of benefits with that. I mean, physics doesn't care if the wings are on top of each other, as long as they're far enough away not to disrupt air. And it very clearly is not with Rutgers playing the Dragonfly here. You can generate a lot of lift. Physics doesn't care if the wing is one's on top of the other. Once again, as long as they're out of the airflow, you're fine. You can even have asymmetric wings or a crooked wing. There's all different types of designs that you could do. NASA actually proved that with their AD-1 prototype plane, which had what's called an oblique wing. It's a wing that's diagonally across the fuselage. So just because the wings are on top of each other doesn't mean it's a bad design. Coming in for a landing. Oh! Hey, she's down in one piece. That's all that matters. Rutgers completing their Mission 1 flight with Dragonfly. Okay. Ground crew's going and safing the plane. Chris, you're back with us. Who do we got?
Up next is Team 70 from the University of Alabama in Huntsville, flying their plane Manta Ray, and they're on Mission 1.
Okay. Wait, judge is holding up Rutgers here. So, Chris, you said
Team 70.
Team 70, got it. Okay. Okay, so we have University of Alabama, Huntsville. It's Team 70 putting their plane out on the runway. Now, this is a very, very interesting design that we got here. They have a twin engine design, but an inverse V-tail on that plane. Meaning you have twin fuselages going backwards and then two rear wings pointing 45 degrees inward at each other. I don't think I've ever seen a reverse V-tail like that. But very interesting design. Now they have two engines. The engines are wing mounted on either side. And then the fuselage is in between them, but the fuselage splits into two back to that inverted V-tail. I'm not even sure if that's the right way to say that. Okay. Fuses in, arming the engines. The arming system needs to be activated by a fuse per the rules. And that is to make sure that nobody has their engines working, you know, when you're in the hangar, where Clay is doing those great interviews. You don't want engines going off in there. You don't want to generate thrust in there. It's a spinning propeller. So they have arming fuses that they put on the plane to make sure that the engines can only work when it's out on the runway or in our staging pits behind us. There we go. University of Alabama, Huntsville, flying their Manta Ray up into the sky. This is Mission 1 for them. Now they have opted once again for a tail dragger design, meaning their main gear is up at the front of the wing and their steering gear is actually underneath the inverted V-tail on their twin fuselage. There's actually two rear gears back there. Having the engine so far forward, the twin engine design on this is actually forward of the fuselage. Having your engine so far forward is going to make your center of gravity with a huge bias towards the front of the plane, which is of course more stable. Plane working great here. I'm getting a little hung up on that crosswind. That 360-degree turn will get you with the winds. Just to remind the viewers at home, we do have a crosswind on the runway. It's not a lot, but it is there. Winds are blowing left to right on the runway from your view right now. So that would be from the left side of the plane to the right side of the plane. It's not as nasty at winds as we had on day 1 or day 2, but the day 1 and day 2 winds are actually going with the runway instead of against it, or across it. You know, this is the University of Alabama at Huntsville. Huntsville, Alabama being an aerospace giant with more on the rocketry side, with roots going back to the early 1950s with the Army Ballistic Missile Agency, which would eventually evolve into Marshall Space Flight Center. Marshall to this day, with NASA, working on the Artemis program, amongst other projects. Blue Origin also has very big facilities down there in Huntsville, working with engine and propulsion systems down there. Also utilizing some Marshall Space Flight Center test stands, 4670 test stand. Also, while we're here, shout out to Blue Origin with New Glenn. But it's not about Blue Origin now. It's about the University of Alabama Huntsville nailing the landing with Manta Ray for their first flight. Great mission for them. The entire team down here in the crowd rooting them on. It's always nice to have your own cheerleading section there. Ground crews vacating the runway. Great flight for them. Okay, Chris, you're back with us. Who do we got?
Up on the flight line now is Team 71 coming from the University of Nebraska-Lincoln, flying their plane Quack. And this is their mission 2 with 30 ducks and 8 pucks.
All right. Yeah, I know, right? It definitely is. So you said 30 ducks and 8 pucks, right?
Yep.
Not the most amount of hockey pucks that we've seen, but it's definitely up there.
It is up there. I think 14 was the highest we've seen, so 8 is probably close to the second highest.
Yeah, definitely. All right. University of Nebraska-Lincoln arming their engine. Plane beeping, flight control surfaces checked out. Now once again, this is a cargo mission for them. We do see some clear fuselage there. I'm wondering if we could see any ducks through there, but I don't know. I can't see it from over here. Okay. I see the rudder moving on the plane a lot. The plane's making a beeping noise. Not sure if that's good or bad. University of Nebraska-Lincoln opted for a pretty longer fuselage, right? Overhead wing with a tricycle landing gear, meaning that the nose gear is up at the front of the plane. The plane made a different beeping noise. Not sure if that's good or bad. We'll see here. Oh no. Ground crews pulling the airplane, removing the, safing the airplane, removing the fuse. Oh no. University of Nebraska having some technical difficulty here. All right, as they move off the runway, Chris, who do we got up next?
We've got Team 72 coming from the University of Texas at El Paso, flying their plane Rio, and this is mission number 2 with 3 ducks and 1 puck.
Okay, minimum requirements here.
Good luck, guys.
Thank you.
Okay, University of Texas, El Paso. Ready to go here. Putting in the arming fuse for their engine system. Plane making beeping noise. University of Texas, El Paso opted for a very sleek fuselage. They have a tricycle landing gear with almost a T-tail, not exactly a T-tail. It looks like their horizontal stabilizers and control surfaces are about halfway up their rudder. Similar to how a B-1, for instance. Rockwell's B-1 has a tail similar to that. Let's see if this thing performs like one, though. There we go. Oh, she's got crazy power. Look at that thing. All right. Now, once again, the University of Texas El Paso here is in mission 2, so it is a cargo mission, but they've opted for minimum requirements for cargo, which isn't necessarily a bad thing. They're probably aiming to score points with other different types of missions. Rio's flying great. That's the name of their plane. Doing the 360-degree turn. Oh, they got a little warning from the judge for getting a little far away on that 360-degree turn. Okay, circling around through 3 and 4. Oh, having a very sleek fuselage like that is really going to make the plane a lot lighter, and it's really going to blow that thing around. Oh. Not sure if that's pilot induced, but there seems to be a lot of roll oscillations happening with this plane. Going through the 360-degree turn. Now, once again, for mission 2, your objective here is to see how many laps you can do with cargo in 5 minutes. Once again, Rio flying beautifully through there. So the team flying right now is the University of Texas El Paso, flying the Rio airplane. This is mission 2 for them. They're carrying 3 ducks and 1 puck. It looks like they're having a little bit of trouble with that crosswind there, but crosswind isn't necessarily a bad thing when you're up flying. It's just when you get back down, taking off and landing with a wind that's blowing across the runway instead of down or up the runway. Can be, well, actually a tailwind is probably not great either. You really want to go into the wind during takeoff and landings, but you get neither of that here. You get neither of the benefits. Wind's blowing out of the southwest here, which is across the runway. This runway does go north-south here. All right. Rio flying really high up in the air here. I always say altitude is the best insurance here. So if the wind's going to blow the plane around, give yourself some altitude, better chances of recovery if something does go wrong. Now, nothing has gone wrong here. University of Texas El Paso with their cargo flight, performing great thus far. Oh, looks like the wind's up off the runway a little bit, or getting a little sketchy. Okay, doing the 360-degree right turn on the back part of the track. You gotta be careful. The plane's flying high enough where the sun might come into play with being able to physically see the plane. Doesn't seem to be a problem here, though. Okay, once again, for a Mission 2 flight here, you're supposed to see how many laps you can do around the track in 5 minutes. Should be getting, oh, okay. Okay, all right. Pilot looks to be circling around for a landing here. Okay, bringing it in. Rio's coming in for a landing. Oh, that crosswind, see it? Oh, okay, all right, all right. Nice! The crowd goes wild. As University of Texas El Paso completes their second mission with their Rio plane. It's the best cheering section I've seen thus far. That's great. Okay.
Pull the fuse as soon as you get there.
All right. Ground crew's going to recover the Rio off the runway. Chris, you're back with me. Who do we have up next?
Up next, we've got Team 73 coming from the University of North Carolina at Charlotte, flying their plane, the Nemesis. This is mission 2 with 10 ducks and 3 pucks. A good piece of information about this plane. This plane is entirely 3D printed. We're talking the wheels, the propeller, everything on this plane has been 3D printed.
Cool. All right. So Team 73, UNC Charlotte here. Okay. We've seen a lot of different planes made out of different materials here. I've seen plastics. I believe the Ohio State has a poster board airplane made out of construction board. 2-day build for them. Pretty impressive. This one is entirely 3D printed. Here, this is UNC Charlotte, team number 73. This is their cargo mission. They're going to have to keep that plane up there for 5 minutes and do as many laps as they can. Okay? Ground crew's vacated the runway. We got a 3-prop design there. Plane is armed, going down the runway. Here we go. They're up in the air. All right, doing their 360-degree turn. Now it looks like UNC Charlotte with their 3D printed plane has opted for a more small fuselage here. That of course is less plane to move around, but once again, we were talking about trade-offs. With a smaller plane like that, you're gonna need bigger control surfaces to keep it flying straight. If you look at their rear control surfaces, they're really, really large, even compared to the wing in front. That's what happens when you have a short fuselage. There's not necessarily anything wrong with that. It is, after all, less plane, more room for cargo. Now, once again, UNC Charlotte not moving around the minimum here. 10 ducks, 3 pucks on board. UNC Charlotte with the Nemesis, doing their cargo mission. Actually, despite the winds, that plane, and even with the short fuselage, flying great. Real stable, real smooth. Okay. Once again, this is Team 73, University of North Carolina at Charlotte, flying their Nemesis plane on their cargo mission. Nothing to report here down on the flight line. Everything's going nice and smooth. And like I've been saying, no news is good news here. Flight's going great. As the Nemesis goes through turn 1 and turn 2. Doing that 360-degree turn. That plane's just cruising along against the picture-perfect sky there. Okay, circling around here for a landing. Bringing it down. An entirely 3D printed plane from UNC Charlotte touches down. Cheers from the crowd there. Really, really, really good. Recovery crews moving down the runway to get the Nemesis secured and safed. All right. Chris, you're back with me.
I am. Up next, we've got Team 74 from California State Polytechnic University, Pomona, with their plane Dreamcatcher, named after one of the horses that are bred at the campus, Arabians. And they're on mission number 2 with 12 ducks and 4 pucks.
12 ducks, 4 pucks.
Sorry for the sudden jump there.
Okay. It's California State Polytechnic University at Pomona with the Dreamcatcher. Okay. Ground crews arming the plane. Plane flight control surfaces are working. Plane is making audible beeps indicating, I'm pretty sure indicating that it's working. Should get a takeoff here momentarily. All right, here we go. Got a clear prop call from the pilot, stating intention to take off, and he's done it. Now this is a Mission 2 flight, once again, just like we had before. We're getting a lot of Mission 2 flights today, on day 3 here. Mission 2 flight is the one that carries ducks and pucks. Ducks being your passengers, hockey pucks being your cargo. The objective here is to see how many laps you can do around the track in 5 minutes. The amount of cargo you're carrying, speed, thrust of weight on your plane is all at play here with this particular mission. The more laps you can do, the more you get paid, which I do believe is the objective if you're flying airplanes around as your job, right? The more cargo you move, the more people you move, the more you get paid. And of course, Meredith over at the AIAA in our opening remarks, we'll say, this morning, was telling me that these teams are paid with a very, very special currency called duck coin. And whoever has the most duck coins at the end of the competition will win. Got winds are picking up a little bit down here on the ground. Doesn't seem to be affecting the Dreamcatcher too much here. California State Polytechnic University, Pomona, opting for a longer fuselage design here. Longer fuselage, once again, if your control surfaces are further away from the center of gravity of the plane, that means you're going to have more effective control. And a longer fuselage favors that stability in control. Of course, your rear control surfaces are attached to your rudder, and your elevators are attached to the vertical stabilizer and the horizontal stabilizers. You really see that control authority with how this plane is flying around. Beautiful. Plane performing really, really well. California State Polytechnic Institute, or Polytechnic University, excuse me. At Pomona, performing great. Dreamcatcher's flying around fantastic. Now the winds have picked up down here on the runway just a little bit. Just a little bit. But up there, doesn't seem to be perturbing the plane too much. Plane just cutting through the skies up there. Okay. Once again, they are doing a Mission 2 flight. Oh, turning around. 5 minutes are up. Uh-oh. Uh-oh. Oh, no! Ooh. Not great. From California State Polytechnic University at Pomona, the Dreamcatcher having a little bit of an anomaly, landing over in the grass. Recovery crew's moving, but oh no, we're getting reports here from the flight line that the battery gave out. Oh no. Okay, Chris, you're with us again here. What do we got?
Up next is Team 75 from Alexandria University with their plane Phantom. This is their second attempt at Mission 1.
All right. Good luck, guys. You got this. You got it. Okay, Alexandria University in Egypt. One of our international teams here at the AIAA 2026 DBF, Design, Build, and Fly competition. All right, ground crews are positioning the plane. Out on the runway. Alexandria University naming their plane the Phantom. They did have a little bit of troubles yesterday, but a testament to these student engineers rebuilding this plane, getting it ready for flight, and getting back out on the runway and attempting again. It's not easy when you're coming from overseas. Coming from overseas here, traveling all this way, and performing here. This is not an easy thing to do, but here they are, overcoming adversity here with their second attempt at Mission 1. Ground crews. Getting ready to arm the plane as the recovery crews pick up the Dreamcatcher, who unfortunately had the batteries die when it was coming in around for landing. Not an ideal circumstance for them, but we got Alexandria University out here ready to go. Okay, the recovery truck has recovered the plane, and the next plane is up. We got the Phantom here, once again. Team 75, Alexandria University. Ground crew's just waiting to turn the plane on. Part of the rules stipulate that you have to activate the plane with a blade fuse. That's to make sure that the engines aren't on in any place but the runway. There we go. Activating the airframe. Okay. All right. Ground crew's moving off the runway. Let's see what the Phantom can do. Here we go. Phantom takes to the skies. Once again, this is a Mission 1 flight. What we're attempting here is to do 3 laps around the track. And then come back in for a landing. Now, Mission 1, despite being a lapped mission, you need to do 3 laps to complete the objective, is still timed. You have to do it in 5 minutes. That doesn't seem to be a problem for Phantom right here. Cutting through the air. Looking great. Beautiful. All right, we're on lap 2, doing the 360-degree corner. Oh. A little bit of windage there, but Phantom has recovered. Circling around. Completing lap 2. Yeah, the winds are starting to pick up a little bit. We got winds coming south-southwest at this point here. Actually turning into a little bit more of a headwind here at this point. It's closer to south than it is to southwest, and that means it's going with the runway. Oh no. Oh, she recovered. That's beautiful. Come on. You got this. She's good. You got it. Come on, Phantom. Stay with it. Hey, not bad. Beautiful recovery. We got cheers from the crowd there. That was Alexandria University flying Mission 1 with Phantom. All right. Okay. All right. So, as the recovery teams move out there to get the plane, I'm going to go back over to Chris Horton. Chris, what do you got for me?
Up next, we've got Team 77 coming up from the University of Tennessee, Knoxville, flying their plane, the Smoky Mallard. They're on mission number 2 with 18 ducks and 6 pucks. And the team has asked me to give a shout out to Levi and all the supporters at the university.
All right. Shout out to Levi. Let's go. Okay. Now, Chris, refresh my memory. How much cargo do we have on this mission?
We've got 8 ducks and 3 pucks on this one.
8?
No, I take that back. It's 18 ducks and 6 pucks.
Okay, 18 and 6. Here we go. University of Tennessee at Knoxville with their plane, the Smoky Mallard. Okay, just waiting for the last team to get off the runway here. University, Tennessee, Knoxville, arming the Smoky Mallard. It's one of the more interesting designs that we've seen here. Very, very long airfoil design there. That crosswind, oh baby. Woof. It's like, just like we saw with the last plane, the windage is starting to get a little squirrely here. You can definitely see it when these planes go to do these turns. Uh-oh. Once again, this is mission 2 for them. Mission 2 is the cargo mission. We got 18 ducks, 6 hockey pucks. Moving rubber ducks and hockey pucks here for the cargo missions. Mission 2 requirements here are to do as many laps as you can in 5 minutes and then bring the plane back down in one piece. I did get clarification from the judges on any potential rough landings. It doesn't count if any part of the plane comes off that's more or less not the landing gear. And it also depends on how the landing gear is attached. If you have the landing gear attached via a bolt or a screw, and when you go to land, that screw breaks off, that still counts. But if you go to land and any part of the plane that's not the landing gear comes off, then you got a big problem. That's when it doesn't count. Oh, we're seeming to get some flutter from the tail of the Smoky Mallard. Some flutter over the rudder. Flutter is aerodynamic oscillations that get induced into control surfaces and stabilizers. It basically shakes back and forth really, really fast. Seeing a lot of flutter from that rear wing there, or from the rear vertical stabilizer. Seems to be okay now. You don't really not want flutter on any control surfaces. If your wings aren't doing anything but generating lift or stabilizing you, if they're fluttering around, you can lose control. It doesn't seem to be happening here. Now, flutter, on top of all that, what flutter can do is it actually wears out components. Think about if you open up a can of your favorite soda, right? And you pull the tab open, and you keep pulling on the tab back and forth, back and forth, and back and forth, and then eventually it breaks off. That's the same idea. Flutter can fatigue structural parts of the plane. Whether that was induced from the wind or not, we won't know. Doesn't seem to be happening now. Yeah, beautiful turn there for the Smoky Mallard. Once again, this team is the University of Tennessee, Knoxville, working on mission 2 here, cargo flight. Seeing how many laps they can do in 5 minutes. Oh, coming back down towards the runway. Now the winds have trended more to the, instead of going across the runway, they're kind of more southwest at this point. So it's kind of, instead of crossing the runway, it's more diagonally across the runway at this point, relative to the runway's, long axis. Oh. All right. Oh. I keep, I don't know, I might be crazy, but I think I keep hearing the engine going on and off there, but or at least throttling down. Not sure. We'll see. We'll see when she comes back down. Oh, definitely heard it again. Yeah, pilot could be coming in for a landing, throttling back, reducing the airspeed for a landing. Okay. University of Tennessee Knoxville circling around for an approach. Once again, the winds are coming from the front right of the relative to the airframe here. Timer's going off, 5 minutes up. Good touchdown. The front gear, oh. Front gear did bend a little bit, but the Smoky Mallet's down in one piece.
It's built like that.
It's supposed to do that. Chris is telling me that it is supposed to, in fact, give a little bit like that. Beautiful flight from the University of Tennessee, Knoxville. All right, who do we got up next?
Up next is Team 78 coming from the University of Alabama at Birmingham, flying their plane, the Vulcan. They're on mission number 2 with 8 ducks and 3 pucks.
8 and 3. Okay, once again, Team 78, the University of Alabama at Birmingham. 8 ducks, 3 pucks on their cargo mission. The objective here, see how many laps you can do around the track
Thank you. Yeah.
in 5 minutes. Okay, the Vulcan up in the air, starting flight 2 for the mission 2 for the University of Alabama, Birmingham. Beautiful flight thus far. Pilot opting to get a little bit of altitude there. Oh, careful, you're flying into the sun here. Vulcan way up in the air as it goes through turn 1 and turn 2. Uh-oh. Plane turned right at us there for a second. Everything's looking good. Doing the 360-degree right turn on the back part of the track. Circling around through 3 and 4. Back onto the main straight, completed another lap. Windage starting to perturb the plane a little bit. The wind is not necessarily as bad as we've seen over the last couple of days, but earlier in the day we did have a crosswind over the runway. Now it looks the winds look to be coming straight out of the south here. That would give you a headwind when you're going down the main straight here, flying the course this way, meaning you're going into the wind. But that makes for potentially aerodynamically unstable conditions when you're going into turn 3 right here, because you got a tailwind. Tailwind will increase your ground speed. You will go faster, but with the wind blowing over the control surfaces backwards, it could potentially make some aerodynamic instability here. Of course, the headwind is the opposite. Headwind makes the plane more stable. You get more air moving over the wings, but you don't really necessarily go as fast because you are going into the wind. So you get stability, but not as high a ground speed. And once again, speed is key to these cargo missions. You're trying to see how many laps that you can do here in 5 minutes. Okay, coming in for a landing. Got a nice headwind. Buttery landing. Smooth as butter right there. That was University of Alabama at Birmingham with their Vulcan plane carrying 8 ducks, 3 pucks, completing their Mission 2 flight as the ground crews go and recover the airplane. All right, as they head off the runway, Chris, who do we got up next?
Up next is Team 80 from the Pennsylvania State University flying their plane Penn State Airplane, and they are on Mission 1.
A very creative name. Very creative name. This is a Mission 1 flight, so unlike the cargo flights that you've been seeing where we're talking about rubber ducks and hockey pucks, Penn State's going out. Good luck, dudes. Penn State's going out there with their plane for a Mission 1 flight, which is a test flight. Oh, looking at a interesting material construction there. Looks to be looks to be made out of carbon fiber if I'm looking at that right. I'm seeing some nice weaves on the side of the plane. Now they've opted for an underwing design, tricycle landing gear, 3-blade propeller with a V-tail, similar to Beechcraft Bonanza, early Beechcraft Bonanzas. The V-tail trades simplicity for maneuverability. With a V-tail, you only have 2 control surfaces, but you have 2 control surfaces controlling 2 axes of one of your 6 degrees of freedom here with the airplane. Simplicity makes it easier to make if you only have 2 control surfaces. But a T-tail would have 3 control surfaces, 2 for pitch, 1 for yaw. A little bit more complicated to make, but you do get more effective control. Once again, a trade-off. A V-tail, much simpler, a little bit harder to get to work right. A T-tail, the tail looks like a T, a little bit easier to control, but it's more technically complicated. Illustrating the trade-offs of the different teams here at the DBF, Design, Build, and Fly competition. So this is a Mission 1. It's a Mission 1 for them. They got to do 3 laps. Actually, that plane really flying nice. Now, they did go for a longer fuselage as well. The longer fuselage, once again, if you have your rear stabilizers and your rear control surfaces further away from the center of gravity, you're going to have more effective control. And that's probably going with the V-tail shows some really, really considered thought into this airframe. They have those control surfaces way far away from the center of gravity, and the V-tail makes it more simpler to work on. Or more simpler to make, less control surfaces. Plane looking real good. Real good as they go into lap 3 here. Yeah. Doing the 360-degree right turn. They're on the back half of the track here. You know, those winds, like I was saying, those winds are still here. They haven't stopped, but you wouldn't know by looking at this plane. Okay. Pennsylvania State University completing the 3rd lap, pilots circling around here for a landing. This is a Mission 1 flight for them, so this was just the test flight. Beautiful, beautiful heading alignment turn there. The plane looks great flying through the air. Circling around, aligned with the runway. Yeah, that's one of the nicer landings we've seen. Oh, we may have jinxed it. We may have commentator cursed them, but the plane is down in one piece. One piece. Beautiful flight for them. Completing Mission 1. Looks great. Ground crews going to safe the plane, removing the fuse, deactivating the engine. All right. Pennsylvania State comes off the runway. Chris, who do we got coming up next?
Up next, we've got Team 83 from the University of Missouri, Kansas City, flying their plane GW Bush plane, and this is mission 1 for the team.
Okay, mission 1, another test flight. Okay, here we go. University of Missouri, Kansas City, trying to do their test flight. It's all good, dude. We're good. Just trying to make sure nobody steps on our camera cables here so we can keep providing you guys with these good views. Hey, great flight, guys.
Thanks.
That was great. Pennsylvania State University completed their mission 1 coming off the runway. Now we got University of Missouri, Kansas City. Ground cruiser up, arming the plane. They have a forward engine design, looks to have a tail dragger, wing on the top, overhead wing. Tail dragger means that your main gear are up at the front of the fuselage with a rear steering gear back by the rear control surfaces. This type of design favors very lower speed but very high stability. The control surfaces being as far away as they can from the center of gravity. University of Missouri, Kansas City opting for what looks like an airfoil design that's going to. Oh yeah, I'm looking at the airfoil. Airfoil is if you look at the wings from the side, the shape there, the shape seems to have a lot of tilt back to it. I know that's not the right terminology, I know, but what that's going to do is going to favor this type of plane design here by generating lots of lift and immediately taking off, but not necessarily going too fast. But the plane does generate a lot of lift. Did you see that thing got right up in the air real fast? Okay, once again, this is a test flight for them. They got to do 3 laps around the track. Going through turn 1 and turn 2. 360-degree turn to the right. Completing the 360-degree turn. Plane slewing a little bit to the right there. Coming into turn 3 and turn 4. Oh. Okay. Oh. University of Missouri, Kansas City. This plane is actually being flown by the pilot that actually flew the Thorpe S-18 on day 1. This is Mujahid Abdul Rahim at the helm, or at the controls, I should say. He was flying his Thorpe S-18 for the opening ceremony for the 2026 AIAA Design, Build, and Fly competition. I want to see if we can talk to him a little bit later. We'll see what we can do. See what we can do. Okay, flying really good. So the pilot is also the faculty advisor for that team. A lot of these teams are coming here with an advisor to mentor the students and help them through the process of designing, building, and flying these airplanes. And you can have them as the pilot. That's okay to do. That is very clear in the rules. Okay, University of Missouri, Kansas City circling around, completing their 3 laps, coming in for a landing. Winds are coming out of the southwest here, so it's kind of diagonally across the runway. But with this type of plane, a good approach will get you down nice and easy. Look at that. Not bad, not bad, not bad. Didn't want a commentator's curse, but with this type of plane design, low speed, in favor of low speed, should be nice and easy to land, and that seems to be what happened. I do believe in the commentator's curse, being a sports fan. You know what I mean. Okay, Chris, you're back with me. Who do we got next?
Up next is Team 86 from the University of Maine, flying their plane Barely Airborne. This is mission number 1, second attempt. This team has been was up till 3 a.m. last night, rebuilding their plane. So good luck, guys.
You got this, dudes. Let's go. All right. So we have Team 86 here, University of Maine, with Barely Airborne. And this speaks to what I was talking about a little bit earlier, if you're looking at that plane. University of Missouri, Kansas City, coming off here. Good job, guys. You did great. That was great. Good plane.
Oh my God.
It must be a load off, right?
Yeah.
A lot of relief from University of Missouri, Kansas City. Okay, so we got University of Maine coming up here. And this is what I was talking about. We saw Rutgers with a biplane design, so it's one wing over the other. But I told you, it doesn't matter where your wings are. As long as they're not disrupting air from one another, you can put them wherever you want. And you see a very, very interesting design here from University of Maine with 2 aerofoils that are actually staggered, one in front of the other. All right, plane is armed, engines are on. Let's see what they can do. This is a test flight. Mission 1 for University of Maine. Plane's going down the runway. We got a rotation and a liftoff. She's in the air. Their mission 1 attempt didn't go very well. They got by the wind. But that doesn't seem to be a problem here. Just a point of clarification. I was saying it doesn't really matter where the wings are. There's one thing that does matter. The wings have to be near your center of gravity. If they're not near the center of gravity, your plane isn't going to fly very far. The configuration of the wing is what more what I was getting at. You can have one wing at the back of the plane and one wing at the front, as long as 2 of those wings working together lift up the center of gravity of the plane. It's called the center of lift. The wing shape can be whatever. Wing configuration can be whatever you want. As long as those 2 line up, it will fly. Now, how far? We don't know. But University of Maine seems to have this figured out here. You know, the plane's called Barely Airborne. I would say it's more than barely airborne right now. Okay. Now, once again, this is a test flight for them. This is the second attempt at mission 1. Their mission 1 didn't go very well. But attempt 2 seems to be going great. Teams were up till 3 a.m. last night, rebuilding Barely Airborne to compete in this competition. And that's what I think one of the coolest parts about this competition. You know, you don't have a flight that goes your way. You have a flight that doesn't work, doesn't do what you want it to do. You go home, you rebuild the plane, you get back out here and you fly. That's the beauty of this competition. It really shows some grit. Rebuilding that thing, getting it ready to go. Plane circling around, Barely Airborne, circling around here, doing its 360-degree turn. Oh, we got to be careful. The wind's picking up again. Oh, geez. You know I've been saying that like every flight. It's like, oh, the wind's picking up. The wind is that dynamic in Kansas. I've talked to a lot of locals around here while I've had the pleasure of being out here. They said, you know, you don't like the wind, you don't like the weather, just wait a second. It'll change. So if I say the wind's picking up, that means we're getting a gust. And a gust, the wind does gust, and it seems to be, looking at the windsock, seems to be gusting up to 10 knots. We'll see. You can always tell by how bent the windsock is, how much the wind is moving. Okay. Barely Airborne completing 3 laps, circling around for a heading alignment for landing on the runway. Okay, come on. Come on, bring it in. You got this. There's that headwind there. And a great touchdown from Barely Airborne. 2 completing mission 1. The University of Maine must be very happy with that result. Very unique twin wing design there. Twin staggered wing design from them. They're going to go get their plane and they're probably going to celebrate a little bit. Chris, you're back with me. Who do we got next?
EJ, up next is Team 81 from the University of Houston flying their plane MV1. This is mission 1 for the team, and they'd like me to give a shout out to their aero lead, Raul, who could not make it to the competition.
All right, we got a shout out to Raul there. Okay, University of Houston doing mission 1. The shout out to Raul. Okay. Looks like University of Houston has opted for a little bit of a wider fuselage tricycle landing gear overhead wing design with winglets on the end. Probably leaning in, if I had to guess, could be wrong. I should probably go talk to them. Probably leaning into more to the cargo missions.
Yeah, I know. I'm saying the pilot looks like perfect. Oh, okay.
Oh, I'm just getting in from our producer's desk that the University of Maine, with Barely Able, had 13 other teams help them out, rebuilding their plane till 3 a.m. That shows that aerospace is definitely a team sport. And they wrote all the names of the teams that helped them on the side of Barely Airborne. That's great. That's really cool. Good to know. So, University of Maine's off the runway. Now we have team number 81, the University of Houston. Their plane is armed, blade fuse is in, engine is on. Oh, there we go. Now this plane has winglets on the edges of the wings. Those winglets or wing fences are basically there to govern how the air flows over the top of the wing. It might sound a little bit weird, but sometimes the air doesn't move directly perpendicular over the wings, depending on winds, depending on fuselage design, right? So, wing fences were invented. Well, let's see, when was the first wing fences we saw? Probably into the 30s and the 40s. Wing fences were there as fins that are on the wings and winglets out on the edge of the wing to govern how airflow moves over those wings. You want the air to ideally move with what's called the angle of the wing, right? So these are fixed straight wings here. With a fixed straight wing, you want the air to move perpendicular relative to the wing leading edge. Those wing fences, which we've seen on some of these planes, help govern how the air moves over the wing, and it keeps air over the top and bottom, in some cases the bottom of the wing, depending on the design. Now once again, this is a test flight for the University of Houston here. They got to do 3 laps around the course. They're in the middle of lap 2, going through the 360-degree right turn. Okay, circling around. Pilot's got a lot of altitude here, a lot of altitude. The wind's now coming directly south. They started with a crosswind. Wind's coming out of the west, and then it's moved southwest, And now we have a headwind here on the runway, almost full headwind, meaning that wind is moving in the direction on the same long axis of the runway. So that will give you, with the winds coming out of the south here, that'll give you a headwind when you're on the main straight of the track, and it'll give you a tailwind when you're on the back straight of the track. If you're flying into the wind, your ground speed's actually going to go down because you're going into the wind, but you do get more lift. Plane will generate more lift in a headwind because more air is moving over the wings. If you're unfamiliar with aviation, just in case anybody needs a primer, if there's any parents watching at home, airplanes have ground speed and they have airspeed. The airspeed is important because if you're not moving air over the wings, you're not generating lift. Got to do that. That's kind of important. Key part of flying, right? Ground speed is how fast the plane is moving relative to the ground. Airspeed and ground speed aren't the same number because of stuff like the wind. Right, so with a headwind, your ground speed is going to be slower, but the airspeed will be faster. With a tailwind, your ground speed will be faster, but your airspeed will be slower. Weird, huh? But that's what's cool about flight. There's a lot of counterintuitive things going on there. But here we go. University of Houston completing 3 laps, coming in for a landing. Beautiful. Little bit of a wing touch, but we got it. Plane's in one piece. Coming back down. Chris, watch. You're good, dude. University of Houston disarming the plane. It's actually right by us. Hey guys, you think Raul's gonna be good with that one?
I think so.
You think he's gonna be good? All right, there you go.
Nice job. Big step up from 2 years ago.
Oh yeah.
All right, so as they exit, Chris, you're back with me. Who do we got?
We've got Team 87 from the St. Louis University flying their plane, the Billiken Banshee, and this is mission number 2 with 10 ducks and 3 pucks.
10 and 3. St. Louis University. Okay.
Go on the concrete, please. Go on the concrete. Stay away from all those cables.
Nice flying, dude. University of Houston off. We got St. Louis University, the Billiken Banshee, flying their cargo mission here. Okay, ground crews arming the plane making the beeps, the sweeps for the control surfaces, and no creeps, not this time. Okay. Engine is on. Here we go. St. Louis University with their mission 2 attempt here. Ooh, a little squirrely going off the runway there, but looking good. Up in the air. We got a good indicator from the judge. 180-degree turn to the left through turn 1 and turn 2. Okay, 360-degree turn to the right. Now, the past couple of missions that we've seen are actually a lot of mission 1s. Mission 1s are where it's a flight test for the vehicle. You do 3 laps around the track, but you have to get them done in 5 minutes. Now, mission 2 is a little bit different. Mission 2 is a cargo mission, where you have to carry passengers in the form of rubber ducks and cargo in the form of hockey pucks. St. Louis University with the Billiken Banshee has opted for 10 ducks and 3 pucks on their cargo flight. But when you do mission 2, it's not just about completing 3 laps. You have 5 minutes to complete as many laps as possible. The idea is that you're operating a bush plane here. You're operating a bush plane moving passengers around. And the faster you can move passengers, the more profitable, provided there's demand. And there is demand. The rubber ducks need to go places. The faster that you can move these passenger ducks around, the more points and more money you're going to make. And of course, the currency that the currency that we have, that we're trading here at the 2026 AIAA Design, Build, and Fly competition is duck coin. You get paid in duck coin. No, it's not a cryptocurrency. All right, that's our made-up currency that we're using here to pay our Bush League teams for moving rubber ducks around. Okay, nothing more. Billy and Banshee flying great through the air. The wind, guess what? Guess what? Hey, the wind picked up again. No, that's weird. But like I said, it's moving with the runway, so we got a headwind if you're going south. Now, southbound would be on the main straight of our track. If you see the plane kind of slew through that turn there, that means you have the wind at your tail. So the plane is facing south right now, and now it's turning through the 360-degree turn. Now we're going north again. So we got a tailwind again. If you look at this plane, when it goes through the turn, you'll see it kind of drift around just a little bit. It didn't do it that much that time. There we go. Now we're going into the wind. Into the wind. Coming in for a landing, it looks like. There we go, Billiken Banshee touching down. Perfect landing by the pilot. St. Louis University completing mission 2 here with 10 ducks and 3 pucks. Okay, Chris, you're back with me. Who do we got next?
Up next is Team 88 from the University of Georgia with their plane, the Archangel. This is mission number 2 for the team with 30 ducks and 8 pucks.
Okay, team number 88, University of Georgia. The Archangel, doing their cargo mission with 30 passengers in the form of rubber ducks and 8 pieces of cargo.
Yeah, you right at the white line, no, right?
All right, team's moving on to the runway here. The Archangel utilizing an under-wing fuselage design with a much sleeker airfoil design. This plane, if you notice, like on their main wing, if you're looking at the wing from the side, the design there is kind of teardrop shape. That's the airfoil. And the airfoil, how much it bends is how much lift you're going to generate. That's the quick way of saying it. Aerodynamics is complicated. This airfoil design being a lot sleeker and not having a lot of downward tilt at the end of the airfoil, like the end of the teardrop, means that this plane is optimized for speed here. Of course, the University of Georgia has a longer fuselage with their control surfaces as far away from the center of gravity as they can. Center of gravity, of course, being under that sleek airfoil that I was telling you guys about. They do have a tricycle design, meaning the nose gear is up. Engine is on. The Archangel's in the air. Circling around through turn 1 into turn 2. Now, once again, they're on a cargo flight here. So the rules for the cargo flight are how many laps you can do around our track in 5 minutes. See what I mean about speed? That airfoil is favoring a very, very fast design. University of Georgia with the Archangel absolutely booking down the main straight. You really see, with the tailwind here, you really see that thing start to pick up ground speed. Well, the Archangel is doing their thing with the University of Georgia. I'm going to do my thing here and take a second to thank all the viewers on the AIAA YouTube stream. Everybody watching at home, we appreciate you watching. Thank you very much. And shout out to everybody that's watching this over on Twitch. Chat, you guys are awesome. Thank you for letting me do what I do here, commentating on the flight line at the 2026 AIAA Design, Build, and Fly competition, DBF. Archangel carrying 30 ducks, 8 pucks on board. Looking real good. All right. University of Georgia on the back stretch of the track. Man, look at that plane boogie. There we go. Like I said, that airfoil design that they're using favors a lot of speed. It's a very long, kind of slender teardrop design. Not a lot of deflection down at the back end of it. That favors airspeed here, higher speeds from that plane. The idea is that you can move cargo and you can also haul the mail being hockey pucks, but also go fast. Okay, circling around here. Turn 3 and turn 4. Coming in for a landing. Oh, beautiful. Beautiful. The crowd goes wild. University of Georgia with Archangel completing mission 2. They're definitely happy with that. That was great.
Okay, I'll stay.
They're running down enthusiastically down to that plane. They're really happy with that result. Okay, as they vacate the runway, Chris, you back with me? Who do we got?
Up on the flight line coming up is Team 89 from Arizona State University, flying their plane, the Beak Freak. And this is their second attempt at Mission 1.
Okay, Beak Freak, second attempt. Mission 1 from Arizona State. Good luck, guys. You got this.
Thank you.
You got it. Let's roll.
I didn't know it was my job. You should have said something. No, don't have it yet. Alright, I thought we had to block.
All right.
Good job. Thank you, sir.
This is a Mission 1 attempt here. You got a lot of cheers from University of Georgia.
He's coming out now. He's got a hair.
Good luck, man. You got this.
Sorry, Andy. All right. That's the thing.
Got to bring your scorecard with you. Arizona State, they have to make sure they bring the scorecard to hand to the judges. They have it here. Pilot's ready to go. Ground crew's ready to arm the plane. The arming system activating the engine. Arizona State's opted for a 3-blade propeller design, but a very short propeller as well. So that propeller is going to favor higher RPM. That propeller needs to move more to move that big plane around. The airfoil also, just like the previous team, not a lot of bend in that teardrop shape from their wing, so this plane should be fast as well. Once again, this is a Mission 1 attempt. Arizona State they had an attempt yesterday. They had a little bit of trouble during takeoff. That doesn't seem to be the case today. Beak Freak takes to the sky. Arizona State University, team number 89. Now, because this is a mission 1 attempt, you have to do 3 laps around the track and that's it, and then come back down and land. But the key is you have to do it in 5 minutes. You are timed. Oh, the winds, once again. Saw a little bit of stall there. Okay, Beak Freak performing great here. Okay, once again, trying to complete 3 laps here. Oh, a little bit of a gust of wind up there at altitude, coming through turn 1 and turn 2. They've cleared the gates. Now, Arizona State with Beak Freak has opted once again for longer, like a lot of what we've seen. We've opted for a longer fuselage there. Having your vertical stabilizer and your horizontal stabilizers further away from your center of gravity will allow for better stability in the air, and then the control surfaces being behind that, a little bit better control as well. Okay, once again, the wind started we started with a crosswind this morning, but now the winds are coming out of the south-southwest, almost aligned with the runway. Okay, Arizona State circling the Beak Freak for landing here. They've done their 3 laps. Circling around for heading alignment with the runway. All right, got a good approach. Dealing with the headwind here. Look at that plane. It's just hovering over the runway. There we go. But a great landing there from Arizona State, nailing mission 1 of the first attempt. Didn't go very well yesterday, but this one definitely went great. Even taxied you right back to us over here. Look at that. Great flight from the Beak Freak with Arizona State. Crowd goes wild. Oh, even got an ASU chant. All right, Chris, who do we have next?
Up next is Team 92 from the University of Vermont, flying their plane, the Champlain, like the lake.
Nice.
And this is mission 1 for the team, and they'd like me to give a shout out to the team back home and everyone there.
All right.
Sounds good. Because I think I was hitting full throttle, like. Hey, pilot, is that you?
Okay, University of Vermont, team number 92. Oh, look at this plane. That is a looker of an airplane. They do have a little bit of a wing. They have wing fences and winglets on the outside of the wings there. Keep the air over the wings. Keep the air running perpendicular over the wings. They got a long fuselage with a tail dragger design.
I have literally no idea. Ask Luke.
Engine way out in front. Engine is on, plane is armed. Oh, come on, Champlain, get up there. There we go. Once again, the winds aren't exactly aligned with the runway. They're almost aligned with the runway. That makes for a little bit of tricky takeoff and landing conditions. Champlain going through the 360-degree corner. Whoa, whoa, those winds getting a little tricky there. Getting a little bit tricky. Now this is a test flight for the University of Vermont here, meaning they got to do 3 laps around the track. completing lap 1 there. Now I've noticed that their plane also is carrying a little bit of a dihedral wing. Now, if I was just speaking another language for people, a dihedral wing is where your main wings are actually tilted a little bit up, meaning the outside of the wings, oh no, are a little tilted, but we've had a little bit of a premature landing here from University of Vermont with Champlain. Recovery crew's moving down the taxiway over there. I think that plane was flying fantastic until that point. It's the wind. When you do a sharp turn and you go from a tailwind to a headwind real fast, it can make for unstable aerodynamic conditions. Pretty sure that's what we saw there. It's definitely not what you want to see, but they will be back. Okay, Chris, next plane up, what do we got?
Up next is Team 93 from the University of Arizona, flying their plane Ka-Chow. This is mission 1, second attempt, and the team would like me to give a shout out to John Allen and Elijah Greenfield.
There you go. Okay, University of Arizona with Ka-Chow. Pretty sure that's a reference to Cars, the movie. Now look at this design. We got a little interesting design here. We got a huge vertical stabilizer. The vertical stabilizer is there to make sure that, well, it keeps the plane flying in one direction, and it avoids a phenomenon called side slip with the airplane. You get side slip, it can make for a little bit of an adverse condition. Once again, I was telling before about how wing fences make the wings go perpendicular over the wing. That's ideally what you want. That vertical stabilizer is there to make sure that that happens. Now, you know, there's tailwinds, there's headwinds, and there's crosswinds that can also affect all these different conditions. It looks like the University of Arizona has opted for a big vertical stabilizer there to make sure that that plane flies straight as an arrow through the air. They have to wait, of course, until the University of Vermont with Champlain is recovered out in the grass. University of Vermont on the mission 1, a test flight there, encountered some aerodynamically unstable conditions that caused a premature landing. They're out there recovering their airframe now, and once they vacate, University of Arizona with their plane Ka-Chow will be ready to go. Another thing to notice about the Ka-Chow airframe is that it's using tricycle landing gear, meaning the small gear, your steering gear is in the front, your main gear kind of midway down the plane. We have a forward engine here. And once again, a very, very interesting rear stabilizer design there from them. So once again, this is the 2026 AIAA Design Build Flyer DBF competition here. We are in day 3 of the 3-day competition. And we've seen some really good flights today. That wind is proving to be, it's coming this way, going that way. It proves to be a little bit tricky during landing and during the 360-degree turn. We have seen some planes, we'll say, land a little bit earlier than intended. We don't want to call it a RUD. We don't want to call it a rapid unplanned disassembly. It's a rapid unplanned landing, right? But down here on the flight line, we've been having a lot of fun. This is a lot of fun, and if you're watching at home, I hope you're having fun with us. I hope you don't hate my commentary too much, you know? Thank you very much for watching, especially on the AIAA YouTube channel and over on Twitch. You guys rule. I hope everybody's having fun. This is fun to watch. I really enjoy it, and I really enjoy doing the commentary here. Okay, recovery teams look to be ready to go here. Runway looks to be clear. Here, we should see a flight here in a moment. Students taking selfie with their airframe there. University of Arizona ground pilot and observer, having some fun with the judges over there. Okay, the recovery truck with Champlain getting off the runway. Once again, this is the University of Arizona with their plane Ka-Chow, team number 93. This is a mission 1 attempt. They have beeps from the plane indicating that the engine is armed. Doing a propulsion test here, also taking pictures for the gram. Okay, ground crew's vacating. Engine is on. First flight for University of Arizona with Ka-Chow. Okay, a little bit of a downward pitch rate there, and now an upward pitch rate. Plane circling around. They do have a little bit of a swept wing on their plane, meaning the wings are swept back from the front of the part of the wing that connects to the fuselage to on the very edge of the wing. Oh no. Oh no. Oh no. Not what you want to see. An unfortunate ending there for the University of Arizona, but they still have time. We are in day 3, but that doesn't mean that you can't put that plane back together and get it flying. We'll see. Okay, we got to send out the recovery truck again here. Now, Chris, while the recovery truck's doing its thing, who do we got next?
Up next is Team 94, hailing from the University of Maryland, Baltimore County, and they're flying their plane Zenith, and this is their Mission 1 first attempt.
Okay, a lot of Mission 1 attempts here. You guys got this.
Oh yeah, I already flew Mission 1 and 2. This is done.
All right, you good.
Yeah.
You good.
And then after them is and if you're watching, stay tuned because the next flight is our first attempt at Mission 3. And it'll be coming from the University of Southern California on their plane Trojan Horse. So they're up in the staging box now.
USC. All right. But we have Team 94 here, University of Maryland, Baltimore County, with a Flight 1 attempt after the recovery truck gets out there and helps out University of Arizona with Ka-Chow there. Having a little bit of a unplanned landing on their Mission 1 attempt. Now, University of Maryland, Baltimore County here, if you look at the airplane, they're opting for they have kind of a tricycle landing gear design, but the plane, if you notice, the plane's fuselage is tilted a little bit upward with their gear configuration. That should make for a nice, easy takeoff. You don't necessarily get rotation out of that design. If you notice, the rear gear are a little ways back and that nose gear is all the way up at the front, indicating that the rear gear isn't on their center of gravity. It's not on the center of gravity because their fuselage there, most likely for the fuselage, the yellow fuselage that you see there is most likely for carrying cargo. So this plane, you shouldn't see some rotation from this thing going down the runway. What you should see is the plane just lifts right off up into the air. Now they do seem to be carrying a very tall vertical stabilizer, and actually the horizontal stabilizers look to be about the same width as opposed to the V-stab, vertical stabilizer's height. Now you can kind of tell how these planes fly because where the main wing is more or less where your center of gravity is. Center of gravity being the balancing point of the plane, right? And okay. I'm getting word that I might be having a special guest coming here. We'll see. See what happens as the recovery crews are out there picking up pieces of the plane, but I think he's here. Clay, what's going on, man? Good to see you.
See ya.
Down here with the flight line with us?
Nice to be back out here today.
He's the interviewer in chief.
And I've been having a great time.
Yeah? Having fun in the
team's
hangar?
Super exciting. We did some of the ground mission work, and to watch the speed of those teams on the ground, it was unbelievably fast.
Yeah, the ground missions being where they have to load and unload cargo,
Absolutely.
right?
Absolutely, and some really innovative designs in terms of dispensing. Arkansas, like, crushed at Virginia Tech. Absolute dexterity and speed. It was really interesting to watch the different approaches, but incredible times.
Yeah, and how fast you can load and unload that cargo discerns your score. Your load times and unload times are judged against the team that does it the fastest. So you got to pine for that fast, quick loading time,
Taylor,
right?
our lead volunteer there, she runs a tight ship, so you
Oh yeah,
gotta be ready.
I meant Taylor on day one. We like Taylor here down on the flight line. Absolutely. So, Clay, let me fill you in as what's going on here. University of Vermont with Champlain had a little bit of an early landing there. The winds are getting a little tricky to negotiate here. We started with a crosswind, and now the winds are coming out of the southwest, kind of going diagonally across the runway. That's making for some challenging flying conditions here. But we do have the University of Arizona coming up with their plane, University of Maryland, Baltimore County, coming up with their plane here on the runway. This is a first attempt for them. This is the first attempt on their test flight. They're waiting for, that was the University of Arizona with Ka-Chow that had a problem. I mean, Champlain had a problem too. The wind has taken the last two planes.
Yeah, no, I saw the University of Vermont plane go down as well, and that was, what do they call that, a RUD?
I've been calling it rapid unplanned landings.
Okay,
right.
okay.
I didn't, roll. I didn't see it disassemble. I can't see it from here. I'm in my pit in the flight lane.
All right, so UMBC, these are the retrievers, just north of Washington, D.C., from where I live. Had a good run in the NCAA tournament a few years back. It's a great school up there in Baltimore.
Yep.
Number of teams from that area, right? We had the University of Maryland, Terrapins, Johns Hopkins University was in play. A few others from the area there. RPI from upstate New York also showed well. Here we go.
All right, plane is armed. We got tone from the plane indicating that the engine is ready to go.
Another four-wheel design on the landing gear.
Yeah, I know that they actually have their whole plane tilted up and the gears are spread apart. That means you're not going to see a lot of rotation when this plane takes off. It's just going to lift right up off the ground. And their airfoil design, very sleek, very skinny airfoil, not a lot of deflection on the tail end of the teardrop, so to speak. We're talking about the main wing here. Now that should make for a very fast design. This plane should get up in the air and go real fast. There we go. Oh no. Wind again. Wind again got him. That side slip.
Yeah, the wind is really wreaking havoc out here.
It is. It's not a crosswind, but it's not a headwind either. Oh man.
Yeah, it's kind of coming at a 45-degree angle to the runway. Right?
Yep, we're diagonal.
Totally shift from yesterday.
Yeah, absolutely. We started off with a crosswind yesterday, and then it kind of changed direction. But on the first day, Clay, we had a 20-knot headwind coming out of the south. That was actually not nearly as bad. This one is kind of dynamic. The wind, once again, in Wichita, I've been talking to the locals around here. They say you want the wind to change direction, you want the weather to change. Just wait a couple seconds, right?
Yeah, it's been dramatic these last few flights.
Mm-hmm.
Do you think this is going to play into the banner unfurling as the
that's
coming up?
That's going to make for some tricky missions. So I've been hearing that we're going to see the first mission 3 here momentarily here with USC with their plane Trojan Horse. They did their cargo mission yesterday and they made it look real easy, and I assure you it's not easy. They were moving a lot of ducks around.
We talked a little bit about the design approach for both the team from Argentina as well as the USC team, where they're packing the ducks and pucks into the actual wing structure of the airplane. It'll be interesting to see with this wind and the control now with the banner, how those aircraft, because they're both designed very differently. Some of these very sleek, narrow designs that were minimalist, just the minimum amount of ducks and pucks. A lot more power. They were maximized. Both finished in the top 10. Actually in the top 5 teams. So we'll be interested to see how they can navigate with the wind coming up right now.
Yeah, it's definitely going to be tricky. When that banner unfurls, it's going to start fluttering around, and that flutter is going to put a crazy amount of drag on the plane. It'll really affect your flying conditions. Flight characteristics of the plane are going to be very altered. If you thought the cargo missions were changing how the planes fly, this is going to be something to see here.
Okay, here they come. Trojan Horse.
Good luck, guys.
Good luck.
You got this. So the banner's loaded on their plane.
I spent some time with the USC team this morning in
Oh,
the
yeah?
hangar. They're very excited about this this flight here. They got a unique design for that banner underneath the aircraft.
Yep.
This is kind of for all the marbles on this one.
They have a 229-inch banner. That's what Chris was telling me.
That is huge.
Wow.
So this one, ranks even more. There's more points awarded to this one than we had with the ducks loading yesterday. So this will be definitive for them. Again, design philosophy, the give and take, what you think it's going to take to win on this one. All right, looks like they're armed.
All right, here we go.
Trojan Horse.
So if you're watching, for the folks watching overseas, the international teams, that's a 229-inch banner.
Wow.
That's that
fast.
Yeah, man, she
huge
got
lift on that wing.
Yeah, absolutely. That is a 6.3 meter long banner. Okay. So once again, the objective here is after the first turn, they got to get that banner deployed here.
A full loop.
Yeah. Huh.
Looks like they've got good control.
Yeah.
There goes the banner.
There we go. Okay, they got a lot of altitude there for that banner deployment. That's a good strategy, getting up there.
Is cleaner air.
There we go.
Wow, fully deployed.
Fully unfurled.
You can hear the crowd.
Trojans flags flying over Wichita here. Okay, now the objective here is to complete as many laps as you can within 5 minutes.
That is a huge banner.
Look at that thing.
Wow,
that's awesome.
The Southern California on the front end there.
Yep.
Very nice.
Yep.
We need a little Fleetwood Mac tusk plane in the back.
Yeah, that's what I'm talking about. Absolutely. But you can see as they get into that headwind, that banner is really slowing that plane down.
Sure is.
All that flutter from the back end of the banner is causing a lot of drag. Now they have a tailwind here. The plane should really start to speed up. The ground speed should start to go up a lot.
Nice turn.
Yep.
All right.
Not bad. Not bad.
Fantastic.
Look at that thing.
Look at it go. These unique mission sets that they design for this are just so clever every year. They come up with some new things.
I've been seeing all kinds of awesome designs here, Clay. It's real good.
Last year we had this thing built around the Bell X-1. The third mission was dropping a glider in the shape of the Bell X-1
That's
into
cool.
a target area.
Really?
Yeah, and that was a dramatic come from behind victory on that one last year.
Yeah.
See the crosswind effect on that banner.
Oh yeah, it's definitely flapping around up there. Going through the 360-degree turn. Oh man.
Also a little altitude, but they've covered nicely.
Yeah.
There you go. Yeah, that downwind is much faster.
Yeah, exactly. I was telling the folks at home that, you know, you got a tailwind, your ground speed's going to go up, but your wings are not going to generate as much lift, right? And then conversely, in the headwind, your ground speed goes down because you have a lot more air. You're going into the wind, a lot more air is moving over that wing. Ground speed goes down, but the amount of lift the plane makes goes way up.
So much slower coming up.
Right? See, this is where a high thrust of weight is really going to pay off. When you're pulling that banner, you're going to need that power. Yeah. You need that power to pull it because it's going to drag you down.
Flags up. Making a turn.
Yep. Whoa, whoa, come on.
So much lift in that giant wing design.
Absolutely.
And with no ducks in there.
No,
lighter,
yep,
lighter than
exactly. Yep. Yeah, that's a reminder for the folks at home. This Mission 3 is not carrying any cargo. It's just a plane with no cargo, but you have to have a banner deployment mechanism. And USC has it, and it is working.
They look really strong here.
Absolutely.
Again, we're going to see, I think, with some of the other planes coming.
Oh, that wind.
It'll be speed and power.
Uh-oh. Okay. They have to deploy the banner before they land. That's part of the rules. Oh, no.
Okay.
A little bit of a rough landing. Ooh. Hey, not bad for a first Mission 3, I would say.
That was impressive in flight. All right, and we have another one of the top teams here coming on.
Yep.
Our friends from Slovenia.
University of Ljubljana coming out here. Good flying, guys.
Thanks so much. Good luck.
All right, Chris, I think we know that plane is instantly recognizable, but tell us for the viewers at home.
That's team number 2 from the University of Ljubljana flying their Bervints, and they've got a banner that's going to release at 182.25 inches.
Okay. All right.
Below.
There you go. Good luck, man. Okay, this is Mission 3 for University of Ljubljana. Once again, Slovenia, one of our international teams here competing in the competition, right?
Yeah, they've come to play here. This team.
Oh yeah.
They really have an impressive team. A lot of engineering design work went into this aircraft. It's built for speed. I asked them this morning in the hangar about the propulsion system and the prop, and they said, "Well, no, that's our secret sauce. We're not going to talk about it."
They know the game.
Yeah.
Just like the restaurant industry, you never tell anybody. Don't tell anybody your secret sauce. You gotta come and see it.
So it's impressive what these guys have. This is, I think, the quickest plane in the fleet.
Oh, it's fast. Yeah, she's fast. They did a lot of research and a lot of simulations, from what I can tell, looking at the wing design with the winglets. Make sure the air goes over the wings.
The winglets are impressive. There's
swept back, yeah.
There's a dorsal fin on there and 2 other side fins on the back of that fuselage just behind the wing assembly.
Yeah.
And I asked them about that. I said, "Is this a design feature?" And they said, "Well, it's just where our antennas are, but it looks cool."
Hey, rule of cool is a thing. All right.
Yeah, they were all over the looks of it. So it looks a little bit like a shark, huh?
Yeah. It definitely. Yeah. She moves. That's for sure. All right. Ljubljana has their plane armed. Here we go. Second Mission 3 that we're going to see here. Okay, they have to deploy here, either coming right out of the first turn or into the first turn here. All right, we got 1 turn. We should see a deployment here. No. And then the other thing, the rule criteria for Mission 3 is you got to deploy your banner, obviously, and then you got to do as many laps as you can with the banner. And then you have to deploy. Oh my goodness.
Wow.
Look at that.
That was something.
You have to deploy your banner before you land. You can't land with the banner.
Now, they have quite a leash on that.
Yeah.
Right? So you saw that delayed action when they released it, and then it really unfurled coming out of there.
Look at that thing go.
They're still moving.
She's booking.
Wow.
Their banner showing their university's logo there. Terrific.
It is really moving.
Clay, that thing just cuts through
So
the air.
impressive.
Wow. I mean, I feel like I'm watching an extra 300 fly around here. This thing's just straight as an arrow.
Again, with the speed, it's speed over capacity.
Yep.
But they still had a top 10 finish yesterday.
Yeah.
Yeah, top 5. Excuse me.
Yeah. I mean, they carried minimum requirements, but that minimum requirements still meets the requirements.
Low-level pass.
I think they might be showing off here a little bit.
There's a little bit, yeah, there's a little bit of showing off here.
Yeah. I mean, also, you know, the plane design's great, but still got to have a pilot flying it.
Yeah, this is a very skilled team.
Yeah.
Wow.
It's pretty good, man. It's pretty good. I mean, I've seen a lot of planes fly. Clay, I can't even start to think how many planes you've seen fly. How many you've seen fly like that?
This is one of the most impressive ones I've seen. It really is a powerful aircraft.
Yeah. Wind's picking up again. Here we go. We got a little bit of gust. Let's see if that's going to
average RC.
Right?
Okay.
Absolutely.
The drone is struggling to keep up here.
Yeah.
It's moving out so fast.
Yeah. When that wind gusts, it gusts. You can even see it. You can see it perturbing the plane just a little bit. It's not nearly as much as the other ones.
Compared to the other two.
Yeah.
Going upwind it doesn't seem to be a problem at all for this aircraft.
Yep. You can hear that flag blowing in the wind, the banner.
Solid and in control all the way.
Couldn't ask for more here. Now, once again, as we get to the end of their 5-minute window, they had to complete as many laps as they can while deploying that banner. But they have to let the banner go and then bring the plane down.
The release is what we're looking for. I think yesterday they got close to 13 laps. Is that right?
Yeah, they were
very close to 13.
That plane is booking. Okay, start to see it struggle with a little bit of the headwind there. Pilot gaining some altitude, going through the 360-degree turn, right turn on the back stretch of the runway.
Putting on a show.
Yeah. Well, they did yesterday after their cargo mission. They were doing, guy did a couple of aileron rolls, he did a barrel roll. Let's see. Circling around through 1 and 2. University of Ljubljana in Slovenia, making it look easy. And it's just a pleasure to watch that thing fly.
It really is. Like a knife through soft butter. This thing is just moving out.
Yeah.
Slicing through the air.
Okay.
Here you go.
Yep. Banner's dropped.
The release was huge.
Great. Yep. Now you got to circle around, bring that thing in for a landing. It has to be intact.
So you got to avoid the banner on the runway here.
Yep. Yeah, you can't land into it. Yep, yep.
Yeah, and just make sure you stay clear of that. They're coming in for a wide pass.
Be on a circling around. Yep. Heading alignment here. Now, once again, you got to deal with that headwind. We got winds diagonally moving on your screen, left to right, over the runway.
Yeah, see how they have this technique? They stop the prop and they just glide her right in.
Look at that.
So soft.
That's impressive. That is impressive. That is impressive. The crowd goes wild. Team celebrating out on the runway as their plane rolls out. That was impressive.
Oh my God.
That was really good.
Incredible. Really incredible.
What
did did he drop?
He dropped a bunch of stuff. It's blowing down the runway now.
He's got patches rolling out of his pocket.
Oh no!
Going down the runway. Stickers.
There's stickers.
Yeah.
All right.
Wow.
Pilot rejoicing there.
Some relief.
Yeah, breathing a huge sigh. Yep. So once again, that was team number 2, University of Ljubljana from Slovenia, one of our international teams, completing their 3rd mission.
I think they've kind of set the pace here, right?
Yeah.
They really are impressive.
That was a treat to watch.
All around.
Yep.
Well done, impressive.
That was awesome.
Yeah.
Team running out with the banner. Yeah. Watch it. Congratulations from the other teams too.
Unbelievable. Unbelievable.
Yep.
That's impressive flight.
Yeah. Wow. That's going to be a hard act to follow, man.
I think so.
Yeah.
I think so.
No, I enjoy one.
Okay, so we're waiting here on the next team. Once again, that was the University of Ljubljana in Slovenia, and they just kind of set the bar. That was the second mission 3 that we've actually seen today. University of Southern California, USC, came in with their Trojan horse. They did a mission 2. They did mission 3 as well, I should say, and then University of Ljubljana just completed theirs. Now, Chris, you're with me. Who do we got?
Up next is our team number 3 from the Royal Melbourne Institute of Technology, and they're playing Thunderduck. They're on mission 3 as well, and they're going to attempt to release a 186-inch banner.
Okay.
Another top 10 team from yesterday coming into this 3rd mission set. And they were the 2nd place finisher last year.
Oh yeah.
Design Build Fly in Tucson.
Yeah.
So they're coming back looking for a W.
All right.
Yeah.
Didn't you say it was really close until the end last year?
It was very close at the end. Santa Clara University was in the lead going into the final round.
Yeah.
It was the first time Santa Clara had actually competed in DBF.
Wow.
Which is impressive first showing. On the last day, we had some dust devils that were rolling through the field, so it was kind of sporty.
Yep.
In terms of the environments that people were flying in, and then the University of Graz came in, and then Melbourne, Royal Melbourne, right behind them. And they were the 2 of the last few teams to fly.
Yeah.
And they had to drop this glider into a target area.
Okay.
Both of them hit the target pretty well, whereas Santa Clara had some, let's say, some adverse conditions with the crosswinds and things.
I hear that.
So they didn't quite nail the landing on the glider as well as the other 2 teams, and that was kind of the thing that put them over the top. So we'll see how that goes.
So close competition. All right.
Interestingly enough, Graz didn't even make the field this year. So
really,
yeah, the Seychellagos didn't qualify for this year's match. So we have turnover with these teams from year to year, and so you don't always know if you're going to make it. If some of these teams that can lose a little bit of momentum year to year.
Yeah.
But it's driven by that engineering talent with the different mission design set. So.
And that's kind of the purpose of this competition, to get some hands-on skill while you're in school, and then you graduate into a much bigger aerospace industry, right?
No, it's not like F1. It's a little bit different approach, but we're excited about it.
Cool.
Oh, we've got nice conditions here. Wind's actually still pretty strong coming out, right? About 45 degrees to where the runway is.
Yeah, we got a diagonal across the runway. Now,
looks like we have Kansas coming up next.
Well, they're just in the first staging pit. Just because they're in the first pit doesn't necessarily mean that the next one's coming up. I believe we got RMIT coming here.
Oh, here we go.
Good man, good man. How are you?
Yeah, good.
Yeah?
Good.
You excited?
Yeah, always.
You guys got this. Let's go.
They've got the best gear.
Yeah.
I think they win the gear award here. They've got the Royal Melbourne's got the coolest jackets going.
While we're here talking about merch, I dig these jackets. These
jackets?
Oh yeah. Bomber AIAA bomber jackets. Pretty good. Merch game's on point.
I'm going to take responsibility for that one.
Oh yeah.
As soon as I came in, I said, "Why? We're AIAA, all about aerospace. Where's the bomber jacket?" So it became a meme actually inside of AIAA. All my staff would joke with me almost every day about, "We're working on the bomber jackets, Clay. We're working on the bomber," and we finally have them now, and we're pretty happy with them.
They are very nice. Yeah. Very nice. And then you redesigned the logo. You were telling me yesterday.
Yeah, we did that as well. It was all part of the rebrand, but this year we're really happy to be able to give out these jackets to a lot of our organizing committee members, some of the OG, the 30-year veterans that are here with us. We're super happy that they started this event. I've been talking with all of them this week and about those early days. Where they were excited just to have 12 teams sign up and 9 of them fly in that first competition.
Yeah, right?
Yeah.
And now we've gone up to what? What was it? It's like 89 teams showed up.
Yeah. Yeah, this year we had, 89 teams. So it's, okay. Looks like they're armed. Ready to go. Team from down under, Royal Melbourne.
So, just in case anybody's watching, their banner is 186 inches here. And in metric, that is 4.6 meters, almost 4.7 meters, 470 centimeters here. All right, so they've done their turn on the track here. They got to do a 360-degree turn and then got to get a deployment here. We'll see what they do. Banner's deployed. Oh, having a little bit of trouble unfurling there. Come on, unflap. Come on. Gain some airspeed. There you go. Uh-oh. She's getting close to the ground.
Oh, dear.
They brought it down for a landing.
Yeah.
But they're down intact. Had a little bit of trouble with the deployment mechanism there. They're going to have to try again.
Got caught up.
Yep. You know, it's... Some colorful language there.
Yeah. Well, didn't go as planned in the unfurl there. It looked like it got hung up somehow on the mechanism.
Yeah.
It released, it dropped down nicely, but then didn't unspool.
Okay. Chris, who do we got up next?
So up next, we've got team number 4 from the University of Notre Dame in South Bend, Indiana. Flying their plane, the Duck of the Irish. This is mission number 3, and they're going to attempt to release a 147-inch banner.
Okay.
I gotta love the names here.
Duck of the Irish, that's one of the better ones.
The Irish is one of the better ones out there.
Yeah, word safe.
No, it's good, man. It's awesome.
It's clever. They brought quite a team to Arizona last year.
Oh, yeah?
Fighting Irish, yeah. They really have an amazing program up there in South Bend, Indiana. Notre Dame, Indiana, excuse me. They've incorporated, actually.
Yep. Yeah, they did, didn't they? That's right.
It actually goes back about 20 years now. I think that they finally did that. Maybe even more, maybe 30 years that they incorporated. But I always think about it as South Bend.
Yeah, South Bend is what I learned. So
I'm not old.
Yeah, I'm getting up there too myself. You know, RMIT was just going, and they had trouble with their deployment. Let's see if Notre Dame can do it. This is their 3rd mission, so they have to deploy. You see underneath the plane, they have their banner deployment and their banner ready to go. The banner deployment mechanism.
Another top 10 team.
Yep. Oh, dealing with that wind.
Yeah.
Okay, Duck of the Irish in the air. Yep.
Got some good power in that plane.
Absolutely.
Really got up hot.
Okay, here we go. Okay, doing the turn. All right.
Here we go.
Got a good deploy. Uh-oh.
Same issue.
Yeah. All right, come on, bring it around. There we go, it unfurled. All right.
Finally released.
Yeah, there we go.
It looks like they're gone with a green lucky green banner there from the Irish.
Yep.
You know, the colors for Notre Dame are blue and gold, of course.
Yep.
They paint their helmets gold.
Yep.
They have the golden dome and gold leaf up there on campus. But green being their unofficial color because it's Irish.
Because the Irish, yeah, of course.
Absolutely.
All right, beautiful.
You know what they call informally the graduates of Notre Dame?
No, I don't.
They call them domers.
Domers?
Domers. And if you've gone there for graduate school, you're a double domer. So if you got your undergraduate and graduate degree there, you're a double domer.
Yep.
lot of manufacturing in that part of Indiana.
Absolutely.
Indiana. There's a town called Elkhart that's nearby. The conversion van capital of the.
That's right.
They build conversion vans.
Yeah.
So a lot of manufacturing. I believe AM General's up there too, where they build the Humvees.
Humvees.
Yeah.
Yeah.
A bit of.
We have a lot of those.
Yeah, a lot of automotive and engineering work there.
Yeah, big manufacturing base around the Great Lakes for sure.
Yeah.
All right, Notre Dame looking to be negotiating the course pretty well. Oh, they're battling that headwind again, Clay.
Yeah, a little bit of battle. Not quite as quick as our Slovenian compatriots, but look at that downwind. It's really taken off going downwind.
Ground speed really goes when you get into that wind. Oh man, look at it. Oh, see, that's turning around.
Coming back into the turn.
Yep. Oh man. All right, she's got it. She good. You know, we were talking about banner deployment mechanisms, you know, and how RMIT had a little bit of trouble there with their deployment. I mean, Notre Dame's doing just fine here, but banner deployment mechanisms are not easy to make.
Not easy.
My mind immediately goes, being a rocket guy, goes to like parachute deployment. That's one of the most tested things of any human-rated capsule around.
People don't understand that the parachutes are hard.
It's very complicated, very difficult to get right.
You know, for a while there was only one company in the United States, Airborne, that was making those chutes for the capsules, and then a lot of the companies in the business started designing and building their own chutes because they were having a hard time getting chute systems. They're also, you know, it's a challenge with scale. People don't understand that, but to scale, capsules have a limit because you can't build chutes that are big enough.
Yep, absolutely. And then, you know, on top of the scale, you have to deploy them in redundancy on top of that too.
Notre Dame's making good headway here.
Oh yeah, they're doing real good.
They're really flying the course well. They have a system there underneath that fuselage. Some teams have just wrapped it up and then let it drop, but they actually have a carrying mechanism there.
Yep. Once again, speaks to the design here. The design part in DBF, that really comes into play here.
Different approach.
Yep.
Trying to make that turn nice and tight.
It's tough. The wind's really. Wind's gotten. This is the most gusts I've seen here. We got winds once again coming out of the southwest, going kind of diagonal almost across the runway. That makes going down the main straight here. You see how the plane's just turning into it a little bit, trying to deal with that crosswind a little bit.
A little more altitude by this pilot.
Yep.
Ljubljana was flying a little bit lower path here.
Yep. There we go. Banner drop.
They've released.
Good release.
Okay, good release.
Duck of the Irish circling around. Crowd is loving it. Duck of the Irish circling around here.
Here we go. Coming in for the landing.
Once again, they got to negotiate that crosswind. Let's see what they do. Good approach.
Nice and soft.
There we go.
There we go. Beautiful landing.
Oh, they're going to be happy with that one, Clay. Absolutely.
That was a good show.
Yeah, absolutely. Chris, next one up. What do we got?
We've got Team 5 coming from Georgia Institute of Technology, and they're playing Buzzerang, and they're going to attempt to release a 103-inch banner, and the team tells me they're going to have an unorthodox release of this banner, so watch for it.
Okay.
Smiles all around by the team from Notre Dame.
Yep.
Good job.
Well done. Nice job, guys.
Good job.
Thank you.
Georgia Tech congratulating Notre Dame as they trade positions here on the runway. The wind's really getting...
Yeah, the wind is picking up here.
Yeah, definitely getting a little bit worse. Yep.
The Ramblin' Wreck of Georgia Tech.
There we go. The Buzzerang. Trying to deploy a 103-inch banner.
All right.
Thanks, guys.
Super
Absolutely.
job.
Did great.
It was just me. They built a really good airplane.
Yeah, there you go.
We busted. I bet we got a dozen banner flights under our belts for practice.
did 100 banner flights.
A dozen.
A dozen banner flights.
Yeah.
Okay,
And
that's
we
good.
did it. Some of them were in the middle of January, shoveling snow off the runway.
Hey, that's what you got to do. You really got the banner deployment's not easy as people think, is it?
No, not at all. One time it took the plane down because they had it hooked to the tail instead.
Oh no!
And you had a little hitch there, but once they made the turn, it unfurled.
Yeah, I came. Yeah,
that's awesome. You did great.
Yeah, thank you much.
Absolutely. Be good. There's the pilot there from Notre Dame. Now we got Georgia Tech, team number 5, taking off. Yeah, real quick.
Another speedy plane.
Yep.
Oh,
whoa.
Look at that turn.
That's awesome. Okay, doing the 360-degree turn. They said look out for the banner deployment. Here we go. All right.
Deployed.
Oh, they're not pulling it from a string. It's deployed directly off the plane.
It's like it just
flapped out.
Flapped straight down from there. They are making some speed here. They could be giving a run for their money here.
Absolutely. So, in case anybody's watching overseas, we were told it's a 103-inch banner that is 2.6 meters long. Almost on the dot.
Yeah, look at that down speed.
Oh yeah, she's going.
Downwind, it's really moving.
Yep. And as the wind picks up, the conditions are just going to get trickier and trickier for these banner deployments. Some teams have very, very big banners.
Us coming in a little bit lower, like our Slovenian friends.
Yep.
Boy, that's laboring coming upwind.
Yeah.
That you can tell the speed of that wind is really having an impact.
Right. I mean, comparatively to right when it took off, it really took off fast. Oh, the wind's pushing it up.
It really is.
Oh, okay.
Quick turn.
Yep.
This plane is very quick in the sky.
Yeah. Dealing with that tailwind now that they turned around.
Wow. Just screaming down the runway here.
Yep.
Very capable pilot here.
Yeah, absolutely. Especially dealing with these adverse conditions. This is tough. Oh, doing a low pass. There we go.
Taking a slow pass. They learned a little bit from the previous teams.
Yep.
That seems to be the run.
Yeah.
Coming in low and then taking her up high with the big turn.
Yep.
And downwind. Gaining speed.
Clay, you were right. When this plane goes downwind, it really starts moving.
Cooks. It's okay. Lowering altitude for the pass.
Yep.
A little bit cleaner down here.
Yeah.
Tarmac.
Yeah, absolutely. Definitely dealing with some winds a little bit higher up. Just look at the wind just pick that plane up into the air. Whoa, okay. You got this.
Fancy flying.
Yeah. Very good.
Flags up, taking the turn, and down.
Okay.
Georgia Tech showing their stuff.
Yeah, absolutely. 5 laps, if I heard that right.
Yeah.
That's impressive.
Kind of got this down now. It's a formula now on these laps.
Yeah.
Gain altitude up for the turn and then take her down low.
Mm-hmm. Yeah, dealing with those winds, pilot seems to have it under control. Got the low pass.
6 laps.
Yep. Man, look at the wind just take that thing up in the air.
There you go.
All right, going into turn 3 and turn 4, coming around into the headwind here. Completing lap 6 here. Oh, careful. Once again, dealing with that wind that has claimed a lot of planes today.
It has taken out a lot of flights.
Yeah. This is fascinating to watch. I just want to put it out there.
Amazing.
This is really cool.
Strategy.
Yeah.
Tactics.
Yep.
There you go. Release.
Banner drop. They got a good drop on their banner.
Yeah.
Only thing to do, bring it on home, circle around and land.
Impressive.
Yeah, that was a tour de force right there. Come on.
Here we go.
Right on the center line. You got this.
Nice and soft.
Oh, a little bit of wind. Oh, that was good.
Roar from the crowd. That was impressive flip.
Yeah. Georgia Tech with their buzzerang plane completing the third mission in style. Real good. All right, Chris, who's next?
Up next, we've got Team 6 from the University of Kansas flying their plane Icarus. They're going to attempt to release a 120-inch banner. Let's go, Jayhawks.
There we go.
Rock Chalk, we're here in Kansas. I think we got to see how this home team can perform in front of the hometown crowd.
Yep.
I guess Wichita State also. Claiming the mantle of the real hometown hero, but a lot of folks from KU made the mission. Fantastic!
You guys did great.
Piloting.
That wasn't even that sketchy.
That's all right.
The pilot said, "No, it wasn't that bad."
That sketchy. He's like, no, it wasn't that sketchy.
Okay. All right.
Impressive.
Now, Clay, this is one of the closer teams to the venue here, right?
Yeah, absolutely, yeah. We've got a few teams from Kansas here, and as I say, they've got a big contingent. There's lots of moms and dads here, by the way, from and faculty and student friends and family rooting them on.
Yeah.
And this crowd. That when you look down at the line here today,
a pretty good crowd.
A big crowd out here. A lot of folding chairs and coolers and armchair pilots out there. Cheering on their teams.
I'm here for it. This is great.
Here we go. Icarus takes to the sky.
Yep. Okay, should be getting up to banner deployment here after the 360-degree turn.
Out.
Oh no, it detached.
Detached.
Not the result you want to see.
Unfortunate.
Okay, you got to bring it back down in for a landing here.
It also looked like it had one of those leash mechanisms, right? That
Yeah.
It's going to be towing it farther behind the aircraft.
Okay, Icarus comes down, touches down. Lives to fly another day.
Not the outcome KU was expecting, but safely on the ground.
Yeah. Okay. KU vacates the runway. Chris, who do we got next?
Up next is Team 7 from the University of Texas at Dallas, my alma mater. They're flying their plane Leviathan. They're going to attempt to release a 111.25-inch banner, and a shout out to Max Pollard and Gary.
There you go.
I had a chance to go visit UT Dallas last year.
Yeah.
And they got a great program there. They were the host of one of our student conferences recently.
All right.
Very enthusiastic students there.
Oh yeah, good stuff. We love it when people love planes, right?
They love planes, they love aerospace.
Yep.
Really amazing group of folks there. I met some, I think I was mentioning this yesterday, I met some folks there that aren't even in the aerospace or mechanical engineering program, just art students, communication students, and they love what was going on, and so they're volunteering their time to help out.
There you go. I mean, there is some creativity to engineering. It's not all math and numbers.
No, I'm just
right?
saying it's interesting to see people that just have a love of what's going on in the industry.
Absolutely.
Not they're not interested in the design piece of it, but they want to help and they want to be a part of it. And I think that's the great spirit that you see. By the way, in companies, it takes all kinds of folks as well.
Right.
It's not just engineering talent. It takes sales, marketing, communications, human resources, all the management talent, finance. That's what makes an aerospace company run. So people ask me all the time, EJ, like, I'm not an engineer. How do I get involved in aerospace? There's lots of room for lots of folks out there.
Absolutely.
If you're watching this cast and you're cheering on a team, don't think that you can't play in aerospace if you don't have the engineering piece of it. There's a lot of things you can do.
Yep, absolutely. Hosted live streams is one of them. Exactly. I'm not an engineer. There we go.
There you go.
Okay. Leviathan online and armed. Once again, this is a mission 3. They have to go up, circle around to the back stretch of the track, do the turn, and then deploy the banner. Leviathan's in the air. Circling around. Okay, there's the 360-degree turn. A little squirrely into the turn, dealing with that wind. Okay, we should see a banner deployment now. Oh, it looks like they got a little bit of a deployment. Oh, stuff's getting a little squirrely back there.
Trying to shake it loose, I think.
Yeah.
The pilot's trying to shake the deployment mechanism loose because the banner will not drop.
Yep.
Doing a little bit of flying here to see if they can get it to release.
Yep.
Shimmy, shimmy. Yeah. See the leash.
Yeah, you can see it. Yeah.
They don't seem to be able to get it to.
Pilot doing a loop.
Do a little loop to see if it can deploy. It's hung up in there.
Yeah, definitely. I'm not sure if it's hung up on their landing gear or the mechanism just didn't work.
It's like we didn't get a clean release.
Yeah. All right, looks like they're circling around here for a landing, I think.
All right, so it's a challenge here. Obviously, this is not the easiest of the mission sets here.
I was saying banner deployment is tough. Getting rigging to deploy correctly. Parachutes, banners, not easy to do. Oh, yeah. Looks like they didn't get a full deployment on their front release mechanism, didn't really work. But they'll be back. They'll be back, planes down in one piece, right?
Yep, safely up.
Yep. Chris, what do we got?
Up next is Team 9 from the University of Washington, Seattle with their plane Mako. They're going to attempt to release from the top of the plane a 241.5-inch banner, and the team would like me to give a shout out to Alejandro Sora in Nimitz.
Okay.
Now we got some unique design elements on this UW plane. Tail with a V shape.
Yeah, they've got that V-tail and that contra rotor. This is one of the cooler designs I've seen here.
It's pretty slick.
Yep.
And they're going to go with a top release. I think that's the only one I've seen with a top release mechanism on the floor.
See, that explains why they had that V-tail. They're using the V-tail because they're targeting the release. Mako here on their second flight, they were moving minimum requirements of cargo, so that means they're really targeting this banner mission here.
And they've got 4 blades on that bot.
Yeah, it's
also unique. You don't see a lot of 2 and 3 blade, but not a lot of 4 blade.
Yeah, 2 contra rotating propellers.
Yeah.
Flight control surfaces checked out. Plane is armed. $241-inch banner. Play is the biggest one we've seen thus far.
Okay. And you get points for that, yeah?
Yeah, absolutely.
Size matters here.
Oh yeah. That plays into it a lot.
Okay. All right, Husky's getting ready to fly.
Now for the metric folks watching at home, they use the metric system. That's a 6-meter banner.
Those blades in action.
I love it. I love the noise.
Oh man, that's fantastic.
Yep. Okay.
team member shouting out about the flag is up. So going into the turn, the pilot can know to make that quick turn.
Okay, it made a left-hand turn. The judge is calling for a right-hand turn. There's the right-hand turn. There it is.
Okay.
Okay, we need a banner deploy here.
Banner's out.
Top deployment. Oh.
Not unfurling. There we go.
There it is.
There we go.
There it is.
All right.
All right. University of Washington, Seattle with Mako deploying their 241-inch or 6-meter banner. That is a gigantic one. Oh, they put cuts in the banner too.
Cuts in the banner. I think looking for some speed.
Yeah. Smart.
Huge banner.
Yeah.
Curious to see if they follow the lead of a couple of the other schools on that low pass.
Yep. UW banner flying high.
Yeah.
Now once again,
if you get a banner that big, you want to have a little less aerodynamic drag.
Yeah, they were smart to put cuts in there. Now once again, for the people watching at home, they had to start doing one lap here, and then they had to deploy the banner going into lap 2. And now they have to fly around with that banner for 5 minutes. And to see how many laps you can do in 5 minutes. And then after, when those 5 minutes are up, you have to deploy the banner. You have to let it go, and then you have to land the plane. Definitely the most complicated of the missions that we have here today.
Wind's picking up a little bit behind us, Jack.
Yep. Oh yeah.
Again, good downwind speed.
Yep. This is the first banner, Clay. Like as you were saying, the first banner we've seen with those cuts in it. That cuts allows for, it makes it flutter less for the most part. It allows air to pass through the banner. And it makes dealing with winds a little bit easier, which, there you go.
Looking for clean air.
Yep.
They're getting into a rhythm now.
Yeah, absolutely.
I had the opportunity to speak at the University of Washington up there in December of this year. They hosted the Students for Exploration and Development of Space SEDS conference on campus in Seattle. And it was great to be there. I spent about 5 years working in Seattle for Blue Origin, actually up in Kent.
Yeah,
near SeaTac.
Yep.
It was great to be back and see all the students there at UW.
Actually, you know, while we're here, shout out to Blue Origin. They just landed their new Glenn booster for the second time this morning.
Impressive flight.
Yeah.
I understand they had an anomaly with the second stage. They didn't fully complete the mission for, it was an off-nominal performance for the AST satellite, but I didn't see any details on the rest of that mission set. But yeah, the landing was absolutely impressive for the second time for, don't tell me the odds.
Yeah, that's right. They did good.
Reusability is a feature of launch.
Absolutely. Oh, I'm right there with you.
Drive down the cost of access to space.
Yep.
We see these systems now where they're looking at reuse. Last year, SpaceX did 40 flights on the same booster core.
That's impressive.
Blue Origin designed their boosters to perform 25 flights.
25 flights from GS1.
We did the engines on this one for the second flight to build in some new features and increase the reusability of the booster.
And I think it paid off. They nailed that landing.
Yeah, it was quite a tail slide coming into recovery to the Jacqueline ship.
Yeah.
And, you know, they have a unique system with charges in the feet of that booster.
That hold the thing down.
As soon as it touches down, they fire in and it holds it down.
Yep, there we go. Oh, UW opted for the landing right after the banner deploy.
That was
Excellent.
They let her go and landed right away.
celebration.
Stick the landing.
Yeah,
Huskies,
it was great. Team very, very proud here. Chris, you're back with us. What do we got?
Up next is Team 10 from RPI flying their plane Koi. And they're going to attempt to release a 188.5-inch banner.
Okay.
So Rensselaer Polytechnic Institute, RPI, is in Troy, New York. And I grew up just down the road in Schenectady.
Oh, all right, there you go.
Spent quite a bit of time over there at that campus when I was a kid watching hockey games.
There you go.
Yeah, it was great, great spirit over there. And a lot of my friends' dads had gone to RPI that were engineers for General Electric.
Yeah, there's GE still up there.
Yeah, they have a research and development lab that's up there, and they built the big gas turbine generators up there in Schenectady.
Yep.
Yeah.
Good stuff. I mean, Schenectady, another big industrial base up there. Real good.
It used to be called the city that lights and hauls America back in the day.
Yep.
American Locomotive was also
Alco,
based there. Yeah.
My favorite.
Yeah.
I love Alco.
Yeah, so GE, everybody's dads worked for GE. My dad did not growing up, but a lot of my friends' dads worked for GE.
There you go.
Also have hey, great job, guys.
Good job.
The Knowles Atomic Power Research Laboratory is up there as well. Just in Muskegon, New York, which is where the R&D center is, just outside of Schenectady. Shout out to the Silver Warriors of Muskegon High School, if anybody's watching. That's where I graduated from.
There you go.
Yeah.
There you go.
Yeah.
All right. So, waiting for Rensselaer to...
This is an impressive looking plane.
Yeah. Once again, the nose and the propeller all integrated into one.
The prop is
beautiful.
It's gorgeous. Also looks like she's built for speed.
Yep. Yeah, see, if we're looking at a side profile of those wings, we can get it on camera. Those wings are very, very thin and very, very long. The airfoil is a very long shape. That does favor speed. I mean,
they've got instead of just the curved winglets, you might see on a commercial aircraft, they've got some big fins.
I wasn't sure whether we should call those wing fences or winglets or what.
Yeah.
But they
extend above and below.
Yeah, exactly.
The leading edge there.
And aerodynamically, what those are designed to do is keep the air over the wing.
Yes.
And you want to move it perpendicular to the wing leading edge. It can slide left to right over the wing.
A lot of carbon fiber in this design.
Yeah. There we go, right up into the sky with that headwind.
Looks very stable.
Yep. So they have a 188.5-inch banner. We should be seeing it there. There we go.
Yeah.
Oh, perfect.
Deployed. Wow, look at that.
Perfect.
That was very clean.
Yeah.
Again, laboring a bit upwind.
Yep. Yep. That's definitely a bigger banner there. 4.76 meter on Rensselaer's banner there. RPI, of course, being the alma mater of Commander Reed Wiseman for the Artemis II mission.
That's fantastic.
Yeah, good stuff. Oh man, look at it battle the headwind. Come on, baby.
So upstate New York, between Schenectady, Albany, and Troy, we call that the Tri-City area.
Yep.
Troy, New York is very close to Cohoes. Cohoes is a place where they did a lot of shirt manufacturing.
Yeah.
Manufacturing back in the day.
Yeah, because you're right on the river. The river's right there. Hudson is right.
Hudson River there. And of course, Albany, the state capital of New York.
Yep. The Empire State.
Nice turn here.
Yep. Oh man, look at it.
A little pirouette.
Yeah, you see that? That's from that headwind.
Yeah.
Wind's getting a little bit worse coming out of the southwest here.
Also picking up speed down the runway here. This plane handles very well.
Oh yeah. As you were saying before, it's like built for speed.
Yeah. Boy, you can just tell that drag going upwind here.
Yeah, absolutely.
Not quite as low as Louisiana.
Yeah.
still trying to get flying clean air heading up.
Yeah. Yeah, we see a lot of altitude changes from the pilots looking for that clean air.
High in the turns and then low on the pass here.
Yep.
Up and down the runway.
Okay, 360-degree right turn. Oh, battle in the wind. Powering through.
She corners well.
Yeah, very nice.
I think that wing design helps.
Absolutely. And those fences on the end that you pointed out, those are really helping the air move over those wings. It makes for stable flight even in more turbulent conditions where the air can go sideways over the wing. Oh man. RPI battling that headwind through the 360-degree turn. That's tough when you're towing that banner around. A banner on these planes, guys, for the people watching at home, is like a big brake. It's a big speed brake on the back of the plane. Really, really hampers performance.
Feel that wind picking up a little bit behind us.
Yep, we got gusts. Man, ground speed is real low going into turn 1 and 2. Battling through that turn again. Once again, for mission 3, guys, you're supposed to unfurl that banner on the first lap, and then from there, it's if you get a good banner deployment, it's however many laps you can complete in 5 minutes. And then after 5 minutes are up, you have to drop the flag and then land the plane. Here we go. Oh, a lot of turbulence.
Release.
Flag deployed.
Swinging her back around.
Yep. Good deployment for RPI there. Okay. Aligned with the runway. Bringing her in. You gotta be careful. The wind's blowing 45 degrees from your screen left to right on the runway.
It's beautiful.
Didn't seem to bother RPI there.
Beautiful landing.
Great.
Handsome design. Shout from the staging pits over there. Okay. Chris, you're with us again. What do we got?
Up next is Team 11 hailing from Virginia Tech in Blacksburg, Virginia with their plane Mako. They're going to attempt to release a 154-inch banner, and this will be our 10th flight, Mission 3.
10th Mission 3. Yeah, you see that? We didn't get set on the microphone, but as Rensselaer moves off, RPI moves off, Virginia Tech moves on, the Virginia Tech team congratulated RPI there. That shows that this is a team sport.
Absolutely.
It's a tough competition.
Good showmanship and sportsmanship. A lot of camaraderie amongst the teams. I talked to several teams in the hangar today that were helping each other rebuild motors, share parts, provide advice on some of the deployment mechanisms. It really shows you that everybody's all in on this one. Everybody wants to see everybody else succeed.
Yep.
So a lot of sweat, sweat and effort goes into these things, and everybody's here to learn. That's the big piece of it.
Absolutely. A little bit earlier in the day, we had University of Maine come up, and they had a bunch of other schools written on the side of their plane. That was all the other schools that helped them.
Here we go, taking off.
Build their plane.
The Hokies are in the sky.
Yep. Once again, dealing with that wind again. Gaining a lot of altitude going into turn 1. Okay, completed the turn. Here we go for banner.
This is the 150th flight.
Wow. Okay.
Clean. 150th flight.
Yep.
For this aircraft. Impressive. Also with a leash design here on the banner.
Yeah.
Very clean deployment.
Yeah, looks great.
Yeah.
So here on day 3, we've had 150 flights.
Struggling with that wind up there.
Oh yeah. Oh man, that wind's getting to be.
It's really taking it on. It's picked up quite a bit.
Yep. So this is the 10th mission 3 that we've had today on day 3 of the 2026 AIAA Design, Build, and Fly DBF competition here. Mission 3, of course, being a banner deployment. You have to deploy your banner, then you have to fly the course. You have 5 minutes to do as many laps as possible. Got to drop the banner after 5 minutes and then land the plane. Now that might not sound like a lot, but that is it's a tall order, especially with the wind. You see the plane kind of oscillating up and down. That's catching the turbulence and catching that wind. Oh, come on, bring it around.
Tech choosing a much higher altitude, I think, than the previous teams we've seen.
Yeah, keeping that plane up in the air. Altitude's the best insurance, right?
They're coming in a bit lower for this pass. They're looking for cleaner air, I think. Boy, it's really gusting.
Yep.
I'm glad I got the bomber jacket on.
Yeah, me too. Really nice bomber jackets with a really nice logo. Okay.
There we go.
Banner deployment is good.
And they're going to land. Nope. Yep. There we go.
Oh, the wind. Oh.
All right.
Good landing.
Roar from the ODT.
Yeah, there we go.
I visited with them earlier today too. They had a caravan coming out here, folks. Really a huge contingent. A lot of family as well with them. It's great to visit with the team.
Cool. Yeah, and it seems like they brought their own cheering section there. Pilot flying the Virginia Tech banner.
Yeah.
Good job, man.
We watched them do their ground mission as well, and it was super impressive.
Yeah.
Yeah, a lot of speed.
Oh, yeah. Okay, Chris, who do we got next?
Coming up next is Team 12, coming from Embry-Riddle Aeronautical University in Daytona Beach, flying their plane Perry. This is mission 2 for the team. They've got 110 ducks and 36 pucks, which is really probably the highest amount of pucks we've seen out here. And they also asked me to give a shout out to Max Collin and Soraya's parents and the wonderful team here in the hangar.
There you go.
I visited with these guys as well this morning, and the kids are fired up. They're fired up. This plane is called the Platypus.
The Platypus.
Because it's named after the Phineas and Ferb, Perry the Platypus character from the cartoon show.
Nice.
And I was asking them how that generated it, and they said, well, we kept building it. When the more we looked at it, the more I thought, it looks like a platypus.
There you go.
And it's got that blue collar, so they just went with the Perry the Platypus name.
Yep.
Yeah.
Looks great. So once again, we've seen a couple of banner deployments. This one is a cargo mission, so this is mission 2.
Yeah.
Okay. Arming the engine. Thumbs up from the ground crew.
All right.
So the cargo on board takes the form of, well, passengers and payload. There's no people on board. We got rubber ducks as our passengers today, and then hockey pucks as the cargo. Flight control surface check out there.
The older folks listening, hockey puck was Donald Rickles. Remember Don Rickles?
Yeah, absolutely.
Talk about a hockey puck as a term for somebody that wasn't quite with it.
What are you looking at, you hockey puck?
Yeah.
Okay. taking a turn.
Platypus is flying well.
Oh yeah. Negotiating the winds pretty well. 360-degree right turn.
Doesn't seem to have any instability issues with all that cargo aboard.
No, flying really well. In some cases, loading out the cargo could give you better moment. It makes them more stable flying. Wow, it's got a lot of altitude there.
It's really high.
Beautiful, beautiful. Now with the cargo mission, obviously you got to take off. You got to fly the course. But just like mission 3 that we've seen a little bit earlier today, mission 2 is about how many laps you can do with that cargo. Again, EROW Daytona Beach opted for a lot of altitude there. Have you ever been down to that campus?
I have not.
No?
I have not. I've had a few of their students intern for me over the years.
Yeah.
Great students. Shout out to Joe, who interned for us last year at AIAA headquarters. But I've had a few in my previous jobs where they've interned for me as well.
Great.
Diane Howard used to instruct there, a good friend of mine, and I used to take her students on board. I was remarking earlier today, they're Embry-Riddle Aeronautical University. I think it's the only school here with aeronautical in the name of the school.
Yeah. That's right.
Yeah.
I mean, yeah.
We have two Embry-Riddles here. The one from Daytona Beach and the one out west in Arizona.
Yep. Prescott.
At Prescott.
Yep. The campus is right at Daytona International Airport. It's right by the Speedway, so. It seems like Daytona Beach, they like things that go fast.
I think that's right. I remember going there for spring break my sophomore year.
Yeah, there we go.
There you go, old school.
Yep, good times.
But known as one of the best aerospace programs in the country.
Absolutely.
Embry-Riddle.
Yep.
And really specializing in it.
Yeah,
it's impressive.
Like you said, aeronautical's right in that name.
Yeah.
All right, pilots circling around for a landing, looking to complete mission 2.
Looks good.
For EROW Daytona Beach. Coming around, lined with the runway.
And soft.
Oh yeah. Oh, that was beautiful.
And a huge roar.
That was nice. Very good.
Pretty happy.
Yep. All right, Chris, you're back with us. What do we got? Very excited from Embry-Riddle.
So up next is Team 13 from the University of California, Los Angeles, for their plane Duck, Duck, Goose, and they're going to attempt to release a 249-inch banner.
Okay.
We got the team here with the DBF 30th anniversary hat, and he's got a duck glued to the bill of the hat.
Oh yeah.
Kind of gotta like that.
Yeah. Hey,
that's a great look.
Respect it. Now this UCLA plane, I watched this fly the past couple of days. This one books.
This plane is impressive. I visited with these guys again in the hangar this morning. Talked to them. Huge crew. They came out in 4 vans and a caravan.
Wow.
Drove out from LA. And they've got a huge contingent here. Really impressive group of engineering students.
Cheers from Embry-Riddle there. Their crowd's still going nuts over there.
Yeah. Another aircraft built for speed.
Oh yeah. Long fuselage. Control surfaces far away from the center of gravity as possible.
like that lightweight landing gear setup they got too.
Oh yeah, they really put a lot of thought into that one.
Here we go. Looks like she's armed.
Okay. Okay, we got a 249-inch banner here, which is the biggest one that we've seen. For the people at home watching, that doesn't make any sense there. We have a 6.28 meter banner from UCLA here.
Flag.
Okay, 360-degree right turn. Now, Clay, if I'm looking at that right, it looks like they got kind of a pilot there.
Yeah,
little
they've got a
little pilot thing coming out the top or bottom there.
Yeah, trailing.
Yeah, similar to like a pilot chute for, for a parachute.
Or like a drogue.
Yep.
And cleaning out.
Oh,
Look at that.
very
Great
nice.
deployment. I think that's the smoothest one we've seen.
Yeah, that was nice.
Great engineering on that release.
Yep.
Lots of different mechanisms we saw on the floor of the hangar today about how these systems would actually deploy and unfurl. Different approaches.
Yeah, we saw one that deployed upwards and over. We've seen ones that deployed down. We've seen ones deployed down that stayed with the airplane fixed.
Yep, fixed. That was a unique one.
Yeah.
All right, we're ending lap 1 here.
Okay, observers calling lap 1 for UCLA. That headwind's getting worse. Going flying southbound. That's where they're flying right now.
Of course, UCLA's women's team won the national championship in basketball this year. It was very impressive.
Oh yeah.
Beating South Carolina.
Nice.
And UConn on the way to their victory.
That's not
Final Four. That's some impressive wins over two of the top programs in the country.
I was gonna say.
Been kind of trading punches over the last few years in terms of championships. And those the women at UCLA did an amazing job in that game. It was quite a victory.
Yeah. Yeah. Teams you mentioned certainly are no slouches, that's for sure.
No advertising on these banners. You know, I'm used to being at the beach and you see the planes coming.
Right.
You know, got to buy sunscreen or
don't
get a taco at the local restaurant or something. But we don't see any. It's just the straight up blue on this one.
Yeah, I'm looking for like Big Al's truck stop or something.
Although we've got quite a few folks here in the Buc-ee's gear. Have you seen that?
Hey.
And one that's dressed up in all red panda suits today that are out on the floor. Really interesting that the creativity of some of these teams.
That shows the cohesion that some of these teams have, right?
There's a lot of spirit on the floor here. We love seeing that.
Yeah, absolutely.
They're having fun while engineering and flying.
And that's a winning ticket right there, Clay.
Absolutely. It seems to have settled down a little bit here.
Yeah, it's not too bad. Still blowing, it's kind of a crosswind. We're 45 degrees across the runway here. Trending back more towards a crosswind though.
Duck Goose is making spaces here.
Yeah.
Solid aircraft.
Yeah. And that 249-inch banner is the biggest one. That's the longest one we've seen.
So you get the extra points for that.
Yep.
All right, we're ending lap 3 here.
Okay, calling out the end of lap 3
Yep.
by one of the teams.
Start lap 4.
Trying to remember now the number of laps that we saw earlier. We saw 6, 7, 8 laps.
I think we saw 7. 7 laps was the most.
Yeah.
Flag.
Back in there.
Okay, doing that turn, dealing with that headwind again. Clay, you've called every banner flight here with me. I'd say this one is going pretty smoothly.
Very clean, very clean. This team also did a lot of testing, they were telling me. They did in-tunnel testing. They did flight testing.
Yeah.
Of course, Southern California, nice place to test.
Yeah.
One of the teams. Oh, there we go with the release.
Yep. Banner's dropped.
Just missed the photographer.
Yeah. Almost took out the photographer over there.
Okay. And
circling around.
Land the other way. By the way, you are allowed to land either direction on this runway.
Oh yeah. Oh.
All right.
Putting some work in that suspension design. There you go.
Good string.
Yeah.
Very happy, UCLA team. Wait till the prop stops turning to run out there.
There you go.
Safety first always at DBF. Huge cheer from the crowd. Bruins performed well. Big hugs all around.
There you go. Oh, they love to see it. Okay, Chris, who's next?
Up next is Team 14 coming from the Universidad de Antioquia, and they're playing Scorpion, and they're going to attempt to release a 258-inch banner.
250. Oh, that would be the biggest one.
Just keep going up in banners.
Yeah, right. UCLA team's still bouncing around up there.
Yeah, a lot of joy.
Yep. The headwind's turning their propeller.
Yeah.
That really is they really got a pretty plane there.
It's very pretty. Really nicely designed, and it's just a good-looking aircraft.
Yeah, you can tell they put in the work.
I love that gear system when you showed it really came into play there.
Yeah, right.
The skip and the hop on the landing, but it deployed quite nicely. And great flight, guys. Well done.
Good job, dude.
Yeah. Cheers.
Thank you.
Yeah.
Boom. They're loving it.
They're having a great time out here today. That's what it's all about.
Okay, so if you've been watching along here, we're at the 2026 AIAA Design Build Fly competition. I'm EJ, your host, and I got Clay Morey here, CEO of the AIAA. We're here commentating down here on the flight line, watching Mission 3 banner flights, Mission 2 cargo flights, and even some Mission 1 test flights here today on day 3. Now, the next team we have coming up here is team number 14. It's the Universidad de Antioquia, flying their Scorpion plane, and they're going to deploy a 258-inch banner here.
Massive.
That's the biggest one we've seen.
That's a massive one.
Cheers from the UCLA team behind us.
You can see the size of that thing underneath the fuselage there. It's quite a banner.
Yep. Universidad de Antioquia, one of the international teams here, right?
Yeah, we've got 15 countries here with us, and several from the Pacific, Indo-Pacific, several from Latin America, a number from Europe.
Yeah.
And they have come to play, ladies and gentlemen. Let me tell you what, these guys are not messing around.
No, absolutely.
They've got this figured out. They've worked the formulas. They've looked at how they can compete at different levels. Some focused on ground, optimized for ground, some on flight.
Okay.
Fully armed.
Yep.
All right, here we go.
Prop is on. Let's do this. See how they work with the wind.
It's a quick plane.
Oh yeah, good thrust to weight there.
And the wind has settled down a bit here.
Yeah, it's going to work in their favor for sure.
I think the conditions are optimal. Already deployed.
Oh no!
Oh, too bad.
The banner did go, but
but they hadn't completed their turn first, so I think that just might have been a unscheduled deployment.
Yeah.
A lot of drag. That size banner underneath the fuselage.
Yeah, definitely. Universidad de Antioquia bringing their plane in for a heading alignment onto the runway. Oh, a little bit of windage.
Get still.
Tough negotiating that wind. Good landing.
Yeah.
Not what they want to see.
Too bad.
Yeah. Okay, Chris, keep them firing. Who do we got?
Up next is Team 15 from Auburn University at Auburn, and they're playing Independence, and they're going to attempt to release a 119-inch banner.
Okay. Auburn, 119-inch banner, team number 15. with their Mission 3 first attempt. Looks like, go ahead.
I was just going to say Auburn Tigers, but also War Eagle.
Yeah.
I'm not sure they kind of got two monikers there.
Yeah, they do. Yeah, they do.
War Eagle but they're the Tigers.
Hmm. Hey, whatever works, right?
Whatever works.
Okay, so they got...
Somebody's going to get us in the comments.
They always do. That's the secret.
No, I'm a big fan of Auburn. I've had a number of Auburn grads actually work for me in industry. Terrific school, a lot of spirit, huge rivalries down there in that football conference.
Oh yeah.
This is a good looking plane we have out here.
Yeah.
It looks sleek and fast. How big did we say that the banner is?
Banner on Independence, there's 119 inches.
Okay.
It's not the biggest one we've seen, but still pretty hefty.
Pretty sizable. We'll pick it up a little bit more now.
Yeah, we got the gusts.
Laid down for that last mission. They're trying to get the banner off the tarmac here on the cross runway here and get this clean so Auburn can show their stuff.
Yep.
For those watching at home, we are circled on this airfield by hangars from all of these Beechcraft and Cessna and other Textron aviation companies here. It's a great little spot to be flying. And it's really thanks to these guys that we can use this airfield, shut it down for us for 3.5 days to fly.
Gave us a whole weekend, long weekend.
So we thanks to the team at Textron that makes this happen. We've got a lot of support from them, by the way, the ground vehicles and other things going on here. Without them, we couldn't make this work and get all these teams through their paces.
Absolutely. And not only that, the hangars from the Textron Employee Aviation Club.
Yeah, the Aviation Club is where we're nestled. In fact, just behind where the main hangar floor is there. They've got the Aviation Club, and there's several aircraft right inside the hangar there. I've had the pleasure to go check out this week.
Beautiful planes.
Really beautiful, beautiful planes.
Speaking of beautiful, there we go.
We're up, flying, quick turn.
Auburn with Independence up in the air.
It's moving.
Yeah, that plane's boogieing. There's the turn.
Quick turn.
Yep. All right, here we go for the banner. Oh.
It's out. It's clean.
There we go. Good deploy. Good. You know, as we watch more of these missions, Clay, it's kind of, the banner deployment is a big deal.
It really is.
That's really one of the hardest parts of this whole flight envelope here.
Getting it out there clean, the release, and then watching the unfurl as well.
Yeah.
Because a number of these ones have gotten hung up.
Yep.
Actually on the mechanism itself, not a clean deployment.
Doesn't seem to be a problem for Auburn, though.
They are streaking here. This is really moving out.
Yep. Really challenging with that wind there. The wind is picking up, and it's not necessarily going with the runway. We got 45 degrees over the runway there, and so we got a little bit of a crosswind condition. It's closer to being aligned with the runway though than it is being a total like perpendicular crosswind though. But it is gusting. We got a lot of gusts going on here. So if you see the planes kind of rattle around a little bit, it's because they got those wind gusts. You see the pilots kind of trying to go up or down, trying to find where that clean air is and try to get that plane to fly straight. Once again, this is Auburn University, flying their Independence plane with a 119-inch banner. This is their Mission 3. Mission 3 is where you have to deploy that banner, and then you see how many laps you can do with that banner tugging at your heels there. And that's what it is doing with this wind. You have 5 minutes to complete as many laps as possible.
Auburn, of course, team hails from Alabama, which is home to NASA's Marshall.
There you go, Marshall Space Flight
Facility. So great heritage there. Redstone Arsenal.
Yep.
We're the teams that built the first Saturn V rockets.
Yep.
Way back in the day.
First
they also
S1C.
do quite a bit of work on missile defense in that area of the country. There's the Army down there, and the Air Force, or excuse me, Space Force Space Command is moving to Alabama.
That's right. They did just move it.
Yeah. Well, they're building a new facility down there for the headquarters.
Great. Yeah, another aerospace giant.
Absolutely.
Around the U.S.
Huge amount of infrastructure there. Senator Shelby, Richard Shelby, was really at the forefront of bringing a lot of companies down there and encouraging the growth of that industry in Huntsville, in the Huntsville area, but also down in Mobile.
Oh, yeah.
Huge facility down there. Airbus making aircraft down there.
Yep.
And really an amazing industry in Alabama that supports the aerospace industry.
And I believe Blue Origin built a big facility down there too for propulsion.
They do. So they have a huge facility that manufactures BE4 liquefied natural gas engines and BE3U upper stages that are down there. They also took over the engine test stand.
Yeah.
Where they tested the old F1 engines for the Saturn V program that flew for Apollo.
Yeah.
And that was quite an undertaking. I'll tell you, I was working for Blue Origin at the time.
Oh, yeah.
To actually overhaul that engine test stand.
4670 test stand, yep.
46, exactly right. And 4670, I can't remember what the exact number of feet in terms of wiring and the plumbing they had to take out there and reinstall because it had been in a state of disrepair for quite some time. But they're super proud to be hot firing on that stand down there in Huntsville.
4670 test stand was where they first tested a Saturn V first stage.
Yeah.
And then it was used later for shuttle engine testing.
Clean release on the banner.
There we go.
Banking around. Auburn looking good.
Yeah, great release.
Nice mission set.
Okay, coming around.
All right.
Once again, negotiating that wind is going to be a little bit tricky.
Yeah, it's picking up behind us.
There we go.
Nice and clean.
Oh, very nice.
Soft, yeah.
Very nice.
Ah, a little spin there. A little flourish at the end of that landing.
Not bad, not bad.
Big hugs.
Yep.
All right.
Banner, right now.
Very good, Tiger. All right.
There we go. All right, so that was Auburn with Independence there. Chris, who do we got next?
Up next is Team 16 coming from Purdue University main campus with their plane Quack Edie, and they're attempting Mission 3 with the 58-inch banner.
Okay.
Boiler up.
Yeah, Purdue, here we go.
They say with Purdue. Boiler makers.
Yep.
A lot of aerospace engineers coming out of Purdue. It's one of the most famed programs in the country. Amazing heritage.
Do believe
some of the Apollo Air astronauts.
That's what I was going with. Yep.
Go ahead, please.
Neil Armstrong.
Neil Armstrong.
Oh yeah.
A lot of them taught there as well.
He did, yeah.
And I've got a lot of friends that are Purdue grads. Sarisha Bandla, my good friend, who flew on Virgin Galactic's first flight.
Oh yeah.
She's a Purdue alum, a proud Purdue alum. I don't know if she's watching, but shout out to Sarisha. She's a rock star.
Yep.
A ton of great, and then Dan Dumbacher, who was my predecessor as CEO of AIAA, also taught at Purdue University, and is a stalwart in the aerospace industry.
Is there anybody you don't know? You know a lot of people, man.
I do know a lot of people. It's great. That's what I love about this industry.
Yeah.
Is the people in it that make it so special. Everybody's nice. Everybody's trying to help each other. I think it's really one of the best industries you can possibly work in, to be honest with you. Everybody's rooting for each other. We all want each other to be successful. Nobody likes to see failure in our business.
And then, it just shows this is hard stuff to do. It's not easy. That's why everybody cheers everybody on.
Aerospace is hard, and we say
tough.
that all the time. But you know what? We put 1 million people in the air safely over the United States every day.
Yep.
That's important. Here we go. Oil her up. Let's see her take off.
Quack Edie with Purdue in the air.
Interesting tail design.
So they have 2 vertical stabilizers, and I believe they opted for 2 V-stabs because their deployment mechanism is in the center.
Interesting.
Yeah. Purdue opting for a twin engine design here too. Okay, doing the turn. Purdue looking at a 58-inch banner here. There we go. Pilot shoots out, and we got a good deploy.
Nice and clean. Some of the teams telling me that they had done actual wind tunnel testing.
Yeah.
With these chutes,
Really?
which I thought was fascinating. And we've seen different approaches here. Some of them directly behind the aircraft, some just underneath, and some on a much longer leash. And I'm wondering what the effects of those different design elements are in terms of drag and resistance.
Yeah, we even saw one that had relief holes cut in it to prevent the flag from fluttering a little bit.
Different design approaches here, trying to adapt to the requirements set for this Mission 3. And a lot of calculation goes into this because it's a complex formula, the numerator and denominator around the length and size of the banner, and then how that affects your speed during this mission set. And the complexity of deployment, as we talked about earlier.
Yeah, that banner flapping around back there is basically a big break.
What this aircraft's doing quite well.
Yeah,
it's not laboring. Clearly, that those bigger banners were a hindrance going upwind here, and this plane is actually really, I think, ripping the laps.
Yeah, Purdue's looking real good here.
So maybe smaller banner, you get some advantage on the. And I don't know how that formula is going to work overall. We'll see.
You know, this is my first time being a DBF, right? And I've been reading the rules. I've been going over the rules throughout the weekend, and you know, I really like that the rules are wide open enough to really not have a convergent design here.
Yeah.
You know, you look at like a airliner, right? Like 737 or an A320. They look very similar to the untrained eye, right? You don't have a convergent design here. You guys give the space to allow for all different types of planes flying around.
It's off.
There we go.
Banner's down. Safely on the runway. You know, that's intentional by our organizing committee. They want to provide latitude in there so that they can get creative with the designs. And I love that. And that's really a hallmark of DBF versus other competitions that you see out there where it's just tweaking designs year over year. This gives a lot of design freedom to the engineering teams.
Yep, that's
great.
That's cool.
That's how you're going to learn.
Yep.
You're going to see different approaches, and we love that. The diversity of approaches here. Already got the banner off the runway.
Yeah. Guess it was okay while the plane was coming in for approach.
Clean deck the way out here.
There we go. Come on, Purdue. Bring it home.
That is a beautiful landing right there.
That was pretty textbook. Not bad. Not bad. Purdue with Quack Edie. Yep, there we go.
I'll be back.
Okay, Chris, coming from the staging pits, who do we got?
Up next, we've got Team 20 coming from the University of Missouri, Columbia, with their plane Bengal, and they're flying Mission 2, and they're going to have a total of 12 ducks and 4 pucks.
12 and 4. Okay. Got it. Good luck, guys.
Good luck.
You got this.
Again, congratulations going out from the last team.
Yep. Like you said, team sport. Teamwork makes the dream work.
Thank you, Dad.
A number of the teams I talked to said that was their favorite part of this. Was getting to know the other teams.
Right.
Other engineers from around the country, and the spirit of cooperation that's here. Everybody's rooting each other on. They make lifetime friends here at DBF.
There you go.
And you know, maybe you end up out in the industry working together someday. actually seen some marriages come out of this.
Really? No way. All right.
Oh yeah.
That's great.
Over 30 years to see this and have it grow. We're very proud of this competition. In a way, it's really our flagship competition, and one that I think it'd be tough to replicate for other organizations because our volunteers are so involved in designing this, so clever around what they've laid out here for the parameters of it. Gets more and more creative every year.
Yeah, I like it. Fun. It's a fun time. You know.
Oops. Cheer for
oh no.
Okay.
University of Missouri Columbia. Ducks are out.
Ducks are out. Ducks hit the deck there, unfortunately. Duck recovery happening right now.
So they were attempting a mission 2. So we did have ducks and pucks on board. 12 and 4.
That crosswind just
it's wreaking havoc. Yeah, I watched this plane fly before. It flew pretty well. That was the wind. Absolutely.
Too bad.
Yeah. It's not what you want to see, but the plane looks to be intact. It might be good for another attempt. It's all right, guys. That's all right. Plane's good. You'll be back. Okay, Chris, with an update.
Up now is Team 18 from Valor Institute of Technology with their plane Maran, which means warrior, and they're flying with Mission 2 with 3 ducks and 1 puck.
Okay. No, good.
This team, I kind of adopted this team a little bit. They're one of my biggest followers on social media at AIAA Clay.
Oh,
super engaged. This is the second time they're competing with us. I met with them and their advisor. They're just a terrific set of kids. Make their way here from very, very far away. I mean, this is, I can't remember, but I think it was 4 flights that they took to get here.
That's a long way.
But they're very passionate about DBF and excited to compete.
Now, when you say AIAA Clay, is that Instagram?
That's my Instagram handle.
All right, there you go.
AIAA Clay, if you're out there, if you want to follow me, here we go. Get ready to take off.
Warrior takes to the air. Oh, no.
It's tough.
Crew's going out and inspecting the plane. It's not what you want to see.
That crosswind got them right after takeoff.
Yeah.
Nose down.
Oh.
It looks like the tail disassembled here, but otherwise, plane more or less intact.
Yeah?
Yeah.
The Warrior will live to fight another day.
Yeah. I think they might have lost a blade on the prop.
Oof. Okay, Chris, fresh from the staging pits, what do you got?
Up next is Team 21 coming from the University of Michigan, Ann Arbor, and they're playing Frankenstein. And this is Mission 2. They're going to fly with the second highest amount of ducks of 154, and the largest number of ducks of 154, and the second highest pucks of 26.
That's a huge payload capacity there. I think we saw 151 yesterday.
Yep.
Was the 151. So 154 is a record here for us. Twin engine design on the Wolverines aircraft here.
Oh, yeah.
Similar to USC's design.
Yeah, there we go.
It's a giant wing that provides the capacity.
Go blue.
To handle.
Oh, yeah.
Michigan Wolverines.
Yep.
Out on the tarmac.
You got a heck of a football program up there.
I sure do. Yeah, I sure do.
Earlier this year, I had the pleasure of going to see in that stadium. That is a big stadium.
Big house, huh?
Yep.
Mission getting ready to arm.
Yep. Engine 1, engine 2. Okay.
Again, design philosophy similar to the Trojan horse.
Yeah.
But a little bit different setup on the prop system and the edge of the wings.
They got a, once again, because you're carrying the cargo on the wing, you got a big jumbo airfoil, which you need. That should be for lower speed with an airfoil that big, but this thing should generate crazy amounts of lift with those two engines. Okay. Oh no, looks like the right gear.
Hung up there, right gear is a problem.
Yeah.
Okay, they're gonna defuse the aircraft here.
Yeah.
Safe it.
Yep, safe the aircraft. You take the blade fuses out.
You got two fuses here.
Yep.
Engine to side. All right.
This good, Daniel?
That crosswind's really picking up.
Yeah, it's really getting those planes.
You can really feel it.
Oh yeah.
Okay. Rearming for second attempt. See if we can get a stable takeoff.
Okay. A lot of the teams, when they put that fuse in, they have the system play a little chime to indicate that the engine's good.
Exactly.
Come on, get up. There we go.
All right.
Frankenstein in the air.
Frankenstein takes flight. Need a little Black Sabbath playing there.
Yeah. You're talking about Black Sabbath. One of the that just reminds me when they played Planet Caravan for Bob Benken and Doug Hurley on their DM2 mission. One of the best wake-up music songs I've ever seen.
They got a lot of play, the wake-up music.
Yeah.
The Artemis mission. All of a sudden, that was like a thing.
Yeah, absolutely.
It's nice and smooth in flight.
Yeah, like I said, that wing generated a lot of lift. Nice and stable. And you got those two engines to move it.
154 ducks.
Yeah, that's a lot. And not only that, 26 hockey pucks.
That's a heavy payload.
Yeah.
You know, those pucks are dense and heavy.
Yeah.
Absolutely impacts the. Maybe that's why it took so long to get off the ground.
Yeah.
With all that lift, that's a heavy payload for a plane that size.
Got to get some airspeed for sure. And actually, that wind worked in their favor there when they took off. Got to get more air over the wings.
Exactly.
Now, once again, for everybody that's watching, this is a cargo flight for Michigan here. Cargo flight meaning you load payload in the form of rubber ducks and hockey pucks. In the case of Michigan, they got it in the wings. The cargo holds are in the wings. And what they have to do here, once the plane gets up in the air, you have 5 minutes to fly as many laps as you possibly can around our track. And you're obviously graded on how many ducks you're carrying, how many pucks you're carrying, and how many laps you can do, right? Faster the better, because these teams are here out trying to generate some profit here for their bush planes, towing banners and moving ducks around. And that actually is how they are graded. They make profit from these missions in the form of duck coin. No, that's not a real currency. But that's the scoring system for this, how much you get paid. It's actually pretty cool, pretty unique scoring system. How they discern how much they make? It was some math formulas that I am not doing on stream because I don't like doing math in public. You hear that? Great reminder that Wichita, always something flying in the air.
That's right. General aviation capital of the world here.
Yep.
Air capital of the world.
Okay.
Low pass here.
Yeah. Oh, battling that wind. Oh no. Come on. Hey, that still counts.
That still counts.
That still counts.
Kicking wheels down the tarmac here, but okay.
Yep.
Down the runway. Actually, they both rolled right nice to each other. That was cool. That was interesting.
Yeah.
So
But
now that they've had the most ducks in the air, do they get to claim Duck Dynasty status here? What do we got?
I think so. I think so. We got to grow beards out now, or they got to grow beards out now.
Grow some beards.
One roll to the right of the grass, so I find the grass.
All right, they're going for the wheels here.
Okay. Chris, you're with me. What do we got?
Up next is Team 22 coming from the University of California, Irvine, with the Flying Duckman in their plane, and this is their second attempt at Mission 1.
Okay, flight test for UC Irvine here. Flying Duckman, I like it.
Flying Duck. Another team from Southern California. We've got several teams from Southern California here with us.
Another big aviation hub down there.
Absolutely. Well, Southern California, of course, known for its aviation and defense businesses.
Absolutely.
All across that Southern California area, from San Diego all the way up through Los Angeles. Some incredible heritage in the aviation world. Satellites, big aircraft,
rockets,
all kinds of stuff, propulsion systems, subsystems, and a lot of startups there now.
There is a lot of startups,
tremendous, a lot of space companies like Vast, and a lot of spin-offs from SpaceX, ex-SpaceX employees that have started companies.
I believe Relativity Space has the hangars where the C-17 was made.
Yep. Virgin's down there. Companies building systems down there. It's really exciting to go visit that.
Oh, it's cool.
Yeah, I've had some great tours down there.
I bet.
Even rovers they're building down there.
Yeah. Okay. UC Irvine with the Flying Duckman doing their flight test here on day 3. Ground crews, arm the plane, and they're in position. Pilots declaring takeoff.
Here we go.
Oh, come on. Get going.
They're all adjusting that crosswind right at the beginning.
There we go.
There we go. We're up. It throws that pilot off right at the beginning.
Yeah.
They're just getting a little squirrely coming out of the chute.
Yeah, you tend to see an overcorrection.
Exactly. He's flying well now.
Yeah. Oh.
That crosswind got him there. On the turn.
Exactly. You see it really comes into play with these planes when you start to see the turn. It gets a little aerodynamically unstable.
This plane's actually pretty quick in the sky.
Yeah, pretty nimble. All right. So, we haven't seen a Mission 1 in a little while here. So what Mission 1 entails is doing 3 laps around the track, but you only have 5 minutes to do it. But you have to complete 3 laps. Mission 2 and Mission 3 are more about how many laps you can do in 5 minutes. But Mission 1, flight test of the vehicle, is complete in 3 laps, and you have 5 minutes to do it. That's basically qualifying you for the cargo flights and the banner flights, which is what we've seen today. We've seen all 3 mission types today. And then, of course, there's Mission 4. There's the ground missions, which are how quickly you can reconfigure your plane from Mission 1 config to Mission 2 config to Mission 3 config. That counts, being able to do what's called turn around the aircraft. Not physically. Turn around means the difference, the time down on the ground between flights.
UC Irvine, of course, are the anteaters.
The anteaters, that's right.
And the mascot is Peter the Anteater.
Peter the Anteater.
There you go.
Nice.
I don't think I've ever seen an anteater fly.
No, but if they could, they'd be flying like that, you know? Flying great.
This plane is really moving out.
Yeah.
It's one of the quicker ones we've seen today.
Yeah, they UC Irvine's opting for a little shorter fuselage, right?
Exactly.
That makes the plane
shorter wingspan and shorter fuselage.
Makes it a lot more nimble. Very nimble plane there. Okay.
They've completed their mission 1 criteria.
Yeah, just got to bring it on home. Pilot's circling around.
You got the banana slugs up in Santa Cruz. You got the anteaters down in Irvine.
Yep.
Some great creative mascots.
Saw you. Yeah, there we go. Saw UCLA with the Bruins.
The Bruins.
Yeah, great. Flying Duckman.
Flying Duckman, nice flight.
There you go.
Good mission 1.
Yeah, absolutely.
One person has to get behind us. For that,
And fresh from the staging pits, we have Chris Horton with us again.
Back again. So up next is Team 23 coming from the University of Buffalo with their plane Razorbill. This is mission 2 for the team, and they're carrying 21 ducks and 3 pucks.
It used to be called SUNY Buffalo when I was growing up in upstate New York.
Oh, yeah?
University of New York, so now it's SUNY University at Buffalo.
Yeah.
They're the Bulls. And my brother Chris is a proud graduate of the University of Buffalo.
There you go.
I also got to give a shout out to Brad Cheatham, who's the CEO of Advanced Aerospace.
Oh.
Who's a Buffalo grad. And Brad was one of the guys who came up with some of the interesting orbits for lunar missions that have been flying.
Oh.
He's really a genius. He went to UC Boulder for his graduate degrees, PhD studies. He's really a savant when it comes to novel orbits.
Lunar orbits are not as tricky as people think they are. The moon has non-uniform gravitational pull because of its composition. So you can actually have a decaying orbit around the moon. It'll deorbit you if you're not careful.
His company's actually looking at some of this new configuration for Artemis, what they're going to do with some of these orbits right now.
Yeah. Oh.
Okay, come on.
Looks like they don't have the right engine.
Yeah. One prop spinning, the other is it's not. All right. Check the fuses on this.
Okay. Judges saying go and check the fuses.
Left top prop is rotating, right prop standing still on this.
Now the twin engine design is good. You know, you have one.
You're working in sync though.
Yeah, they have to both go. It's good if you're flying and one goes, but not for takeoff. Takeoff, you're going to move your center of thrust away from your center of gravity of the airplane. Basically, one engine, if the left engine's going, you're gonna turn to the right if the right engine is not going as well. Center of thrust moving to the left side of the airplane.
We've been hearing behind us, on the cross right here, some of the teams testing their engines, giving them a quick little burst just to see when it's on the ground, held down.
Yep.
If the engines are functioning properly, particularly in this twin engine design. So still got one turning and the other one not. This may be a no-go.
Oh no.
I think we're scrubbing on this.
Yep. Team's safing the one operable engine.
All right, no-go for the Bulls.
They'll be back. University of Buffalo bringing their plane past us here in the commentator pit. Hey, work the problem, guys. You got this. You got this.
Thank you. Buffalo, what's up?
Chris, you're back with us fresh from the staging pits.
Yes, we've got Team 24 coming up from San Jose State University with their plane Rack Wagon. This is mission 2 for them with 3 ducks and 1 puck.
Okay, minimum requirements from San Jose, not necessarily a bad thing. Okay. Hey, look at this. What's up? Go ahead.
Just saying, San Jose State coming to play. They got a big box for them. I don't know more what's inside that box.
I don't know. They have batteries, maybe? Huh.
Lightweight design here, very smaller aircraft. Again, built for speed.
Yep.
Minimalist design. I think some of these guys have just opted for that small mission set with 3 ducks and 1 puck.
Yep.
And see how many turns they can do. Work for Ljubljana.
That's what I was just about to say.
Yeah.
It seems to be a pretty viable strategy going for those minimum requirements.
Most of the giant capacity systems that we saw. We haven't seen Buenos Aires again out here today, have we?
No, no. I want to see that. I want to see that Dorito fly again.
Flying Dorito, the giant triangle-shaped flying wing design. Very impressive yesterday. Well, a little bit tough in that air.
Yep.
On the turns. So.
Okay.
Okay, we're ready to go.
Once again, this is Team 24, San Jose State University with Rack Wagon, doing the mission 2, cargo mission.
Here we go, and they're off and up.
Oh, beautiful takeoff.
Yeah, that plane is quick.
Yeah. Coming around. Oh, that's nimble.
Yeah, wow. That rivals, dare I say, the Slovenians?
I would say, yeah.
I think that's about as quick as we've seen.
Yeah, that plane is booking. What winds? We don't care about those.
Taking that low-level pass.
Yep. Wondering if he's doing what Ljubljana was doing.
Exactly. I think there was a lot of learning going on there.
Yeah. .360-degree turn on the backstretch. Once again, San Jose opting for the minimum cargo requirement for mission 2, 3 ducks and 1 puck. Now, just because they're meeting minimum requirements here doesn't mean that they haven't spec'd the plane to exceed in other requirements for mission 3, cargo loading. We'll see.
That's a beautiful flight right now.
Oh yeah, that plane's...
And it's moving upwind faster than I think anybody we've seen fly it.
Yeah, it's just gliding through the air.
San Jose State is the oldest public university in the western United States.
Really?
Absolutely. They're known as the Spartans.
Yep, there you go.
Look at this. Wow.
Man, this is just a pleasure to watch.
Expert flying.
Right?
The pilot's really got it going on here. And I love the low-level approach.
Yeah,
really
yeah.
Avoiding the wind up high.
Yeah, he's trying to keep it low because we got good air down here.
I'd be curious how many they can get in here if they could get in 12 or 13.
Yeah, absolutely.
Give Ljubljana run for their money.
Yeah, yeah, that's good. It's good to see some competition, right? That's good stuff.
She's only about 20 feet off the deck coming across.
Low-level passes. I mean, that plane just looks beautiful going through the skies.
Super control.
Yeah.
And really turns like no other aircraft I think I've seen out here.
Just pretty. You know, San Jose University has opted for, I mean, that plane, you got tricycle landing gear, you got a low wing, no winglets, just T-tail in the back.
Flat out fast.
Very, very, very conventional design, and it definitely is paying off for him here.
Wow.
That's pretty. Look at that plane go.
Heck. That was about 6 feet high.
Yeah, he's going lower every time.
He's just getting in laps.
Yep.
Right. Yep.
Okay. Man, this thing's just cruising along.
Really flying fast.
Yeah. Now sometimes it's just a pleasure to just watch the planes. No news is good news.
It's very pretty in flight.
Yeah. Just let the flight speak for itself.
This part of the fly straight.
And now, once again, the goal with the cargo missions here is to do as many laps as you can in 5 minutes. And I'd have to say, San Jose State making it look pretty easy. They're doing a lot of laps.
Have you been counting?
What's that?
Have you been counting? I got lost in the flight.
I think I got past 7, and then I was just like, wait a minute, I'm not talking. we gotta commentate. That's the job.
Wow.
Nice.
That is impressive.
There we go. 5 minutes are up. Yep.
Chris Cullen on the line here.
Yeah.
It's time to bring her in.
Yeah.
Wow, that was impressive.
That was fun to watch.
Yeah. One of the cleanest I've seen.
Yeah, absolutely.
They know, like, so they're already.
Oh, look at that.
Yeah, that was impressive.
That was nice.
I really enjoyed that one.
That was nicely done. Rack wagon back down.
So wait till the plane comes back and the team are kind of switching.
That's a fancy taxi
Yeah,
drive.
look at that.
All right.
That's a nice looking plane.
Wow. Super maneuverable.
Yep. Yep.
Yeah, I think I'm going to take a break. And,
Okay. Clay, thanks for being down here on the flight line with us.
I'll come back a little bit later.
Absolutely.
All right. Thanks. Appreciate it. That was a treat. Right
That was fun.
All right.
Yeah. Okay, Chris. What do we got?
So next up on the flight line is Team 25 from Santa Clara University with the Wings of Theseus. They're on mission 3 with a 58-inch banner they're going to attempt to release. And they'd like me to give a shout out to Carl Almendinger.
All right. Once again, guys, that was Clay Morey. He's the CEO of the AIAA, and he just did probably about, 3 hours of commentary with me. That was great. It's just a pleasure. Okay. So this is team number 25, Santa Clara University. They are going with their Wings of Theseus plane for a banner deployment. This is mission 3 for them. Okay, Wings of Theseus is in the air. I do believe this name, Wings of Theseus, is calling back to the ship of Theseus, a mythology that basically calls into question, like if you have a ship and you replace every single part on that ship over the course of its lifetime, oh, banner deploy. Is it still the same ship? But I think Wings of Theseus is the same with that banner deployment. Little sketchy, but they do have a banner. Now, once again, for mission 3, their goal there is to fly. Their goal there is to fly as many laps as they can, dragging that banner behind Wings of Theseus. Okay. Once again, we have Santa Clara University with Wings of Theseus doing their banner flight, doing their Mission 3. It's a 58-inch banner. So not the biggest one we've seen, but they are towing it behind the plane. This is the 14th Mission 3 flight for the day. Now, once again, a little bit of a warning for the judge. They missed the first gate going into turn 1 and 2. They got to turn around. Santa Clara University got a lot of altitude there. Okay, 360-degree turn. The wind is staying pretty steady, but it's not a crosswind. It's going with the runway. We got winds coming out of the south now. They started west, and then they moved southwest, south-southwest. Now we just got winds coming out of the south. They're aligned with the runway. That should give you a pretty good headwind when you're coming down the main straight here. Now, once again, the objective here for Mission 3 is to drop the banner after 5 minutes. Great cheers from the crowd there as the Wings of Theseus deploys the banner, now coming in for a landing. Okay, bringing it around. We got a long, uh-oh. Got to turn. Oh no. I'm not sure if something's wrong there. Bringing it down over the runway. Come on. I don't know if they got into trouble there at the end, but they did bring her down in one piece. Crowd goes wild. Okay, taxiing back down the runway here.
Next on the flight line is Team 27 coming from the University of Arkansas with their plane Pee Wee Piglet. This is mission 2 for the team with 3 ducks and 1 puck.
Welcome back. All right, you guys can start heading over there.
Up next on the flight line is Team 29 coming from Washington University in St. Louis with their plane Side Duck, and this is their third attempt at Mission 1.
Guys, watch out for cords. You guys stay over.
next is Team 30 from the Aviation and Aerospace University, Bangladesh, flying their plane Phoenix. This is mission 3 for the team, attempting to launch a banner of 167.5 inch. The team also wanted me to give a shout out that their university is only 6 years old. This is their second appearance at DBF, and a shout out to Vice Chancellor Air Vice Marshal Mustavich, Faculty Advisor Dr. Saf, and Team Lead Abdullah Allah Aziz, Chief Design and Chief Designer Tashin. And I'm sorry that if I botched everybody's name up, but good luck, guys. from the Hong Kong University of Science and Technology with their plane Twin Fury, and this is mission 1 for the team.
Okay, Commentary is back on here. What's going on, everybody? This is the 2026 AIAA Design Build Fly DBF competition. I am EJ, the flight line commentator and host for this 3-day excursion here. I got Chris Horton next to me. Chris, how you doing?
Good. How are you doing this afternoon?
Good, good. Well, we just had one flight land. Who do we have up next?
Up next, we've got Cornell University. And they're flying Duck Force 1. And this is mission 2 for the team, and with 3 ducks and 1 puck.
Okay. Cornell, here we go. Flying mission 2. So, since I last left you guys, the winds have picked up a little bit. They've gotten worse relatively than what we've seen. We got winds coming out of the south-southwest here. Okay. Cornell's coming up here with Duck Force 1. They are waiting until we get the last team off of the runway. Once again, winds playing havoc with some of these planes today. We've seen a lot of premature landings here, not voluntary landings happen, and that's because if you look at how the runway is positioned, the wind's blowing kind of. It's more south-southwest, so it's blowing kind of like at a 45-degree angle across the runway. And that, when you're going through and turning with these planes, and you get that transition from tailwind to headwind, it really makes for an aerodynamically unstable condition. And you can see some of these planes kind of wiggling around when they fly. That's what's going on. I do believe Hong Kong University of Science and Technology got bit by it a second ago. Twin Fury had a little bit of a belly landing over there. And as they got the plane off the runway, Cornell with Duck Force 1 is ready to go for their cargo mission. So the cargo mission is mission 2 out of 4 missions that you can do here at Design, Build, and Fly, or DBF for short. Cargo mission entails moving passenger ducks and cargo hockey pucks. Rubber ducks and hockey pucks. The idea here is to get the plane up in the air and fly around our test course here as many times as possible with your cargo on board in 5 minutes. And just as I said, Cornell, with Duck Force 1, flying their cargo mission, cleared the gate, turn 1 into turn 2. On the back stretch, 360-degree right turn here. This is finishing out the backstretch. We have a 180-degree turn to the left. That's turn 3 and 4. And now back over the runway for our main straight. And once again, this is a cargo flight. So what Cornell's aiming to do is as many laps as possible within a 5-minute timer. Once again, these winds have picked up a little bit. We got winds coming out of south-southwest. I'd say, let me pick up some grass and throw it. Probably at least 10 knots maybe. The windsock has a full rung. Now, if you don't know windsocks, they're the weather implementation that you see on airfields that tell you which way the wind is coming from. And they do tend to hang down, right? If more of the windsock is blowing into the wind and not hanging down, that indicates more wind. Specifically, that indicates wind speed, too. We are at 1 full notch on the windsock on winds coming from south-southwest, which means some pretty serious winds here. I'd say 5 to 10 knots, definitely, because we got 1 rung filled on the sock. Oh, geez. There's a bird flying around up there next to Cornell's bird. Or duck, should I say. Duck Force 1. Duck Force 1 looks to be really maneuverable, though. It doesn't seem to be caring about the passenger cargo that they have on board. Okay, once again, the object here that Cornell's trying to do is get as many laps in around our test track as they possibly can with cargo on board. The idea here at DBF is annually they change the challenge. So for 2026, what you're really doing here is you're trying to make a bush plane. So a plane that's designed to, like a small general aviation plane that's designed to go move some cargo around, move some people around, and tow a banner around. The kind of thing you'd be seeing from more general aviation stuff. So smaller Cessnas, smaller Beechcrafts, like the planes that you see here. Facilities that we're at here are in Wichita, Kansas. We're at Textron's facilities here. Textron, home of Beechcraft and Cessna, a general aviation giant in the airplane industry. And they've let the AIAA host the design, build, and fly here. But these planes are designed at basically operating general aviation plane. And how these missions work is you get paid. More cargo you move, you get paid. The faster you move it, you also get paid. How quickly you can load and unload it, you get paid. How fast you can tow a banner around, you get paid. The currency here for the design, build, and fly competition is duck coin. Duck coin. Yes, it's called that. It's a made-up currency. Don't go looking for it. Don't do that. So, the team with the most duck coin at the end is the one that's going to be crowned a victor here. Oh no! I'm not sure if that was showing off for the pilot there or if that was intentional, or if the wind took it. Once again, wind is picking up. We started the day with a relatively calm crosswind. Now we have a wind that's more or less moving in line with the runway, but it's still moving slightly diagonal as opposed to the long axis of the runway. It makes landing these planes a little bit difficult. There we go, come on. Hey, not for Cornell though, with Duck Force 1. Here we go, complete in mission 2. Great flight. All right. So, Chris, you're back with me.
I am back, and up next on the flight line is going to be Team 34 from the University of Akron, flying their plane, the Rue Express. Team 34 is on mission 3, and they're going to attempt to launch a banner of 236.75 inches.
Okay, University of Akron with Rue Express. Actually performing really good in mission 1 and mission 2. Good flight, guys. Good flight, that was great.
Thank you. Almost lost it.
No, you recovered and came down in one piece. That's what matters. All right, that team outgoing here was Cornell with Duck Force 1, flying a great mission.
Good job.
Good job, dude. Okay, U Akron on mission 3. Okay, University of Akron with the Rue Express in the air. All right, they got to do one turn, then the 360-degree turn, right-hand turn on the track here. Wind's really picking up. Here we go. Go for banner deploy. Oh, there we go. Perfect. Okay, now that they have the banner deployed, the real testament here is seeing how many laps around the course you can do with that wind. You can really see the plane fighting against it. Rue Express is really powering through. That banner, it's a big banner, 236.73 inches. That is the biggest banner that I've seen here. Banner flying, showing U Akron's logo there. Very nice, very nice. But you can see powering upwind. Oh man, the ground speed's really, really slow. Now, plane's gonna really struggle here through this turn. Not because of the design. U Akron's design is great, but that headwind is gonna turn into a tailwind and really start accelerating the plane relative to the ground. 360-degree right-hand turn. Oh man, turning back into that headwind's really gonna slow them down. Gotta be careful. Okay, and then coming out of that turn back into a tailwind. Ground speed starting to speed up again. Now they gotta turn into the headwind here. This is another really difficult part because the wind's starting to push against the plane as it turns towards us. Oh, you can see the pilot inducing some roll onto the aircraft there to try and get this thing to power through. See, the wind is pushing the plane back when you have a headwind. Your speed relative to the ground goes down, but the air moving over the wings goes up. So you generate lots of lift in a headwind, but you're just not going too fast relative to the ground. And that banner that the University of Akron has behind them is absolutely acting like a gigantic brake that's slowing them down even more. It makes for a really low relative ground speed. I'd say relative to the ground, it's probably going 5 to 10 knots at best right now. But the air moving over the wings is going way faster because of the wind. Now, conversely, when they turn through for a tailwind here, or they got a tailwind here, that's pushing the plane as fast as possible, but you don't generate as much lift. It makes for high ground speed, but very unstable aerodynamic conditions here. But the Rue Express in U Akron seems to be powering through, doing real good. Once again, the objective here is to deploy that banner, which they have, and really see how many laps they can do around the track in 5 minutes. Judges have a timer here. The more laps you can do, the better. Beautiful, beautiful airplane. Completing lap 3, on to 4. Call out from U Akron's observer. Teams are only allowed 3 teammates to be on the runway at a time. You have your pilot, you have your ground crew, and you have your observer. Some of the teams have opted to have the observer call out distances for the pilot so the pilot can focus on flying the plane. Oh man, look at it coming through with that tailwind. That thing's really moving. Oh, we gotta be careful. This 360-degree turn with that wind is really gnarly. Okay, Rue Express at U Akron powering through it though. No big deal, no big deal. Okay. Coming through to the start-finish line. Completing lap 4. We got 4 laps with the banner for U Akron. Very good.
We're on to 5, 420.
They dropped the banner. Banner's down. Now it's just to get the Rue Express back down on the ground. That was one of the bigger banners that we've seen here. Circling the Rue Express around. Feathering the throttle. Oh, the wind. Come on. You can do it. Little 1 bounce, 2 bounce, 3 gear down. Great flight, great flight. University of Akron showing how it's done. Okay, Chris, you're back with us from the staging pits. Who do we got next?
Up next is Team 36 coming from the University of Maryland College Park with their plane Duck Force 1. This is mission 3 for the team, and they'll be trying to launch a banner of 169 inches.
169, there we go. Thank you very much, Chris. Okay. Okay, I got a special guest here joining me on commentary. We had Clay Morey in with us before, but now we have the pilot that flew the opening ceremony presentation. This is Mujahid Abdul Rahim.
Yes, sir.
How are you, man?
I'm doing well. This is my favorite place.
This is fun. This is my first time being here. I love this.
Welcome. It's so nice to be able to operate DBF out of an airfield. Is one of the great unique experiences.
It's fantastic, right? It's fantastic. You actually, now you flew the opening ceremony, right?
Yes.
What kind of plane was that, just for the viewers at home?
It's a Thorpe S-18 experimental.
Experimental.
Yeah.
Thorpe is an older plane, if I'm
Thorpe is an older airplane. John Thorpe, the designer of my home-built airplane, he'd been working for Piper, designing the Cherokee, essentially, and so he decided he wanted to build the everyman airplane, right? Out of 12 sheets or something of aluminum, build a side-by-side all-aluminum aircraft that was aerobatic.
It is 2 seats next to each other.
It's 2 seats side by side. I will say, most of the time, the right seat is occupied by my food. I love, as soon as you're up in the air, just consume whatever food.
Okay. All right. What do you bring with you? What kind of food?
Usually snacks that don't make my hands dirty, right? So fruit snacks are good. Chips make an absolute mess, right?
Yeah, yeah. It's like astronauts. The astronauts up there.
Yes, absolutely.
Food that makes a lot of crumbs, right?
Don't open the bag of chips in zero gravity, right?
Yep, yeah, that's right. Now, notice you got an Artemis shirt on.
Oh, this whole thing? Yes. Yes.
You watch the Artemis 2 mission?
Absolutely. I watched it from Banana Creek. We were very fortunate to be able to get passes the closest possible to the launch, I think Pad 39B. It was a heavenly experience.
It was awesome. All right. This is University of Maryland College Park. Duck Force 1. Deploying their banner, and their banner unfurls. That's what I'm talking about. A little bit of squirrely on the deployment.
A little squirrely on the deployment. There's he pushed over for negative G for some reason.
Yep.
It's remarkable the different choices that people make, the teams make on the size of the banner.
That's one of my favorite things. I love how the AIAA leaves it open. They leave it open, so you don't really have convergent design. It's not like. I was about to throw Formula One under the bus, but let's just say we have divergent design, and we'll leave it at that.
But here, look, let's talk about Formula One. You can argue it is like Formula One because there is a specific formula that you have to follow. We just happen to have a lot more freedom in some of the regulations. Like stock car, you can say even stock car is not stock anymore, right?
No comment.
Yeah, right. Fair. I'm sorry if that's a sensitive subject.
No, it's all good.
But you know, the lovely thing is, for me as a professor of aerospace engineering, aircraft design in particular, the thing that always fascinates me is people read the requirements, right? The rule requirements, the formula, and somehow come up with wildly different results.
I love it.
And we have, I've heard your commentary, tandem wing airplanes and biplanes, and then V-tails and T-tails and H-tails, and
I saw staggered main wings from the University of Maine. They have one main wing in the front, one main wing in the back. And that got me into this whole conversation about, like, as long as your center of lift is lined up with your center of mass, physics doesn't care what the wing looks like.
Yeah.
I mean, I was thinking about NASA's AD-1, that oblique wing, which is just crooked, and the thing flies fine.
So it's worth mentioning some of the rules for tandem wing airplanes. If they have a tandem, one in the front, one in the back. There's 2 basic rules you have to follow, and risk divergent flight if not. One of those rules is the front wing has to stall first. If the rear wing stalls first, it goes into a deep stall. That's no bueno.
And
the other one is the rear wing has to go to zero lift first, because then it goes back to higher angle of attack. If the front wing goes to zero lift first, it tucks under. So God bless the people that chose to do tandem wing designs. They are harder to design in a sense.
Have to mess with the angle of incidence on the rear
angle
wing.
of incidence, the airfoil, the stall, everything becomes important there.
That's cool. That's cool. University of Maine, actually, they were rebuilding their plane till 3 a.m. last night, and they had all the teams that helped them written on the side of their plane when they completed their flight today.
That's lovely. And if you walk by the hotel where the teams are staying, what you'll see is every room has been turned into an aircraft rebuilding and design center. I don't think Marriott knows that, but that's okay.
No, that's fantastic. So this is the University of Maryland with College Park deploying their banner. They just got to bring it on home here. Okay, dealing with that wind. Actually, does their plane have flaps? Am I looking at that?
It does, yeah.
Right? Hey, that's pretty trick.
That's not bad.
Oh, that was nice. Very nicely done.
You know, there's the rule that no matter how good the flight goes, everyone's judged by the landing.
Oh,
and
yeah,
so
of
we've
course.
had that too. And one of the rules of the competition is no matter how many laps you do, you have to have a safe landing that doesn't destroy the aircraft. And it's painful sometimes to see a team that seems like it completed everything, breaks off portions of the aircraft, and they basically scrub. They have a no-go.
I've seen a couple of teams, well, let's say, get robbed by the wind today. It's not great. It's not great. Now, you are actually an advisor for one of the teams, right?
I am, yeah. I'm a professor at the University of Missouri, Kansas City, and we started a design, build, fly chapter there. So I teach aircraft design, and what I've done recently, in recent years, is I've coupled the requirements of my course to the DBF requirements. So every single year, my course changes. The project that I give the students changes.
Smart.
And that means I can better able to support the students in their design mission.
Yeah, absolutely. I saw you guys plane fly a little bit earlier. Very, very stable design.
It's not a bad design. They put a lot of work into it. As always, they should have done things earlier. They should have tested more frequently, right? So, yeah, exactly.
All right. Chris, back from the pits, who do we got next?
We've got Team 37 coming from the Institute Tecnológico de Buenos Aires with their plane Condor. We've seen this plane out here a couple times.
Yep.
And they're flying Mission 3 and attempting to launch a banner of 117.75 inches.
Okay. This plane becoming very famous for 2026 Design, Build, and Fly. All right.
Here's another example that someone decided to do a delta wing flying wing.
It's a delta blended wing, right? Because it blends the fuselage.
Right, exactly.
That's cool. And then you got twin stabilizers at the end.
The only design aspect I don't understand is how much camber they have on the main wheels.
Yeah.
I think it's just a stance thing like the car guys do.
Bringing the Stance Nation.
That's right, the Stance Nation, exactly.
To the runway, let's go.
Exactly.
Now, okay, so see, I can pick your brain about this.
Yes, sir.
That blended wing is going to be very stable at lower speeds, right? Very stable. You don't want to go too fast with that kind of design, right?
It's okay. Actually, surprisingly, one of the things about the blended wing, and more so the delta wing, is it's good at a variety of speeds. It's good for very high speed flight. It tends to be, especially when you put the center of gravity fairly far forward. And the nice thing about it at low speeds is that is very resilient to stall. Because you have this high degree of sweep, it basically has a lot of spillover. And some of these things can go up to 40 degrees angle of attack without a substantial stall. It increases the drag, certainly, but the stalled brake doesn't happen like it would on a rectangular wing.
So Concorde.
Concorde, exactly.
Concorde does that.
And think of a lot of the fighter jets, right? They can go to very high angles of attack without issue. So this is a lovely design, and not even to mention it's a nice trim scheme.
Yeah, I like it. Okay, once again, they're looking to deploy a 189-inch banner.
There it is.
Hey.
I'm astounded to see the difference between some of the aircraft, where some look like they labor against the drag of the banner, and others don't seem to be affected very much.
Yeah, I even saw, I forget who it was. I think it was University of Maryland. I think they had cutouts in their banner.
I didn't understand that. I wasn't sure if that would be more or less drag.
You know, I want to say it looked like it was fluttering less, but I don't know. I don't know. Hard to say.
You see that on banners that are draped across the highway, so they don't catch the wind as much. But as far as drag, pulling it along the axis of tension, I don't know.
Once again, the flag of the Instituto Tecnológico de Buenos Aires. Forgive me, Spanish is not my first language.
It's your second?
Yeah.
Fair enough.
No, my second is bad English.
Bad English, that's right.
Okay.
So I have a quiz I give to my students, which is, when you're towing a glider, you have a tow plane, a rope, and a glider at the back. And I ask them how much tension is on the line. Is it wrong to ask you to do public math? Do you want me to do it?
Do it.
All right. Imagine there's a glider that weighs 1,000 pounds.
Okay.
And it's being towed by a tow plane, and there's a rope that connects them.
Okay.
How much tension is on the line, do you think?
Well, that would really depend on how much drag it's going to make, right?
That's exactly right. Most people think if it's a 1,000-pound glider, it should be 1,000 pounds tension. That's not right at all.
No.
Because lift to drag ratio is 20 to 1.
Yeah.
So it's something like 50 pounds of tension on the line in level flight.
Yeah.
And so that's the same thing here. It's whatever the drag is of this whole assembly, right? The banner. That's the additional drag that the aircraft has to overcome.
Yep.
But it doesn't need extra angle of attack because it's already flying at whatever speed.
Yeah.
Only if it's flying slower does it need to pitch higher.
Yeah. Yeah. That's great. You see, that's the kind of things that I do over on my end on the Twitch stream. Shout out to the Twitch viewers, thank you very much, and the AIAA viewers on the YouTube channel. Thank you very much for watching, guys. That's what I do. We mess with Kerbal Space Program. Build all kinds of contraptions, crazy contraptions in that.
Yeah, so Randall Munro, the XKCD guy, says nothing has taught him more about astrophysics than Kerbal Space Program.
Yep, Randall Munro. Been playing that game for a long time.
Yep.
Okay.
That crosswind.
Yeah, that crosswind's really been a nail biter for some of these teams coming in.
So speaking of, I'm astounded sometimes that teams show up without steerable gear at all.
Yeah, and just let it roll out.
Sometimes it works and sometimes it doesn't.
Right.
A crosswind, that's why we need steerable landing gear.
Yeah,
right?
absolutely. You gotta, what is it called? Crabbing, right?
Well, if you think of it this way, on the runway, if there's a crosswind, it's going to primarily affect the vertical stabilizer. It's going to want to point into the wind.
Yep.
So what we do is not even crabbing, but just rudder opposite to the wind to keep the nose straight.
Yep.
But if you don't have a rudder or steerable nose gear, then you're just left to the whims of whatever the vertical stabilizer does.
Yep. I've seen some teams have an early landing, we'll say.
Yes. And so I was photographing on the other side of the runway. Several of them tried to come and eat me alive.
Yep. I saw that.
Yeah, right.
Yep. Once again, this is the Instituto Tecnológico de Buenos Aires got it that time. Yes.
Good
Team
man.
number 37 with their Condor. Blended delta wing, dropping the flag, the ITBA flag, circling around and coming in for a landing. That is a cool looking plane.
It's a very nice airplane.
I'm just saying, that thing's great. Circle around, heading alignment. Oh. Yeah.
Very nice.
Very good.
Very nice.
Dealing with the crosswind, no problem. Roll out on the runway. ITBA, nailing it. Okay. The next team is the Massachusetts Institute of Technology. Local place to me. And they're going for mission 3 with a 235.5-inch banner. My boys over here, wicked smart. Wicked smart, dude. Okay. Tell you what, Mujahid, you can stay here as long as you want with me commentating about planes.
I'm happy about that, right? If you want me here, just give me a triple blink and I'll leave if you want me to.
Nope, I'm gonna keep my eyes open now. I'm in a staring contest. No, this is great because I mean, like I said, I'm not an aerospace engineer. I'm not a professor. I know enough to be dangerous, but not. Sorry. Argentinian's going crazy over there. I love it. Okay.
Yeah, most of them are like directly to your left on the bowling points.
So did anyone tell you how the flyby came about?
No.
We were so AIAA hosts one of their flagship conferences or forums is SciTech, and we'd been planning for a lot of DBF at SciTech, and someone made the suggestion. I wonder if we should open it up with a flyby. I'm like, of course we should. Why not? Right? You do things like flybys for football games or whatever.
Yeah.
So since SciTech last year, I put a smoke system in my airplane, tested it, made sure it works, and then it was just all sorts of fun. We were actually trying to do formation, but they said, nah, just keep it one airplane. So we did a single airplane.
Banner got deployed.
Oh no. MIT's having some problems with their banner. They'll be back though. Good try, guys. Get back on the horse. You got it. All right. Unfortunately, MIT going back to the staging pits. All right. So next up we have Team number 40, University of Illinois Urbana-Champaign with Quill, and they're flying Mission 3 with a 120-inch banner here.
So 120 inches, is that square inches or linear inches?
It's linear, it's the length of the banner.
Wow.
Yeah. Some of these teams, I tell you, some of these teams had, I think I saw 258 from Universidad de Antioquia, 258 inches.
That is incredible.
That's a long banner, and they nailed it too. It was really good.
We saw one that was something like 25 feet by 5 feet. I don't know, I haven't seen that one fly yet.
Yeah, I'm wondering where that one is. Okay, so
I have to shout out to some of the faculty here. A lot of Michael Selig and the folks at UIUC, they've done such a good job with developing, airfoil formulas and airfoil test databases for us, and I frequently use their website in my teaching.
It's a database of airfoils?
And what's the airfoil on a 747? Look it up, they have a site. What about the airfoil on a Cessna 172? So the database of airfoils and the usage of those airfoils.
Don't tell me that. I'm going to be buried in that for like the next 3 weeks.
Well, what does the P-51 use? Yeah, exactly. No, it's fantastic.
Oh, that's not good. Why did you tell me this?
I'm sorry, sir. There go your evenings.
People get into a good book. They read the whole book in like a day. I go read stuff like that. I read NTRS reports.
Yeah, exactly. But they've done a really good job blending between sort of the modeler community, the glider community, and the aerospace engineering community to give everyone needs airfoil data and understanding of which one should I use.
And a lot of that airfoil data goes back to the NACA, the National Advisory Committee on Aeronautics.
Absolutely. And
okay. University of Illinois Urbana-Champaign with Quill in the air doing their Mission 3. So once again, the objectives here for Mission 3 are to deploy your banner. They have a banner that's dragging behind the airplane or next to the airplane. It's up to the teams to decide. And then see how many laps you can do in 5 minutes. Now that, with this wind, that proves to be a little bit challenging getting all these laps done. Even the deployments are getting a little squirrely there. But here we go. Should be good for a deploy. There we go.
Oh
no.
Looks like it's separated from the airplane.
Yeah. We were talking about tension on the lines there.
Yeah, a little bit too much. The shock loads, so with that 50-pound figure that I gave you was steady, but the shock loads are bad news, and that looked like it might have either pulled apart from shock loads or they accidentally pulled the servo too far and released the whole mechanism.
Yeah.
And because they have that, they have to both unfurl on one setting and then deploy on the other. A lot of times, if you're not careful with how you deploy the servo, if the pilot accidentally pushes the switch too far, it'll just dump the whole thing.
Now, is that a design choice, or does every team have to have a deployment mechanism like that?
Every team has to have a deployment mechanism. That you can design it however you want, but there's one switch that allows it essentially to deploy, and the other switch that allows it to release. And they have to figure out, is that multiple servos, a single servo? How do you do that?
There's trade-offs.
It's trade-offs. And if you use a single servo, you just have to make sure don't pull it too far.
Yeah. Okay. We got Chris Horton back with us. Chris, what's going on?
Up next on the flight line is Team 41 from The Ohio State University, flying their plane Catfish 2. This is Mission 2 for the team with 3 ducks and 1 puck.
Okay, Mission 2 for The Ohio State. Now, I can't help but notice that the plane's named Catfish 2, right? And that's because we heard a little bit earlier that they rebuilt this plane. They built it out of, I think it's...
Is that foam board?
Foam board.
Really?
Yeah. They built it out of foam board, and that's why it's 2.
What happened to Catfish 1?
I don't want to know. I wasn't here for that. So they opted for a twin-engine design, tricycle gear, lower wing, but your vertical stabilizers and horizontal are on the top back of the fuselage. Why would you put them up high like that?
What is that?
The horizontal stabilizers, the vertical stabilizers, they're above the fuselage and the main wing's below. Why would we do something
Well, there's
like
a couple of reasons. One is it's a nice platform. You see how it's a low wing, a low wing design, and then because you have a nice flat spot on the top of the fuselage, it's a nice solid area in which to adhere the horizontal stabilizer. The other thing that can help a lot is if it's a T-tail configuration, to make it clear of the wake of the wing.
Yeah.
Daniel Raymer wrote a book, the AIAA design book, and he has a whole section on where would you put the horizontal stabilizer. I would say, not that I want to throw shade at anyone's airplane, that sort of makes me a little bit nervous. The idea is, as you increase an angle of attack, you don't want the wake from the separation of the wing impinging on that horizontal stabilizer. So he describes generally a little bit of, if you're going to put it above, put it well above.
Yeah.
A little bit above is not great. Below is the best, because as you go to high angles of attack, the wake of the wing just flies right over the horizontal tail. The exception, of course, is if you want to use the vorticities or the wake that comes off of the wing to impinge on the tail to give you a little bit of warning for stall. That's what a lot of people, that's how they design aircraft, to have that little buffer. That's intentional, to give the pilot some feel that, hey, as this thing shakes from the wake of the wing impinging on the tail, it's time to push the nose down.
I do believe the MD-11 did that.
Right.
In their flight test, they did that exact thing. They induced flutter on the rear wings to indicate a stall condition.
Right.
Smart.
Of course, right now, most of the modern aircraft use stick pushers or stick shakers. Saying, hey, your high angle of attack, if it's detected through the instrumentation, it shakes the stick or even pushes the stick.
Yeah, that's cool.
But it's cooler to do it by design.
I like designing that way.
Yeah.
You know.
Another one of the challenges is not just the fact that the wake from the wing is turbulent, it's also slowing down. As the air goes over the wing, drag slows it down. By the time it gets to the tail, it's actually slower. So the tail is operating in lower dynamic pressure, lower airspeed, and it becomes less effective. In the worst case, it's far too ineffective, and you don't have the authority to push the nose over.
Oh, that's bad. You don't want that.
And you don't find that out until high angles of attack. That's not good.
That is a compounding pitch moment, right?
A compounding pitch moment, depending on the pitching moment of the wing, it could pitch up or it could pitch down, depending on what's going on. The point is, you no longer have authority. You expect that you move the elevator, you want to get pitch up or pitch down. If you have slow wake moving over the tail, then you just don't get much authority at all.
Yeah, exactly.
Wing is in nice clean air. The tail is in garbage air. That's slow and turbulent. It's very ineffective.
Yep. Okay. Plane is armed.
Go Catfish.
Catfish 2, yep, here we go. The Ohio State Buckeyes, my cameraman loved it. 2 engines giving a good thrust of weight there.
He didn't even use all the runway.
No, oh geez. Come on, Catfish.
So this oscillation roll looks like possibly overgained. The controls are a little bit too sensitive. It's also a short wing aircraft. And so the moment of inertia isn't that large, the roll damping isn't that large, and you can see between the effectiveness of the aileron and the poor roll damping, how it's having a little bit of an issue.
Yeah. So the deflection of the aileron, how much it's moving, is going to create a lot of roll, right?
So it's a balance between how much the ailerons deflect, that gives you what starts the roll, and how big is the wing, that's what provides roll damping. So that's what eventually slows it down. But if you have a lot of deflection on a short wing, it's going to roll very aggressively.
I've noticed that the teams take off, and it's a little shaky on the first lap, but once you get to the second and third lap, they got it figured out. You got the feel for it,
and you talk about feel. Pilots adjust their gains. So initially, I've had airplanes where I fly for the first time, and like motorcycle tank slappers, I'm over controlling left and right, and you have to force yourself to be a little calmer, remove the gain or reduce the gain, and then it settles out. But that's the unique adaptive nature of human control, right?
We interface to the machine. Very cool stuff.
It looked like something fell off the airplane.
I think I saw something come off, yeah. That wind is getting nasty.
Yeah. That's a pretty effective way to lose altitude.
Yeah. But Catfish 2 powering against the headwind here. That 360 degree, you go from a headwind to a tailwind real quick. It makes for, would that be aerodynamically unstable conditions there? Or?
So I've had a lot of arguments about this.
Yeah.
If you are, for instance, going downwind and then just do a regular turn, the aircraft doesn't really care because the airspeed could remain relatively constant.
Mm-hmm.
It would look from our ground perspective as though it's slowing down and speeding up, but that's just the ground speed.
Yep.
The airspeed is largely invariant. It's only if you're making a very aggressive turn in a gradient that matters.
Okay.
But I will say there's been a variety of discussions over where on the downwind should you place that 360 degree turn.
Yeah.
Because you have the centripetal acceleration, right? You're limited by load factor. And then the radius of the turn depends on the square of the velocity.
Yep.
Which means, should you turn while going slow at the very beginning of the downwind or turn while going fast at the end?
Mm-hmm.
And I think the right choice is doing it as soon as you do that first turn going downwind, do the 360 right there.
Yeah, I see a lot of teams doing it right out of the turn.
And you talk about the airspeed variations. If you're going fast, bank, and then pull hard, the increased load factor is going to cause increased drag. The aircraft will slow and it will make essentially an increasing or decreasing radius turn.
Yep.
You can see it starts off, especially from that vantage point, it starts off here and ends up over here. It's like a little curly Q almost.
The Fibonacci sequence.
That's right,
there.
exactly.
There we go.
I wonder what they lost.
Yeah, we got to see. We got to wait and see till the plane comes back down. But now that windsock's almost completely horizontal over there. That's making challenging conditions. Here we go. Oh, come on, baby. Come on. You got this. Look at that. The wind's blowing that thing. It's not moving fast relative to the ground.
Nope. Just put it down.
Yep.
There you go. Very nice.
All right.
Very nice.
The Ohio State with Catfish 2 completing mission 2.
He stopped his run for the cheer.
Hey, you got to show team spirit.
Absolutely.
It's important.
Absolutely.
Okay, Chris is back, fresh off the staging pits. Who's next?
Up now is Team 42 coming from the University of Oklahoma with their plane Foul Play. Mm-hmm. And this is mission 2 for the team. They're carrying 12 ducks and 4 pucks.
Cool.
Along this
mission
line,
2.
This one here, facing that way.
You know, if these guys are Team 42, they could have called it Flight, the Universe, and everything, but that's okay.
Don't forget to bring a towel.
That's right. I saw a couple of pilots panic, and don't do it. Don't panic.
Nope, don't panic. Don't need to do that. They got the shark tooth on it. I like it.
Excellent. That adds several horsepower.
I agree. Now they got a much bigger vertical stabilizer there, and it's kind of back up and very, very tall compared to the rest of the plane.
Right.
Is that because the fuselage is shorter? What do you think?
I think there's 2 reasons for it.
Yep.
One reason is it is a short coupled. If you look at the distance between the wing and the horizontal tail, the vertical tail, they have to compensate for that short distance with increased area, which is tail volume, which is a silly thing, but it's area of the tail times the distance. If you have an area times a linear distance, it's a volume.
Yep.
So the units are, meters cubed or something, or inches cubed. The other aspect, it's a multi-engine aircraft.
Yep.
And so from my experience teaching people to fly multi-engine aircraft, a lot of times if one engine quits, you have a yawing moment, and you need all that vertical stabilizer and rudder area to provide that countering yaw moment.
Yep.
I don't think we have a lot of instances of engine outs in electric, twin airplanes, but still.
But yeah, if one engine goes, your center of thrust is going to go way over to one side around the center of gravity.
Please, head over.
The Ohio State clearing the runway here for the University of Oklahoma. Foul play. 12 ducks, 4 pucks. Now, I've been telling viewers pretty much throughout the weekend, adding the cargo really starts messing stuff, not messing stuff up, but it really changes the flight characteristics of the plane, right? Especially with hockey pucks. Those things are pretty dense.
They're pretty dense. You said 12 pucks? Or 12 ducks?
12 ducks, 4 pucks on foul play here.
So if you think of Mission 1 is the unladen configuration.
Yep.
The aircraft just has to fly, just has to complete the circuit. By the time you load up the pucks, load up the ducks are not a big weight hit, but now you have increased stall speed, different moments of inertia, the longer takeoff distances and so on.
Yep.
And then load factor, certainly. If you put too much in there, that wing root bending moment is going to have to strain against all that weight in the fuselage.
Stronger wing box. There you go. And it can also play havoc with the center of gravity if you don't balance it right?
You know, that's right. So the center of gravity changes, and one of the things DBF requires is that the student teams mark where the center of gravity is for each mission. So you have to at least have considered that. But then how good is their bracing? Is it possible that it shifts? And there's been several accidents of cargo shifting, especially aft, and then causing the airplane to be unstable. Yeah, that 747 out of Afghanistan, I think, was a terrible incident.
Bagram. That was not a good day. Oh, that wind's getting nasty.
Yep. You know, there's been murmurs of, is this fair that you don't get to pick your flying conditions? Like, yeah, that's kind of how things go. Some people get calm winds, some people get aggressive winds.
That's
and you just have to fly.
I mean, Boeing or Lockheed wouldn't engineer a plane for calm winds all the time, right?
Yes.
You got to take that into account.
Yeah.
But that's one of the, I would say that would be an unknown here in this regard,
Exactly.
right? You don't know what you're going to get.
Yeah.
So you got to design around that.
Absolutely.
Definitely a challenge. Twin engine really able to power into the headwind there.
Yep. The nice thing about twin engine designs for this mission is because it leaves the fuselage largely empty of any of the electronics or motors or no firewalls, you're able to have a lot of flexibility where you put the cargo.
Yep. Same is the case for the real planes. There you go.
Right.
Actually, it's not happening on this flight, but I did see some of the teams have flutter on their vertical stabilizer a second ago.
There was, as a photographer, I don't wish badly on anyone, but certainly we're going to capture it, right? And same thing with your videographer, he's making sure he's capturing everything.
Yep.
Flutter is an insidious thing. Flutter is where, that coupling between the aerodynamics and the structural modes, and every airplane will eventually flutter. Hopefully the flutter point is far enough into the airspeed range that you can't actually get it with your motors.
Yep.
But some of the teams are making choices on, well, how heavy do they build the tail? How robust are some of the structures? And you can see they kind of chose wrong. I will note that when we saw that flutter earlier, the pilot did the right thing, throttled back, reduced the airspeed, and then we didn't see it for the rest of the flight.
Absolutely. Yeah, he did a good job correcting. Yeah, I likened flutter when I saw it to the time. Like if you open up a soda can, you have the tab, and you start moving the tab back and forth and back and forth. It'll eventually snap right off.
Yeah, past DBFs, we've seen divergent flutters, right? If you're plus or minus 10 degrees on a control surface, well, then good luck trying to control it.
Yep. So once again, this is the University of Oklahoma flying their Mission 2. This is their cargo mission. The objective here is to fly a fully loaded plane with ducks and hockey pucks, rubber ducks and hockey pucks. They have 12 pucks, or 12 ducks, 4 pucks. And the goal is to see how many laps you can do around the track in 5 minutes. Pretty uneventful flight for them.
That's the best you can hope for.
No news is good news.
Absolutely.
There you go.
He's handling the winds very nicely and just being nice and conservative about flying.
Yep.
It's a challenge here. We're in the afternoon of day 3, though, and some folks are just flying Mission 2. And it's a consequence of the weather and preparedness.
I mean, some of the teams came out here on flight day 1 when we had a 20-knot wind coming out of the south, and they paid for it, and I kind of feel bad.
Yeah. In actual flight test or any flight operations, you have a go, no go. Should you go or not?
Yep.
In this case, you can choose to forego a flight opportunity, but that basically means you won't be in competition.
Yeah. Some people would, like I said, get the short straw. There we go. That was the University of Oklahoma cheering from the stands with their plane foul play, completing Mission 2. Chris, back from the stage pits. What do you got?
Up now is Team 43 from the University of Colorado Springs, flying their plane, the Duckinator. They're on mission number 3 and attempting to release a banner of 93.75 inches. And the team asked me to give a shout out to their faculty advisor, Dr. Wilcox. He's here somewhere in the viewing area.
There you go.
Good luck, guys.
Okay, UCCS here, flying mission 3.
Maybe my favorite looking airplane.
This is the one I like. This is the one I like the most. It's got windows.
Looks a little bit like a maybe Cessna Caravan, low-wing Cessna Caravan, or Pilatus PC-12 or something.
Right.
It's just lovely. And the fact that each duck gets its own window is my favorite.
Yeah, every duck's got a window seat. I love the window seat. That's my favorite. I'm sure you do too, right?
Can I talk about window seats for a second?
Go ahead.
I'm the type of person that's glued to the window seat. It's like there's a whole world out there.
Yep.
The most disorienting feeling is when you're sitting in the middle row and everyone closes the window shades. Am I flying? Am I on the ground? I don't even know.
That happened on my flight here.
Oh, I'm sorry to hear that.
You know what I do? All right, this is a really, really nerd admission here.
Here we go.
I get my level out from my phone and use that as the artificial horizon.
Excellent, excellent.
Yep.
So I'm constantly looking at my EFB, electronic flight bag. I use a VAIR, 4Flight, or whatever you use.
Yep.
And then you can guess what instrument approach they're flying and look at all the pilots in like, what's the nearest airport to me? Look, there's Cincinnati down there.
Oh, I've done that.
Yeah.
Yep. Okay. Yep. We do that. We do that all the time.
And it's like the type of pilot that's sitting in 28F but tells the actual pilot, hey, if you need me, I'm 28F if you need anything, sir.
There you go. All right, here we go. UCCS looking for their banner deploy here. Okay.
They did the 360 without a banner.
Yeah. Come on. Come on. We can hear that banner flapping, but it's not deployed.
And it makes me wonder if the linkage is jammed, because the way it's oriented sort of laterally.
Yeah.
Maybe there's a lot of load on the release mechanism, and the servo's not able to pull out the pin or something.
Yeah. Even if they slow down, you still got that headwind that's keeping that thing closed.
Okay. It should be sensitive to airspeed alone, but then do you slow down to reduce the airspeed, reduce the dynamic pressure on it, but then risk loss of control?
Yeah, there you go.
I think they might be bringing it in.
Yeah.
Is this the team that believes birds aren't real?
Yes, it is painted right on the tail.
Yeah, I see that.
That's the livery that they're indicating on the tail.
I'm a lie, I like those shirts.
Yep, yep. Come on. Bring it down. There we go.
Well, it's brought home safely.
Yep. Yep. Now, I haven't gotten a clarification on this. If they fix this, will they get another shot?
They get a shot depending on timing.
Yeah, okay.
So they will have to wait for 92 teams to have a flight attempt before their next one. In past competitions where the weather is good, and there are not a lot of crashes, you can cycle through the entire flight list 4 or 5 times, right? So people will get at least mission 1, 2, 3 attempts, and afterwards they can re-attempt any mission. Or for folks that are late, for instance, to finish tech or have a crash and have since repaired, they get another attempt. But this time, I don't think we're going to have every team getting a mission 3.
Yeah. Okay, Chris, back from the staging pits. What do we got?
We're up at team number 44 with the Universidad Pontificia Bolivariana. Sorry, probably botched that up.
It sounded perfect. You must be native speaking.
I tried.
Yeah.
Their plane is Barracuda.
They were giving you crap on social media.
I'm sure they were. This is mission 2 for the team. And they're flying with 3 ducks and 1 puck.
3 and 1, got it. 4, Universidad Pontificia Bolivariana. Sorry, man.
You do it.
You guys are braver than I am.
I'll work on my Spanish.
No, they UPB or UPB.
UPB, that's what they told me to do.
UPB, they posted something on social media saying we were close.
Okay.
We got close. There was an attempt.
With an attempt. That's all that matters.
We did all right. All right, hopefully this gets on reel too.
If that's the worst, then I'm okay.
Yeah, no, we love you guys. Shout out to their social media team. That was fantastic.
BP, I should have done that again.
UPB, dude. There you go. Barracuda's in the air. So this is mission 2. This is their cargo mission.
Remind me how many pucks? 1 puck, 3 ducks?
Yep. So this whole time, I've been talking about trade-offs here. You know, the minimum requirement is 3 and 1. 3 ducks, 1 puck. Some teams are opting for more, some teams are opting for less. That shows the different design decisions that you can take here, right?
Right. It's not just design decisions. I mean, everyone's programming to task, right? The idea is I want to maximize my points. So part of every report is a sensitivity analysis to say, how much does changing the wingspan help? Or if I go a little bit faster, how much does the decrease in the lap time help? So everything, because it's parameterized, or there's a cost function of how many points do I get per duck, how many points do I get per puck, they can make that decision. You can see some that are content with a relatively low number, others that just want to maximize it. And you saw some of these ducks that have hundreds of ducks or whatever it is, tens.
I think the Technological Institute of Buenos Aires had 151.
That's incredible.
That's pretty impressive.
Which, for the ground mission, it means they're spending a lot of time seating all those poor ducks.
Yep.
Now I can appreciate how hard flight attendants have it. Everyone, please get in your seatbelt on.
Yeah, right.
I haven't noticed any tray tables for the little ducks. Have you?
No.
Okay.
No. Ooh, wind's playing foul with that thing.
Yeah, it seems like it flies very nicely.
Yep.
You can see the slow ground speed on the upwind leg, but it seems like it flies nicely.
Now notice that they have on the trailing edge of the outside of their wings, it's kind of diagonal like a Spitfire. Now I know a Spitfire cut the wings like that to fit the guns in the wings, but I don't think we got that going on here.
I don't know that guns are part of this competition. I don't think so.
No, I don't think so either.
But essentially the taper in the wing, whether you taper, double taper both leading edge and trailing edge, leading edge only or trailing edge only, essentially it's to reduce the chord towards the tips. And what that does is makes your lift distribution a little bit nicer. Because if you have the rectangular wing, then you're trying to make as much lift as possible all the way out to the tips, and then you have the high pressure versus low pressure in close proximity, which it basically creates a lot of induced drag.
Yeah.
So the elliptical wing from the Spitfire you mentioned is, according to Prandtl, was the minimum induced drag planform. So if you have a 0.4 taper ratio, as in 1 meter chord on the root, 0.4 on the tip, that gets within 2 or 3% of that ideal elliptical wing. So why they did that? A lot of us make airplane design decisions because it looks cool.
Yeah,
frankly.
That's fine.
But it could be that's a mechanism to try to reduce the induced drag a little bit. Why induced drag is a problem in this case, not just for steady level flight, but when we're pulling Gs, you're having increased load factor, you're making more lift, you want less of a penalty in drag. So if the wing has lower induced drag, right, better efficiency, now as you're pulling Gs around, you lose less speed.
Is that why, like fighter jets have a swept wing and then a reverse swept wing coming out the back? They're kind of skinny out at the end and really thick towards the fuselage?
Yeah, so I think in that case, that's more a transonic thing, I suspect. And so I don't think we have transonic aerodynamic issues on any of these airplanes, thankfully.
No.
But yeah, I think the fighter jets, I can't pretend to know a lot of details of their design, but they have to work everywhere from 180 knots all the way up to Mach 2 or something.
It's not as easy as it seems.
No. And balsa is not a really good material for Mach 2 flight.
No, I don't think so. Okay, once again, we have UPB here with the Barracuda doing their cargo mission. With the cargo mission, just to refresh people, if you're just tuning in, watching at home, first of all, thank you very much for watching on the AIAA YouTube channel and over on Twitch. Thank you very much for watching, everybody. Appreciate it. Now this is a cargo mission. Once again, they have rubber duck passengers, hockey puck, cargo. And they have to do as many laps as they can in 5 minutes. More laps, the better.
Of course, they have a Price is Right rules here, right? Where if you just do a little bit without going over, And in this case, you want to make sure that you don't exhaust your battery energy, right?
Yep.
So if you try to go a little bit too fast, you burn a little bit too much energy, try to get too many laps in, and you land off field, you get nothing.
Yeah, don't want that. We don't want rapid unplanned landings.
No.
Okay. UPB coming in for a landing here. Oh, very nice.
Beautiful. Absolutely beautiful.
Yeah.
5-float landing roll is lovely.
Yeah. That was Universidad Pontificia Bolivariana with the Barracuda flying mission 2. I love talking aero with you, Majid. I'll be honest with you.
Happy to
if
be
you
here.
Want to stay here, you're welcome to stay here.
Happy to be here.
Okay, Chris, fresh from the staging pits, what do we got?
Up next is Team 45 coming from Case Western Reserve University, again with their plane Bathtub. And they're attempting mission 3 and deploying a banner of 94 inches. Thanks for that.
Gotcha, man. That's what I'm here for. Hey, it happens.
Do you know why it's called Bathtub?
I didn't get that actually.
I'll find out.
Oh, the rubber ducks.
Yes, that's why.
Okay, yeah, okay. Rubber ducky.
It's the one.
It's the one.
Now notice they have 2 sets of main gear, one after the other.
These are interesting choices.
Yeah.
I would say, I talked to them earlier on one of their previous flight attempts. They don't have any steering mechanism.
Yeah,
you
were saying
it's
that.
very rare to have an aircraft with, 3 points of contact with the ground. 4 points, sorry, 4 points of contact with the ground. This is one of those rare cases where not having nose wheel steering seems to work okay.
Yeah, doesn't seem to be a problem for them.
Has a centipede-like look in the air.
Yeah, it really does. Once again, this is Case Western Reserve University flying their Bathtub. Looking to deploy a 94-inch banner here.
One of the teams that was describing why they chose not to have steerable nose wheel or tail wheel was because they kept breaking in previous year's competition. Oh. Their mechanism kept breaking, or the rod for the nose wheel would keep bending. So they made a decision to say, forget it, let's have the stoutest landing gear both front and back.
Hey, there you go.
And it's worked in this case.
Oh, there you go, going for the banner deploy.
Yeah. Hasn't unfurled yet.
Oh no. Looks like the banner didn't fully unfurl.
So now they have to try different flight maneuvers to try to get it to release.
Try to just jiggle the handle a little bit.
Just jiggle the handle a little bit. Looks like it's winding its way closer to the airplane. Oh, there we go. Very nice.
That's awesome.
Very nice. Nothing like a little bit of drama before the banner release.
Right. Case Western Reserve people jumping in the stands. That's awesome. You know, I've been telling everybody, this is my first DBF that I've ever gone to. This is fun. This is fun to watch.
Really
it's fun to come down here and see this. This is a great time.
Again, for every one of these aerospace engineering students, ultimately, they may or may not design airplanes for a living, but they put into practice all of the things that they've been studying this time.
Yep.
And the necessary trade-offs, right? So you can't get everything. It's how much speed do you want? How much takeoff distance would you like? What kind of payload would you like? And so it's very fun to see looking at an aircraft that's finished, that maybe spent 6-7 months, the team has spent building it, and you can see a little bit in their thought process, what they thought was important.
See, that's what I've been doing. I've been trying to figure out, like, okay, why did they get, okay, I think they went with that wing because they want to go fast, you know?
Right.
I think they went with that, oh, geez. It's over in the spectator area. Oh, she's close to the ground. Oh, no.
All right, they put it down safely, though.
Yep.
I put it down away from people, I should say.
Yep. That wind's playing foul.
Yeah.
That's really what's going on here.
I think the other aspect is depending on how much excess power the aircraft has, it might not have sufficient amount of excess power to take into account the drag from the banner.
Yep. Absolutely. Those banners are like a big break off the back of the plane. So once again, that was Case Western Reserve University with Bathtub doing mission number 3. They did get a good banner deploy, but unfortunately they landed a little premature. Okay, Chris, who do we got next?
Up next is Team 46 coming from the Indian Institute of Technology, Kharagpur, with their plane Push Puck. This is second attempt at mission 2, and they'll be flying with 18 ducks and 4 pucks.
Okay.
So this is another one of your aircraft type that have different tapers along the outer part of the wing. So this one has a straight inner section, and then the outboard section has sweep on the leading edge.
Yeah. Why would you do half and half? Why not full sweep?
That's an interesting, I don't know. I think my guess is if you do half and half, then you have a spar that can run through the center section where you have the highest bending loads. You can have a nice straight spar, whether it's a tube or otherwise. The moment you're doing a taper, then it becomes a little bit more challenging as the thickness changes versus the span.
Oh, recovery truck going out.
But don't discount the whole looks cool factor.
Yeah, that's true.
Which are you familiar with Van's aircraft? The RV-10, RV-6, these general aviation experimental airplanes.
Yeah.
Same thing with mine. Mine has just a straight wing.
Yeah.
And you think of, well, why didn't you taper it? Honestly, it's a lot easier to build.
Yeah.
And the consequences, there's a little bit more fuel, and if the pilot doesn't care, then just put a little bit more gas into it.
There you go. All right. So this is the Indian Institute of Technology at Kharagpur with Push Puck doing their second mission. They have 18 rubber ducks on board, 4 hockey pucks. We're just waiting for last team to vacate the runway there. Recovery trucks are down the runway.
What do you think caused the airplane to go down?
That one?
Yeah.
Say the banner coupled with the wind. I mean, I think you nailed it with the engine not being powerful enough. I mean, it's, what is that called? It's easy to do it in a non-dimensional, right?
Yeah.
You do a non-dimensional analysis, you know, that's the kind of unknown you're not really going to know until you get here.
Right.
You know?
Another aspect that possibly is happening is if they're flying fine in the absence of a banner or just carrying the weight of the banner, as soon as they deploy, they have to have additional power, right, to compensate for that extra thrust, to compensate for the additional drag. If that extra thrust, because it doesn't come with additional airspeed, right, if that additional thrust could cause extra motor heating, it's possible that the electronic speed controller begins to sag as a result of overheating, the motor begins to overheat. That's the challenging situation even about glider towing. When you have something that's dragging you down but not providing any more speed, then high motor power, low airspeed, possible overheating. I don't know for a fact that it did overheat, but it could be one situation.
My mind is cast back to a B-36 and why they put 2 more jet engines on that thing to get the propellers to not overheat, because putting propellers behind the wing is not
turns out
a deal thing.
Yeah, and that's the problem with almost every single Cunard aircraft. Is that engine heating is always a problem.
Yep.
Look, I'm going to say, this is Clay, I was back out there walking my way back from the hangar here, and that plane flew right over my head. Mary Scott and I were down there, and it flew right over the top of us. It was pretty exciting.
I'm glad you're safe, sir. Of all people we should protect here, it's you.
We stopped, and we were like, okay, we shouldn't be standing here.
I've had 2 instances this whole DBF of saying, I'm not positive I'm in the right place relative to where this airplane's coming down.
Yeah. It was, you could see it fighting with the crosswind coming across there, and the banner was hanging on, and it was, the pilot was fighting, and finally it just couldn't recover.
So what do you think it was? Loss of power, excessive drag?
I think it was drag in the wind direction that got them. You know, because it had altitude and they lost altitude very fast.
Yeah. That's exactly what you said.
Yep.
Yeah, they didn't have enough horsepower to pull through.
Yeah. You know, I have something called the flight test triad, which is the airplane has to work, the instrumentation has to work, right? And then the pilot has to be able to fly the aircraft. And that's like this. You can do all sorts of things. The mechanism has to work, but fundamentally, if the pilot's not able to do it, right, in the current conditions, they get nothing.
Wow.
So we have the Indian Institute of Technology at Kharagpur with Push Puck doing their cargo mission. 18 ducks, 4 pucks on their cargo flight here. And of course, we have Clay Morey here, CEO of the AIAA with us. Once again commentating. Clay, how you doing?
I'm doing great. This is a beautiful, I love the copper wing on this thing. It
really
just
nice.
catches the light in the right way, and it's just a majestic plane. I don't know what it is about it, but I like watching it fly.
Pretty.
It's very pretty.
Are you getting Duracell vibes? That's what I saw initially.
No plane looks like it or flies like
Exactly,
it.
exactly.
How's that?
Yeah, very nice. It is very nice. It's beautiful
It's
colors.
a beautiful plane.
So we were debating on the sweep at the wingtips.
Yeah.
Right. They swept back the leading edge. We were sort of pontificating what it could be. What do you think?
Well, we were thinking about it a little bit with speed for the design piece. I'm not quite sure. I mean,
reduced drag maybe.
Yeah, maybe.
I don't think shock in the transonic range is that big of an issue with this airplane. Right?
See, that's what we were talking about before.
That's funny.
Okay, so
it certainly looks like it handles well.
Yeah.
Yep. And the winds, Clay, I tell you, they've gotten worse.
And sporty.
Oh yeah, very sporty.
You guys were out here earlier when my favorite design flew with that blended wing with the Technical Institute from Buenos Aires.
Beautiful.
Just fantastic. What did it look like here when you're out on the flight?
Oh, it was awesome. They aced it. It was great.
Yeah, I think it's a fight for the top between Argentina and Slovenia right now.
Really?
It looks like it. I mean, that's what the leaderboard looked like. So we'll see.
How many teams do you think we'll go through by the end of the day? You think everyone will get a Mission 3 attempt? Or think we're going to run out of time?
We've got about an hour and a half left in flight time. They were just putting out a call in the hangar that if teams weren't prepared to fly, to let them know so we could try to squeeze in as many flights as we could get this afternoon. So we want to try to accommodate that. Weather didn't help on the first day, but we've had beautiful conditions. Unfortunately, we've had quite a few rapid disassemblies or landings, as you said. Rules.
Rapid
rules
landings
today, so maybe that helped us in terms of cadence.
Right.
Yep.
I think a lot about Theodore Roosevelt's quote, "Man in the Arena," right? Because it's like coming here and having a crash sucks, but at the very least you were here. At the very least you were on the flight line, you tried to fly, you were in the arena, good on you.
Well, we had a couple teams that came here even though they didn't have their plane.
Is that so? Really?
Absolutely. They wanted to experience it, see what it was like, watch the other teams. And I think one of the really interesting stories is the University of Maine that was out here today. I don't know if you've talked about that.
Yeah, I talked about it. They had 13 teams come and help them repair their plane till 3 a.m., right?
So I was talking with the Virginia Tech team earlier today in the hangar, and they were saying how the lead engineer, he said, I spent hours with these guys last night rebuilding their motor and giving them parts.
That's awesome.
And that's exactly the spirit of what we're trying to do here.
I always say aerospace is a team sport.
Absolutely.
Pushback flying fantastic here. Negotiating the winds really, really nicely.
I don't think I've ever told you. You know that obviously technical readiness level, TRL, is essentially like how close are you to actually having a field of technology. For my students, I've tried to communicate something like CRL, competition readiness level, and it's fascinating for me to see them year after year. And it's 3 stages, right? We could talk about TRL stages. One is curiosity. Hey, I think I might want to, I'm coming here to see what this competition's all about. And then there is competence in the middle, where it's like you're in the middle of the pack, you can finish the missions reliably, and that top tier is competitiveness, right? So curiosity, competence, competitiveness. And I have all the broken out, the basically CRL 1 through 9, and essentially if you come to competition with like, well, I've flown it once and let's see how this goes, there's not a chance you're going to be competitive. And you can very clearly see, especially in Mission 3, the types of folks, the types of teams that are doing well have clearly practiced this before. This is not the first time they're attempting a mission.
So many of the failure modes here were the release of the banner. They didn't have that practice well enough. And I was telling you, one of the teams told me they practiced in a wind tunnel.
Oh, neat.
Yeah.
And we were just discussing this for some of the releases. Having that side loading or aero loading that can jam the mechanism is something that's hard to really predict unless you've tried it before.
That's right. I also think I was speculating when we were coming up about the release when you're going downwind with the tailwind behind you.
Yeah.
If that was somehow hindering some of these things, because some of them, once they deployed and seemed hung up, as soon as they turned back into the wind, it unfurled perfectly.
Maybe. My thing is, the airplane doesn't care about the wind. It's just going to fly at airspeed, right?
Does the banner care?
The banner doesn't care. It's all dynamic pressure. It's all airspeed. Up, wind, down. It should be the same thing. I could see the argument. I could see what looks visually. But to me, the airplane's flying the exact same speed this way versus that way relative to the air. The whole air mass is moving. That's and I don't know. I've had a ton of arguments over, does the tailwind actually help or hurt? I don't think it matters that much as long as the airspeed's the same.
Interesting.
That's my perspective. I'm about to fight with students over it too. So.
Okay. That was the Indian Institute of Technology, Kharagpur, with Pushpa completing their second mission. Chris, who do we have next?
Up now is Team 47 from Johns Hopkins University, flying their plane Peking J. They'll be releasing a banner of 80 inches.
80. All right.
Congrats, sir.
For Johns Hopkins.
Oh my gosh.
That's very nice.
That is outstanding.
Very, very nice.
This is going on my backpack.
That's the pilot who I think was asking, can I do a Cuban 8? Of course you can do a Cuban 8, right? Not my position to tell him yes or no.
So he is the Slovenian pilot.
Right.
That's the Slovenian pilot, but flying someone else's aircraft.
Yeah.
Yeah.
I've been so astounded to see over the years, right, 20 years ago, the volunteer pilots from Wyatt Sadler, Rip Rippey, all those old school guys, right? And then right now you have Aiden, you have this gentleman, they're just volunteering their pilot services. And you talk about like the monkey on the sticks, right? It's so important to have someone competent, and so these teams that have showed up without any pilot, the fact that we have some of these folks like that gentleman over there to help out is amazing.
Yeah, you could tell. And you know, I was chatting with the the San Jose State team after they got back, and we were walking off. They were walking off the runway here, and they were replicating. In fact, they had watched Ljubljana fly, and they were absolutely had learned some lessons. So watching the other teams, the top teams fly, and some of these top pilots, what's their strategy in terms of how low, how you're going to navigate the winds, where you're going to make the turns on the course.
Absolutely.
It was really interesting to watch that strategy play out, because I think they learned a lot from watching this gentleman fly.
Yeah.
That's the competition inside the competition right there. Right? There's a little bit of gamesmanship there going on.
But you know, that same thing is true for auto racing. Seeing someone's racing line, or air racing at Reno or Roswell, seeing how someone flies can give you a lot of good tips.
Pilots do it all the time crossing the Atlantic, right? The plane in front of them, they want to know where the clean air is.
Exactly, exactly. I try to do that. I try to give pilot reports as much as possible, but no one's flying at my altitude anyways, right? The big guys are all up high.
Good. All right, nice deployment.
Once again, this is Johns Hopkins with Peking J doing their third mission with the banner deploy. Oh, look to be having some trouble.
Yeah, I think there's some tough air there at certain altitudes. This is why I think the pass lower to the ground seemed like a better play.
I will say it's interesting the different choices teams are making on where they put the attachment, the tether attachment. Do they put it at the tail, or do they put it near the center of gravity?
Yeah, that's exactly right.
This is one that's chosen to do it close to the center of gravity.
And how long is the leash behind it?
I'm guessing
this one looks like it's
10 feet or so, maybe?
Exceptionally far behind the aircraft.
Yeah.
Does that affect the drag, do you think, for aerodynamically? How far behind?
That's interesting. Like if it's near the wake, I don't think it would necessarily. Once it's behind, it's very nice.
All right, the release.
But you know, seeing how far the banner floats downwind is a good measure of the wind speed.
Absolutely.
I mean, looking at the windsock, boys, we got a full windsock out there.
Full sock.
Really windy now.
What do you think, Clay, about the drag, depending on the distance away from the airplane? Do you think it makes a difference?
It seemed to me just visually today that it made a difference. I think that the team that had it closer to the plane
was it better?
Was better somehow. But I don't. It's hard to tell visually.
So we've done a whole bunch of formation flying in the wake of another airplane, and it's just dirty air back there.
Yeah.
So the question is, how far back do you have to have it so it's not influenced by the wake of the wing?
My speculation is
right.
if it was far enough back that you weren't going to get the turbulence coming off of the plane, might it be a better thing?
I think you're right.
Once again, that was Johns Hopkins deploying their banner, doing mission 3. Chris, who do we have next?
Up now, we've got Team 48 from the University of Texas at Austin flying their plane Peacock. They're going to release a banner, or attempt to release a banner of 134.75 inches.
Okay, cool. Clay, back to you.
So, we were at SciTech earlier this year, which is our R&D conference, about 6,000 engineers that assemble in Orlando, Florida every year. And we had the CTO from F1 there. And he's former NASA Jet Propulsion Laboratory engineer from Pasadena, California, now works for the F1 teams, and he was talking a lot about exactly what we're talking about here, which is the dirty airflow. And if everybody's watched the movie F1, you can Brad Pitt's character is talking about this a lot in that, about how dirty the air is and how you can cause problems for the cars that are right behind you.
Ruin the tires.
And what they were talking about with this year's, and I haven't paid that close attention to the competition this year. I know there's some controversial things going on with the car configurations, but what he was explaining is that they actually have now the ability to actively change both the front wing foil and the rear wing foil during the drive. But it can only be done by the driver in the cockpit. So you can see they all have these command control centers where they're doing digital twinning. It's just outside of London where most of the teams are based. And in real time, they're getting 600, in some cases 600 sensors on the car. And they're providing feedback to a central computer. And then telling the pilots and the drivers in real time how to adjust those two wings. Can you imagine that? You're driving 200 miles an hour and they're talking in your ear. You need to do this a little bit going into this turn and this. You got to lower the foil here. It's unbelievable to me the talent that would take, the concentration.
Much less the G's, much less the physiological load factors, right? Now you have to fiddle with all the configuration of the vehicle. That was one of my favorite plenaries, by the way. You did a great job.
Fantastic.
Okay, so we got UT Austin here with Peacock doing their third mission.
I don't want to throw shade. It's surprisingly white for an airplane called Peacock.
Yeah.
Hey,
they got a good deploy.
Hook 'em horns right up there.
That's right.
There we go. Let's see how it plays in the wind.
He lost quite a bit of altitude on that turn, but not sure if that was intentional or otherwise.
So the earlier pilots were taking them up high in the turns and then sweeping down low.
Right.
Both upwind and downwind. It seemed to be a good strategy. But so this is what I'm saying now is you look at that leash length and it looks like they're laboring.
And so he's probably 1.5 to 2 plane lengths before the banner. And it looks like that can't be low drag, right? All that flapping around.
We were saying about, you can just hear from the flutter noise behind it. It seems like it's more resistance.
And it's funny, you talk about the changes in altitude, the low close by and high far away. Some people fly on a slant angle, right? So because their perspective is like this, so they'll naturally do that.
Interesting.
And of course, you have to do a low flyby to impress the crowd.
Well, we had the San Jose team was flying about 10 feet off the deck here.
Right.
And they were really ripping. Texas looking good here.
Longhorns logo on the banner.
So we were debating debating about the possibility of motor heating on banner deploy, because you have all the extra drag, you have to compensate with increased thrust, but you don't get any more speed out of it. So do you think motor heating is a problem during banner tow operations?
I would guess it would be. It's pure conjecture on my point, but I would guess that motor heating is going to be an issue.
And it makes me wonder sometimes, maybe if that airplane that went down close to you, if they were full throttle, right? Because it seems silly to be descending and not be giving it all it has. I wonder if he was full throttle, draining the battery, right? lower state of charge.
That could have been.
Right, higher motivation.
We know that yesterday that the Buenos Aires team was on fumes coming in with the battery power.
Really?
At the end of the meeting, and they had was 150 some odd ducks on top of it. Yeah, in the plane, and so
wow.
Yeah, they were coming in right at the end, almost gliding in.
I do love that fact that the design, the TC that really helps set up the DBF committee, they're making all these rules, but they can't possibly anticipate all the ways the students will interpret them. Nobody thought of 150 ducks or whatever it was.
No, it's amazing.
And a shout out to them for their creativity and coming up with something new and fresh every year.
I was going to ask. I was watching the stream before. Could you tell when the Dorito was in the turns? Because yesterday they seemed to really lose a lot of airspeed when they went to corner here.
When they were deploying that banner, that thing slowed down a lot.
Slowed down a lot, but they didn't seem to have as much trouble negotiating the turns today. And I wonder if that was because the ducks and pucks were slowing them down.
Maybe.
Some good speed downwind.
Yeah, so what do you want? Do you want more load? Do you want to have to carry more weight and increase angle of attack, or basically have a lighter weight aircraft but now be towing something that produces drag?
This is a nice mission here.
Yeah, very, very well thought out.
See, Austin, 1 minute left in their 5 minute allotted time. Really battling against the wind there.
Oh, it looks like maybe lost some motor power.
Oh,
gosh.
That banner. See, I don't know if that was power again. Once again, same thing.
Once again. But maybe, to your point, maybe they were losing battery power here.
Yeah, so we were talking about Price is Right rules, right? How many laps should you do? And if you're really pushing against your state of charge, you're pushing against how much capacity you have left in the battery, sometimes it's better to say, maybe I left a lap out there, but bring it in under power. Because the moment you are a little greedy, I'm not saying this team was, if you go a little bit too far, lose the motor on the backside, and don't land on the runway, you get nothing. And that's the strategic aspect, right? The piloting and the system analysis aspect of this.
So give me a price, but no, don't go over.
Don't go over.
Yeah.
$1.
How many laps do you want, right? Go over, you bust.
And you get the won't.
Exactly.
Yeah.
Okay.
That's good. That was a good, I like that.
Thank you. Chris, who do we got next?
Up next is Team 49, coming from Texas A&M University with their plane Aggie Bullet, and they're going to attempt to release an 85-inch banner.
Okay, Mission 3, Texas A&M College Station.
It's a nice stout landing gear.
Oh, yeah.
Well, the Aggies really won the cheering section yesterday.
Oh, absolutely.
Yeah, I mean, they really brought it. And they were doing a little bit out in front of the hangar earlier today as well. They were doing a little
Saw that.
Yeah, it was
the farmer's singer?
Yeah, it was very funny.
But you know, it's a lot like college graduations. As a professor, I've attended many, many graduations to support my students. And there are some folks who go across the stage and have tens or hundreds of people cheering, and others with just a golf clap, and you can never know, right? So part of this is having a huge crowd or huge teams to cheer them on is really nice.
It's the amount of crowd support we've had today has been fantastic, and it's great to see the thank yous and the cheering on the other teams. I really love it.
And then even over on the live streams on the AIAA YouTube channel where we're live streaming this, and the Twitch channel, got a lot of support over there. A lot of people who can't come out here to Wichita, coming out over there on the online to watch the competition. It's good stuff.
Yeah, I think we had over 800 viewers a couple times today.
Hey, that's not bad at all.
Yeah, really. Thanks to everybody that's tuning in today. We're glad you're with us. Hopefully you'll stay for the award ceremony later today and get to hear all the great stories that came out of the day.
Okay.
Have you seen the bingo card?
I have seen the bingo card. I had a really good hearty belly laugh out of that one. It was fantastic. I don't know who created that, but kudos.
Okay, fill me in. What's the bingo card?
All right, go for it, sir.
No, please.
So my students were the one that pointed this out on the DBF Discord. There is someone that made a bingo card, and some of them are absolutely fabulous. Like there are some here. I'll let you read some. So this is the DBF Wichita bingo card. Like, it's raining ducks. Prop strike. Plane begins acrobatic maneuvers, right? Lipo fire. We haven't had that one, thankfully.
Oh, jeez.
But what's going on is this closed loop process where people will, every time something happens, they'll fill another square and re-upload it to the Discord. It's very nicely done.
That's great.
The Aggies are in the air.
Yep.
wind picked up considerably there in the last minute.
Oh yeah. There's the banner.
I'm really impressed how well they stabilized the banners.
Finally got stable there.
Yeah.
Wow. Laboring upwind.
I have to think some of the teams that are most successful probably looked into actual banners, right? The banner towing aircraft.
Yes.
Because we have solved that problem fairly well, right?
Yeah, absolutely.
Especially where the point of tension is, where the weight is relative to have a nice stable banner behind the aircraft looks lovely. But this one's flapping all over, Clay.
Yeah, it really is. College Station bringing their A game here.
So you were saying you think where it's affixed to the fuselage has an impact of the...
I think so. So I think of it in the glider sense. When we do tow gliders, right, there is the tow plane that has a rope that goes all the way to the glider. We usually have that rope affixed to the tail, which means if the glider's going around, you can maneuver the tail of the tow plane. Think of it like you're adding lateral force or vertical force, and you can change it in pitch, which is why both pilots have a release mechanism. I don't actually know how banner towers do it, except I think they have a big hook. They do that big dive and swoop up and catch the banner.
To the rest.
Right, and I think they do it quite off the trailing edge, meaning that, well, the nice thing about the banner is at least it's going to be linear. It's always going to produce drag right along the line. And I don't know if it's off to the side, if you're side slipping, for instance, if it'll have corrective or divergent moment. But, you know, no matter how bad the banner is, it can't be worse than a student glider pilot.
Okay, once again, for the folks watching at home, this is Mission 3 for College Station, Texas A&M College Station with Aggie Bullet here. They deployed their banner successfully, and they have to fly that plane around the track and see how many laps they can do in 5 minutes. Or, I mean, we were talking about this, maybe take a little bit of a lesser lap and save the plane, because that plane has to do a lot of work moving that banner around, especially with the windage out here in Wichita today.
Power management is key here.
Yep.
You know, had we not had weather issues on the first day, we might have gotten the flight order all the way through 4 times, so that the teams that are capable of doing mission 1, 2, and 3 then get a reattempt, and then they can use that to try to improve their score. And that's when you go for broke. Yep. That's when then you can say, all right, let's push a little bit harder, let's sacrifice the airplane, here's our last flight.
You know, when I was watching, I went to my first F1 race a couple of years ago in Baku, Azerbaijan. And I noted that, you know, in the qualifying, in the time when they're trying to really make times, is where they push it even more than in the race.
Really?
Oh yeah, because they go for broke, right? And they have the ability to bail out in certain corners, but you see them breaking off the front wings of the car. You see them bailing out left and right because the drivers are really going for it. In the qualifying,
especially Sector 2 in Baku.
Yeah.
A lot of tight corners.
Oh my God, it's so crazy how tight. It's these old city streets that are there, and a lot of sparks coming up from the bottom of the chassis that are just hitting the deck going through the turns,
scraping the barge board.
So speaking of qualifying, I had a discussion with some students who were saying, hey, if I don't get my flight 3 attempt, isn't that unfair? And so in a sense, yes, but I also had to tell them it's just like qualifying in F1. If you write a good report, if you're one of the first few teams, of course you'll get all the attempts.
Yeah, there you go. They did deploy their banner, Texas A&M College Station, circling around the Aggie Bullet. Uh-oh, might be out of power.
All right, now we've seen it.
It's that thing.
I think maybe 3 times now we've seen this.
Yeah,
so there may be a trend here.
And I think this is part of proper practice ahead of time, knowing the power consumption both with the banner and without the banner, right? And that varies with speed, because it could be maybe if you reduce the speed a little bit, you get better range. And it's hard to know this, right? You're flying a remote airplane. But that stinks for them, right? They didn't get to score a point. Well, they didn't score Mission 3 because they didn't get back to the runway.
Yeah, but it might be a Sammy Hagar kind of thing here, that they can't drive 55, right? They feel like they have to be to the wall on this thing because they're going around trying to make as much time as they can to get through this.
I mean, Ayrton Senna said something, right? If you're not driving hard, you're not a race car driver, right?
That's right.
Yeah. So
they went for the gap, right?
That's right.
There you go.
Okay. Chris, fresh from the staging pits, who's the next team we got teed up?
Up next, we have Team 50 coming from the University of Central Florida, flying their plane Albee. This is their second attempt at mission 2, and they'll be carrying 3 ducks and 1 puck.
Okay, 3 and 1 for UCF.
Remind me, the rules say as long as once you release the banner, you can land straight ahead, and that counts.
That's
right?
true. I think we had a few flights earlier today that did that.
And had they made that decision, of course, it's so hard to know in the heat of the moment. Had they redone that, just chop the power, land as long as you need.
Yeah, that could have been the case on that one.
Yeah,
they landed here from the runway, but they just barely. You saw it losing power there at the end.
Yeah, not knowing your bingo fuel, not knowing where you are in the state of charge. It's very, very hard to make those judgments.
Situational awareness.
Yeah.
Big one.
You know, one of the things I've always loved about DBF is that there's never an autonomous aspect, save for the glider last year, right? Yeah. Because you have to design an airplane that can be flown by a human. Right, we can do UAVs, we can do autonomous things, but I love the fact that, it takes a guy on a stick still. Yep. You have to make it reasonable enough, and what do handling qualities mean? What does it mean to actually make something that's flyable by a human? So it's not just, does it have the performance numbers, does it actually have the handling as well, and I love that aspect.
Human factors plays a big role in this.
That's right.
Yeah. As all of life, maybe.
Yeah, exactly.
I could be prophetic.
Yeah, please.
You ain't kidding. Okay, so once again, this is University of Central Florida with their plane Aggie.
You know, I try to do that a lot with my students. When I teach handling qualities, I put them on the simulator and I put the center of gravity way far back, so it's almost impossible to fly. And I don't want to stress them out, but I want them to see what an airplane that sucks feels like, because they have that responsibility when they produce stuff. Pilots should love their airplanes. Yep. And this is one where you can look at the tandem wing airplanes, the biplanes, and whatever configuration that you want, and then you realize if it sucks to fly, then that's not a marketable thing. And if you're trying to, like, what we make airplanes to make money, fundamentally, right? We're selling them to customers to meet the requirements. And if you're not meeting the requirements, or if the customer doesn't like the aircraft, then you're not going to get another sale, and the company's going to go broke.
You ain't kidding.
It's like the rental car I'm driving this week. I'm never going to buy one of these. I'm not going to say who it is.
Oh, I'll talk to you later. You know the Mitch Hedberg joke about rental cars?
No.
Very quickly, Mitch Hedberg, you know him, the comedian?
I know him well.
Yeah, so he's like, I was driving along, and then 5 miles in, I noticed my emergency brake was on. He's like, that's not much of an emergency brake then, is it? It's more like an emergency make my car smell funny lover. So yeah, every rental car is different, and some you rent, you're like, I will never pay money for this airplane or this car.
There you go. So UCF with Aggie doing their cargo flight here, taking off. Now once again, rules for the cargo flight here. This is mission 2. You have to load down your plane with rubber ducks and hockey pucks. They got 3 rubber ducks, 1 hockey puck. They got to do as many laps as possible around the track in 5 minutes. Oh, really battling that wind.
Yeah. Wow. We had some beautiful clouds as backdrop yesterday.
Yeah, yesterday.
Really
candy clouds out there.
Yeah.
Pretty.
This massive descending turn here.
Now, Clay, I gotta ask. You said you went to a Formula One race. You said you went to Baku. Who's your favorite Formula One team?
Well, I'm a Mercedes guy.
Oh, no, Clay, no, so not right.
No. Yeah. Are you a Ferrari man? What do you got?
I'm a Ferrari guy.
Yeah, I figured that.
I've known nothing but misery for the last 20 years. Aggie performing really well. Really well.
Ferrari, one of the few teams that doesn't have their mission control outside of London, right?
Wow.
Yeah, that wouldn't be allowed, right? You have to be in Italy.
Why is that? Why is London so popular for mission control?
Well, it's just on the outskirts too. It's not in the city. It's out in the countryside, just outside, where you've got several teams that are out there. I don't know. That's an interesting dynamic. Maybe because of racing history.
Yeah, maybe.
Yeah.
I will note that for U.S. mechanical and aerospace engineers, we don't, for universities, there's not a typical mass that wants to work with F1. But outside the U.S., every university that I've been to, their dream goal is always F1, be on an F1 team.
Interesting.
Well, in the movie, it's the female lead engineer role she's a Lockheed Martin aerospace engineer.
Really?
Yeah.
There you go.
Yeah.
I mean, Adrian Newey, he's an aerodynamicist. He's an aerospace guy.
Oh, yeah.
He's on some of the most notorious Formula One cars for the last 30, 40 years.
How do you hold the car down to the road?
There you go.
Yeah, it's all about pushing the car down.
Actually, do you know who Milliken is? Doug Milliken. He wrote a book called Race Car Vehicle Dynamics. He's an aerospace engineer that wrote like I have that book on my shelf. You right? Isn't it a fantastic book?
Gray with red text, right?
Yeah, absolutely. Yep. And it's like the best book that I've ever read on how do you make a car go fast, but from an aerospace engineering perspective. He has things like stability derivatives for the handling of cars. It's fantastic.
Oh, that's great. Yeah, that is a good book, and it's got a lot of diagrams in it too.
Yeah.
Good stuff.
I'm not saying aerospace engineers are better at everything, but we certainly know how to design cars.
I mean, yeah. Okay, Aggie performing really well for UCF's cargo flight. Golden Knights.
Boy, battling upwind. Battling.
The wind's getting bad. Oh no.
Pull out.
Commentator's curse. Sorry, guys. That wind, the
wind is really taking its toll today on the competitors.
Yeah, it's claimed a lot of planes.
I hate to keep going back to this, but like, land early, land with power, right?
Yep, there you go.
I think what looked to me, and I'm speculating, is as the aircraft it looked like the motor cut out. Maybe they tried to do one too many laps. He was trying to hold altitude. Looked like the airspeed, you can't see airspeed, right? The ground speed decreased to almost zero.
Yep.
And it looked like it was a stall spin.
Yep, absolutely.
Right? And it's like, at some point, if the motors quit, you have to come down. There's no choice. You can't pause it.
Rapid unplanned landing.
Yep. And that's the thing about stall spins. You know, if you fly an aircraft just above stall speed and you crash into anything, you're probably going to be okay. The moment you stall spin, the natural, stabilizing tendencies of the aircraft will overcome you, and then coming in vertically is always worse than coming in horizontally.
Yep.
That's what I do a lot. I do spin training for pilots that want to be CFIs, and I just try to emphasize if that happens close to the ground, we're done.
Yeah.
Up and away, no worries, right?
Yep. Right,
and that came.
Trucks out.
That was what was an amazing flight. Unfortunately, had a terrible ending.
The plane was. It was really. It was moving well until the end.
Really doing well. Well, as UCF goes out there and picks up the pieces, who do we got next, Chris?
Coming up is Team 52, California State University, Long Beach, flying their plane Mako. They were our first flight this morning, and they'll be flying Mission 2. With 3 pucks and 1 duck, and the team asked me to give a shout out to Dr. Karcher, telling me he's the GOAT.
He's the GOAT. He's goated.
So we've gone through the full flight order already.
Yeah.
Okay.
More or less. I mean, looking through here. Yeah, we haven't gotten all the way through.
I see.
But that means that some teams may. You said you could opt to try to go for another slot down the road, like the next time the rotation comes around, right?
I don't think any team will have the opportunity to repeat a mission.
Yeah.
Or have 4 flight attempts.
Yep.
I think we're going to run out of time before every team gets 3 flight attempts.
I have about an hour to go.
Yep.
So. AJ, you said that, and that made me think of the average white band should be playing in the background. There's a lot of great social media game out here this week by these different teams. One of the teams posted that they showed the wreckage and the ducks, and they say they had killed 12 passengers. It was pretty dramatic, but it was funny because it was like an old timey newspaper article. But I'm thinking if you needed a soundtrack for this, pick up the pieces might be a good one.
That's
right?
a very good one. Yeah. I'm forever in search of good soundtracks, right, for DBF crash videos, right? So I did one that was learning to fly, right? So
absolutely.
That'll be okay.
Wait, which learning to fly by which band?
Yeah, you got Foo Fighters. You got
Tom Petty.
Okay.
Learning to fly, but I ain't got wings, and it goes down, right?
Yeah.
And actually, we had a really good visual 2 years ago when we were here on site. Textron had the vans as opposed to the pickup trucks. And so what they do, every time there was a crash, they'd load up the airplanes and then put the students in the back of the van and close one door and the second door. And I filmed every one of those because it was a great visual, like, we're closing the door on you guys, I'm sorry.
There you go.
Oh, Pat decline, maybe. I fall to pieces.
Oh, very nice.
All right, I'm trying to go through my head.
This is
good wreckage songs.
Yep.
Yeah.
apparently now I'm doing it.
You know, there's a bunch of songs with burn in the title, but we haven't had that. Thankfully, those lipos are in that lipo safe container.
Yeah.
Burn, I immediately think Deep Purple.
Really?
Oh yeah.
I was going Blue Oyster Cult. I'm burning for you.
Even better.
Oh, that's a very good one.
Right.
Even better.
Honestly, what you could do
I've been astounded looking at some of the landing gear configurations. It's just a great design study or design case. Why the nose gear is larger radius than the other ones, I don't understand.
Oh no.
The grass got him.
Yep.
Wow. That wasn't even a high-speed taxiway.
No, but we've seen that repeatedly this morning with the angle. This has got like a 45. If you look at the sock, there's like a 45-degree runway, and as soon as the pilots power up, just they overcorrect. Every single time.
Yep.
And they end up doing that kind of spin out thing. And some of them were able to recover, but a lot of them ended up just off the runway here or over there. Because of that. And just not kind of not learning basically, right, from what they saw before. Maybe taking it a little slower on the throttle, coming off the line.
Right, and that's the thing. Just bring up nice and slow, under control.
Okay, Chris, who do we have next?
Up now is Team 51, Embry-Riddle Aeronautical University in Prescott, with their plane Hail Mary. This is their mission 3, and they're attempting to launch a 92-inch banner.
Okay. One of the bigger banners that we've seen.
This was an impressive plane yesterday. We saw this aircraft fly. It was really something to watch. I'm interested to see how this one goes for these guys. I think they could get 10 if they can get a good mission set.
So what do you think happened here? It was initially a weather vane to the right, pilot overcorrected to the left, and then by the time you get the tippy thing, right?
You saw it kind of skitter there, and then they couldn't recorrect, and then the wind's coming from behind them at that point, right? So they had to.
And then a downhill taxiway. But it's a tall gear. So the moment you have any sort of lateral G's, it's going to start tipping now on it.
We saw this with some of the landers, right? Recently with the CLIPS program with NASA. They didn't realize the CG and how high the CG was on. So they hit the landing, and then they didn't realize that it was a different gravity, right?
Yeah.
1/6 gravity.
Right.
So it's not like landing on the Earth.
Yes,
right?
that's exactly.
And then they ended up tipping over.
Yep, 2 times.
2 times. Look at this plane go.
Wow. That's awesome.
Yeah. Impressive.
Yeah.
What a helpless feeling to be tipped over on the moon.
Yeah.
Did you guys ever see the Japanese mission to the moon, the SLIM mission, where the lander landed in the ground like nose first, and then it ejected the camera, and they took a picture of the rover or the lander, and it's like halfway into the regolith?
That's like the war journalist stereotype, right?
Yeah, exactly. Looks like Roadrunner and Coyote.
Yeah, exactly.
The banner is out, but not fully unfurled. See if it, when they turn back upwind here, if it improves.
Yeah.
We've seen this on a few of these flights.
Yeah,
right.
There it goes.
There it is.
Yeah. So this is my
I don't know,
speculation.
Clay, I don't know what to tell you, right? Because I'm like, the airspeed's the airspeed, right? But you're making observations, right?
I'm just doing it from visual. And all I can tell you is I've seen that 5 or 6 times today.
I hear you.
And visual observations is part of engineering.
That's right.
It's part of the process.
But it's amazing to hear that the note of the airplane changed so much. Like that's a lot of thrust compared to what we're seeing on the speed. Obviously, it's going upwind.
Yeah.
But now you talk about like learning from other teams. Several teams have had power losses, right? We've seen that several times. How does that change the strategy of the pilots have?
I feel like we're kind of on the 14th green, and we're watching the guy's putt, and we're like, well, that guy didn't watch the break, or they didn't see it, right? They didn't see the other force.
Yeah, exactly,
here
exactly.
And see it. So it's a little bit of quarterbacking here from us. When some of these teams might not be paying attention, but it just means you should watch the live stream. I think, right?
Yeah, I think so.
You got to do more live stream watching.
Yep.
Or have somebody on your team do that and inform the pilot.
Yes. Yeah, absolutely.
Shout out to all the people watching out there on the internet, on the AIAA YouTube channel, and on the Twitch stream. Thank you very much. What's up, Chad? How are you?
So I'll go back to that quote from Theodore Roosevelt. The first part is, it's not the critic that counts. I'm like, but we're critics. Don't we count for something? And maybe not.
Well, you know, this plane was one of the higher performing planes in terms of speed that we saw fly. And you can just see how fast it is coming downwind versus upwind, and how much it's laboring coming up.
Yeah.
And again, to the battery power, we're going to see how this does in terms of how many laps they can get in.
Because this is just such an off-nominal situation. The power consumption is going to be a lot longer. And of course, then there's the fact that it's in a wind condition. You're going to spend more time going upwind compared to the time saved going downwind. So it's going to be much longer. You can't just count it in terms of laps.
Exactly right.
Factors at play.
Yeah, so you have to make that calculation when you're thinking about power management, right?
Yeah, exactly.
Okay.
So trying to shed the
Yeah,
banner.
it's feathering it. Oh no.
All right, they got the flag. Look at the difference. Wow. It's extraordinary.
Now, do you think they're going off throttle when they got a tailwind?
I really think if the best strategy is just keep the wind. Well, I'm going to say keep the throttle constant, except if you go into gliders. Gliders is always power into the wind, throttle down on the downwind.
Yep.
A lot of oscillation.
There we go. Come on.
Come on. Bring it in. Perfect landing. Wow.
Very nice. Very nice.
That was some skillful flying right there.
Good.
There's nothing like holding that nose wheel up right with the main touch first.
The other thing we've seen on that landing strategy, which was interesting, with Yana and some of the other teams, they actually stop the prop just before they land, and they come in just gliding, which is, I think, is really an interesting strategy.
Right.
Really slow airspeed when they touch down.
But you have 8,000 feet of runway. There's no worries. Just take the whole runway.
Exactly right.
All right. So that was Embry-Riddle Prescott. And Chris, who do we have next?
Up next, we've got Team 53 coming from the National Cheng Kung University with their plane NCKU Ironman. And this is their second attempt at Mission 2, and they'll be flying with 64 ducks and 9 pucks.
64 ducks.
Sounds like Iron Man might be Tony Stark for one of those
That's
ducks.
right. I mean, the color scheme exists, right? That's a Tony Stark color scheme.
That is some classic Iron Man right there.
That's right.
That kind of yellow, bronzy gold.
Yeah, absolutely.
And red.
I don't think that's an accident.
I don't think that's by accident.
I'm waiting for the jet boots, sir.
Yeah.
Yep. Jarvis, fly the cargo mission.
There you go. Nicely done.
Nicely done. I like it. Iron Man was one of my favorites when I was a kid.
Oh, yeah.
In terms of superheroes.
So once again, for the people at home, this is National Cheng Kung University. NCKU Ironman is the plane. It's team number 53 flying there. It's another attempt at their second mission.
I also enjoy that a lot of these guys have had the see-through fuselage where you can see the ducks inside.
I love that.
It's a really nice feature.
No one better than UCCS though, with that Pilatus PC-12 looking airplane with the windows. Yeah. That sir is my favorite.
Yeah.
We were liking that plane.
That is a gorgeous airplane. Yeah.
But it's like, you know, Jay and I were talking about like how awful it is to be seated on an airplane with all the window shades drawn.
Yeah.
So the clear monocoque helps. The ducks should have situational awareness, right?
Okay, powering up.
See that a little bit?
Yeah.
He's fighting it.
Interesting the oscillations in roll though.
Yeah.
Or has it slowed, like pitch and roll combined?
Yeah, it's going up and down and kind of wants to roll left a little bit. So once again, for the people at home, this is a cargo mission. So there are passenger rubber ducks and hockey pucks as cargo aboard the NCKU Ironman. The whole objective here is to fly as many laps as you can in 5 minutes. Once again, we're battling into that headwind. You called it. The power management is very important here.
Yeah. I'm interested, again, all the landing gear, wing, tail configurations.
Yep.
These guys chose to go with an H-tail, twin vertical stabilizers.
Yeah.
It's not clear why. I can see for multi-engine airplanes or twin-engine airplanes where they want something in the prop blast. I think it looks lovely. Has a little B-25 feel to it.
Yep.
Liberator?
Yeah.
Yeah.
I mean, it's missing an engine, but still, it's nice.
Wow, look at that move.
Yeah.
Now we did see, I believe it was Purdue. They went with a split B-stab because their deployment mechanism for their banner was in the middle there.
I was so surprised that that choice was remarkable.
Yeah, smart.
Because usually you let gravity do its thing.
Yep.
That meant that the banner had to clear both vertical stabs on the way back and not get impinged on anything.
And it did
it did.
too.
So good on them.
Impressive.
Who was that team that had the transverse of the lateral banner?
I think that was UCCS.
Was it?
Yeah.
And that wouldn't come out?
Yeah.
Yeah, that's right. They brought the airplane back.
Yep.
The Ducks were happy. They had a good view, though.
Yeah, they had a great flight. You know, speaking more to that, I hate it when I do have a window seat, you look out and you see clouds. It's terrible.
So I've taught students, given instrument ratings to a bunch of people, and for their first time in clouds, where the windows of Cessna 172 are just white.
Yeah.
You know, as much as they've practiced with hoods and foggles, it's not the same thing as being immersed in a cloud.
Right.
There's this helpless feeling of, which way is up? Where am I?
Yeah. Watch those instruments, right?
Yeah, exactly. Which, you know, going back to my flyby, that's a courtesy thing with smoke. I could just be lighting up smoke all the time, but the guy behind me taking off might not like it so much, so I have to be a little bit courteous about it.
I don't know if you heard, but they didn't tell the local fire department you were going to be doing that.
Oh.
So there was a responder truck
Was it really?
that came out.
I didn't realize that.
Yeah, so best practice, give the fire department a call, let them know you're going to be dropping some smoke.
At the very least, give the fire station a courtesy smoke run, right?
Yeah.
Yeah, because I was right over there southwest of the field coming in on a diving turn with smoke on.
Coming in for a landing, Ironman. Good touch.
Very nice. Very nice.
Oh no, front gear came off.
Yep, hold the elevator up. There you go.
All right.
Not bad. Not bad. Nicely done. Very nice.
Wow. And they still get credit for that, even though the wheel came off.
So I actually talked to the judges. It depends on how the gear actually comes off. I'm
Yeah.
pretty sure they'll let that one fly. That one was good.
If it's something frangible, if it's something like nylon bolts that break, no worries, those are replaceable. If it removes any kind of bulkhead, then it's considered damage.
Got it.
Which is a really difficult decision that they have to make on what is damage, what is not damage.
Yeah.
Yep. Okay, NCKU, Ironman, completing their flight. Who do we got next, Chris?
Up next is Team 54 coming from the University of Massachusetts Amherst, and they've changed their plane name. They're now calling it the JB Welding. I think that's because of a little accident they had earlier. So this is their Mission 1 second attempt.
Okay, UMA, up in my neck of the woods.
Are these guys also not wicked smart?
No, they're wicked smart.
They're wicked smart, okay.
But they're wicked smart to the west of 495.
I see.
Understand, that's a completely different thing. It might as well be a different state.
I got you, I understand.
Now, remind me, is Amherst, is that the zoo mass?
Yes.
It's called the zoo?
Yep, it's called Zoo Mass for a reason.
All right.
So here's our chief judge coming to make an inspection on that nose gear.
Yep.
Okay. And are they the... Are they the Minutemen?
I think so, yeah. Let me check.
Nice, yeah.
Who needs the nose gear anyways?
Highly overrated.
As a tailwheel pilot, I agree, sir. You know, Clay, at some point I'm going to have to take you up and light some smoke up in the airplane.
I'm excited to fly with you.
Looking forward to Oshkosh.
It's gonna be fun.
Yeah, it's gonna be a great time.
So my smoke system has two modes. One is put it on, it just dumps smoke. The other one is you put it the other way, and there's a push button for momentary. So you can type messages in Morse code if you wanted to.
All right.
As long as we're not
SOS.
Not SOS, right? Because then the fire department will be called again.
Yeah, exactly.
So yeah, you're right. Minutemen.
Minutemen.
Yep. Their mascot is Sam the Minuteman.
You guys good on sunscreen?
I'm good.
Okay.
I think you're looking a little toasty back there, but all right.
Do you want some?
I mean, yeah. Here, hold that for a second. I'll be right back.
All right.
So here's another tail dragger.
Another tail dragger. Another.
Look at that.
Again, but you saw that correction.
I saw that.
Right?
Yeah, you're right.
It's
very keen observation.
You watch them 10 times, and you're like, okay.
There's a pattern here. This is a reattempt at mission 1. Do you remember what happened on their first mission 1 attempt?
I do not remember. I don't think I was on the line for that.
A little bit more of a loop there.
Yeah. A lot of carbon fiber in this aircraft.
Yeah. Yeah, it's a very nicely designed airplane. Yeah. It doesn't look like there's much dihedral, which means I suspect that laterally it's going to be a little bit more workload on the roll.
Okay, how they doing?
They're looking pretty strong here.
Uh-oh.
Oh.
The wind.
The wind is the enemy today.
Yep.
Yeah. Every time he does that 360, it tends to be more of a loop than a turn.
Yeah, I don't know if you've seen it. It's pushing the airplanes that way. A lot of these guys are flying almost over those hangars.
Yep.
By the way, the drone shots have been fantastic.
I love them. Absolutely love them.
It's really spectacular to get the aerial view.
That's my cameraman, Jerry Pike, on the drones.
Good
Shout
on
out
him.
to Jerry. He's doing a great job.
He had that mean NSF Hawaiian shirt on.
He did.
That's a very nice shirt.
Yeah. UMass renaming their plane to the JB Welded. Didn't have a lot of luck on the earlier attempts, but this looking
You were
good.
out here for the first one?
Yeah.
And what happened?
A roll.
Yeah.
Rapid unplanned landing.
Yeah.
All right.
Do you remember what the first name was?
I do. The Minute Plane.
Oh, of course, Minute Plane.
Yep.
Which is about how long JB Weld takes to set, right?
Yeah, I think
Excellent.
so, actually. We got to buy the Minute stuff.
Oh, yeah, that's excellent.
They've been eating Minute Rice and drinking Minute Maid.
Yeah, absolutely.
Yep.
Absolutely.
UMass battling that wind there. But, I do believe the tail gears did come off there.
Okay. Who needs a tail wheel anyway, sir?
Yeah, you don't need that.
We're just shedding nose wheels and tail wheels as long as the mains are fine.
It's like staging on a rocket.
Yeah, exactly. Oh, this is second stage. Yes, I see.
Yep.
Oh, this is the pilot for Notre Dame. He's got the South Bend shirt on. So they had a guest pilot in here on this one.
Yep.
Which is probably a safer thing to get somebody who's already flown in this difficult air today.
Absolutely. Okay.
You know, sorry, please.
As UMass comes off the runway, Chris, who do we have next?
Up now we have Team 55 coming from the Old Dominion University, flying their plane, the Blue Heron. This is mission number 3, and they're going to attempt to load a 175-inch banner. And they've asked me to give a shout out to their faculty advisor, Drew Landman. He's done what no man can do.
All right.
All right, so we have a small vertical stabilizer, but very large winglets.
Yeah, I was going to say.
And I've tried to think what the choice was there. I wonder if they just wanted a little bit more lift efficiency against the 5-foot wingspan constraints.
Yeah.
But I'm surprised with all that lateral area close to the CG that they don't need to make a larger vertical stabilizer.
Yeah, you generally want your stabilizers to be further away from center of gravity, right?
Typically, which is why for swept wing flying wings, those wingtip vertical stabilizers work great.
Yep, absolutely. Good job, guys.
Yeah. So located in Norfolk, Virginia, Old Dominion University, known as the Monarchs.
Yep. They got the blue heron. Let's see what we got.
A lot of blue heron down there in that Tidewater region of Virginia.
Oh yeah.
Yeah.
Okay, this is a banner flight, Mission 3.
It doesn't seem to have any directional stability issues, so maybe I'm wrong.
Yeah.
Yeah, very, very pronounced winglets there. I mean, those super big.
This is the answer to the question, how much winglet do you want? Yes.
Yeah, I need all of it, please.
Turn it up to 11.
up to 11, sir.
These winglets go to 11.
Oh, so look, this is, they're struggling with the banner deployment.
Oh no.
And Clay, if it deploys on the upwind turn, I don't know what I'm going to say to you, sir.
We'll see. Yeah, it's still wrapped.
Yeah, it looks like aerodynamics are holding that banner tightly knit.
Did it wrap around?
Up.
It didn't.
Uh-oh. Yep.
No,
good choice by the pilot.
Yeah. Instead of dragging it down.
Yep.
Just released.
I thought Captain always goes down with the ship. Am I wrong?
Captain doesn't go down with a banner.
Banner. I'm sorry. Yeah.
Unless you're Bruce.
That's right.
Yep. Yeah, the plane isn't green though.
It's a pretty plane. I like this design actually. It's interesting.
Yeah.
We have had a lot of smash today, haven't we?
Yeah, we have quite a few issues today. And we talk a lot about resilience at this competition, and it's a huge thing in real life as well, right? When you're working on programs, particularly in the aerospace industry, being able to come back, these days fail forward is more of a mantra than it used to be. It used to be that failure was not an option.
I think they broke one of their frangibles. I think that's okay.
Yeah. But the nose gear is still in place.
Yep. Yeah, I mean, failure happens in the aerospace industry. That's the thing. You gotta learn by it.
The resilience against conditions, whether it's wind or turbulence or something, or against a failed mission, and then rebuilding at 3 a.m. or whatever it is.
Yep.
I feel sorry for all the hotel carpets that have epoxy stains everywhere, right? But still, it's remarkable to see what looks like a complete de-kitting or re-kitting of an aircraft, and then it's back the next day somehow.
Yeah, it's been incredible to watch.
Okay, Old Dominion coming out the runway after not too good of a flight. They're not going to be happy about that one. Chris, who do we got coming next?
We have. Sorry about that.
Oh, no problem.
We have Team 58 coming out next from Columbia University, flying their plane Mallard. It's very windy out here, and they're in. This is their third attempt at Mission 1.
Okay. Mallard.
Do you remember any of the previous attempts for Mission 1 for this university? What happened?
Wind got them.
Yeah.
Wind got them. I'm not sure if it's the T-tail on their design. It looks like their main wing is slightly dihedral there, if I'm looking at that right.
Yeah, it looks like a pretty high angle of incidence too, from my perspective. The nose gear is pretty far forward.
Yeah.
It's forward to the leading edge.
Yep. And then, like I said, a T-tail with this design. So we were learning about that from you a little bit earlier.
Right.
It's going to be a nice clean air.
Should be clean air, unless the angle of attack is too high.
Yep.
But the nice thing is, because it has a high angle of incidence, then the whole fuselage won't get to a very high angle of attack, right? And so you shouldn't have any of the wake of the wing impinging on the tail, I suspect. I can't visualize aerodynamics just by looking at it, right? But it does present challenges, because now you have to have that vertical stabilizer be able to support all the additional weight of the horizontal on top.
Yep.
And the servos and everything else.
Yep. Got to build a lot more structure there.
Mm-hmm.
Okay, plane's armed. Let's see what we got.
It looks like they made a choice of a composite fuselage, but a built-up balsa wing.
Yep. Once again, this is Columbia University. Attempt at Mission 1 with their Mallard airplane. The wind.
Crosswind got him.
Crosswind got him. You think it was that same correction? He actually got airborne.
Actually, he got airborne. I think it might have been a little bit different on that one. Power up was actually kind of slow.
It was slow, and to me, the only thing
he needed more acceleration on takeoff.
More power, put the nose down.
Yep.
But that's our quarterbacking here, right?
Yep.
I don't think he had enough force to overcome that crosswind.
Yep, and then I'm sure he was opposite aileron, but if you're slow, then ineffective control surfaces compared to that wind.
Okay.
Landing gear has been severely abused today.
Yeah. All right, we got Columbia recovering their plane. Chris is back from the staging pits. Who do we got next?
Up now is Team 60 from the Hong Kong Polytech University with their plane SLDPK.
Didn't we see Blue Heron fly already?
Yeah, we did.
Mission 3, and they're going to launch a banner
Beautiful.
of 240
Mission 3 will be done one way or the other.
Beautiful heron flying over.
Absolutely.
Yeah.
I had a couple of shots of a heron and one of our DBF airplanes together.
Yeah. Great Blue Heron just flew across the field. Kind of prophetic after we watched Blue Heron fly.
Oh, yeah.
Was it the soul of the Blue Heron leaving?
I think
might have been, yeah.
Okay, so
maybe he came here to watch, and then
maybe
after that flight, he was just ready to go home.
His namesake is like, well, it wasn't what I wanted.
Yeah.
I will point out that the gentleman here preparing to launch the aircraft has a whole bunch of rolls of tape, and I just love that preparedness.
Yeah.
What do you need? All the things. There's a toolkit, tape. My team suffered an incident where they came here and they needed a screwdriver. Didn't have a screwdriver, had to forfeit a flight.
Oh.
And it's all about, are you prepared? Are you ready to go?
There you go.
Boy Scouts of America, be prepared.
That's right.
That's right. So, once again, this is Hong Kong Polytechnic University with SLDPK. This is their third. They're going to fly Mission 3 today. Third flight, Mission 3. They're deploying a 240-inch banner, which is on the higher side of the banners that we've seen today.
240-inch.
That's big.
So, I mean, the banner looks stuffed underneath the aircraft, which is how I like to stuff my carry-on and my check luggage, right? Just to the max.
Yep.
Kind of like the rolled-up sleeping bag underneath.
A little bit, yeah. Oh, it's a day tripping airplane. I see, yeah.
Okay.
240 inches?
Yeah, 240.
That's massive.
That's not the biggest we've seen. I think the biggest we've seen is 249. But that one's definitely one of the larger ones. Okay, here we go.
There we go. Good takeoff.
Yeah, a lot of power.
I was wondering if the banner extends too far, does it prevent rotation? But it was fine.
Go with the deploy.
Okay, once again.
Oh, come on, unfurl.
It makes me really think towards actual banner tool operations, why they always have it laying on the ground and then they come pick it up, I suppose for this exact reason.
Oh,
very
there
nice.
you go, look at that. That was
nice.
dramatic. I love that. Same thing. See, you turned upwind.
I've got nothing to say, sir.
I'm just saying.
All of my constant airspeed arguments are falling to you, sir.
Don't argue with the professor. That's what I'm learning right now. But I can see it.
No, you're not wrong. That is an excellent
That is
banner.
some banner. Let me tell you what. It's not only is it long, it is big, it's wide.
Yep.
And making pretty good headway upstream.
Yeah. And I have a lot of respect for how stable that banner is. They really did a good job where attachment points, how they weighted it, it just presents really nicely.
Do you think material is in the design of the banner? Like what material are you using?
I don't know. I mean, nylon seems like an obvious choice, or mylar, but I don't know. I'm not sure. Obviously, the banners that they have for the beach runs or whatever are a lot more stable than these. But this is really nice. It's even rolling with the aircraft.
It seems like it has less flutter somehow.
Yeah.
I just wonder if it's a lighter material.
Yeah, maybe. Or if it's the heavier material that's better because it has more inertia.
Maybe. But they seem to be doing better upwind than some of the other teams that are really struggling now. That could be a power management thing too. I don't know.
Yeah.
Now they're starting to get into that headwind. The ground speed's going down.
And I'm not hearing the motor very high like we did for the other team.
Yeah.
Plane seems real stable though.
I just love the phase lag between the airplane making a maneuver and the banner subsequently following. It's rolling with it very nicely.
Now this is the second plane we've seen that has the the red right and the green on the left.
Yeah.
Right? Which is interesting to me.
And you know, it's
Like
funny.
boating.
Exactly. Which is the navigation lights on the aircraft, same thing.
Yeah.
Yep.
But there's a lot to say for making it extremely visually obvious as the airplane gets small, and you just I need to know what the orientation is.
Visual orientation. That's exactly right for the RC pilot.
Right. All right. So now the question is when is he going to decide to release?
Going for another lap.
Yep.
Extremely well made banner. It's very nice.
Yeah, this is some good flying here.
Yeah.
I don't want to jinx anything, but I got my fingers crossed.
I commentated Chris a couple of teams today, and I felt really bad.
Look at that speed.
Yeah.
You're right. It just goes right through that corner, no problem.
Yeah. That's the most control I think I've seen in the turn.
Yeah. And it's hanging maybe one wingspan low, or barely.
Yeah. Now this may contradict our discussion earlier because it seems like it's a little bit far on the leash and low.
Right.
I don't know how they.
But if you think of what is the size of the wake from whatever it is, a 5-foot wingspan airplane, and what is that, 20 feet or more?
Yeah.
So if it's 20 feet approximately, right there, it's
at least
nice. It's just small in comparison. Beautiful.
See, did you hear it coming down?
Yeah,
That's
right.
lightweight.
Yeah.
No, I hear you.
Absolutely lightweight.
Yeah.
More like a cellophane almost.
Right.
Maybe you're right. Maybe the heavier material is worse.
Well, certainly for speed, I think they had more aggressive speed heading upwind.
Okay, coming in for an approach here.
This was a solid flight here.
Yeah.
Yeah. Excellent
Hong Kong
job.
Polytechnic. Gonna be really happy with this one.
It's on autopilot.
Come on.
Beauty. Look at that.
Absolute beauty.
Right. That was a perfect landing.
Real nice. That was, I'd say, one of the cleanest banner runs we've seen.
It's a very nice one.
Little fancy taxiway.
Yep.
Yeah.
The pilot has a GoPro on the bill of his cap too. I kind of
Nice.
like that.
Yep.
Right? So go and track the flight on his own.
Absolutely.
I haven't seen anybody with the Google Glass here, or the Ray-Bans with the Meta Ray-Bans. Could be a thing.
Those are so nice. Look at that.
Yeah.
You're right.
The noise it's making.
It's quite lightweight. I think they really figured out on the design side how to have a lightweight banner that was gave them a lot more control in the turns. Yeah.
Almost sounds like tinfoil.
Yeah.
Huh. All right. So lightweight seems to be the key there. All right. So that was Hong Kong Polytechnic University with their third mission. Chris, who do we got next?
Up next is Team 59, coming from the University of South Alabama, flying their plane Jag Air. This is their second attempt at Mission 2, and they're flying with 15 ducks and 2 pucks.
15 and 2.
You want to feel it as it goes by?
Oh my goodness. Right? That is good work for him. Yeah. Probably go over there and ask him, what is that?
We have a nice red, white, and blue design on this one.
I like this one.
Yeah, again, a little bit of a see-through.
Yeah.
Wonder if they're helping celebrate the semi-quincentennial.
Possibly, yeah. Very nice. This is Mission 2 again, right?
Yep. That is the same problem that they had before.
Was it really?
They took off. The plane had some pitching oscillations. I don't know if that was pilot induced or if it's the wind or what.
It's funny, laden airplanes are hard to fly sometimes.
Yeah.
Which is the argument folks make against RC airplanes. RC airplanes are lightly loaded typically. They fly great because they don't have to carry anything useful.
Yep.
The moment you laden an aircraft with payload or instrumentation or sensors, now it's harder to fly and you can't get as much range.
Yep. Can never have your cake and eat it too.
I would like to.
Yeah, right.
But that's the beautiful thing about the Mission 1. It's just a remote control airplane.
Yep.
Fly it, just
have some fun.
Prove that it can fly, and now let's do something useful in Missions 2 and 3.
So for the folks at home, this is a cargo mission for the University of Southern Alabama. They have 15 ducks, 2 pucks here. Cargo missions, basically where you load down the plane with your ducks and pucks, and you fly as many laps as you can in 5 minutes around the track.
You know, Clay, I'll agree with you that having a clear monocode is beautiful. You put so much work into the structure. Show it off a little bit. Yeah.
Yep, looks great.
AJ, do you remember how early the first flight attempt ended? When they
it was
quick?
right at takeoff.
Yeah.
Plane went up, came back down, went up, came back down, went right into the ground.
So
that's not happening here.
They're doing a great job.
Yep, they are.
So South Alabama is located in Mobile.
Yep.
And they are the Jaguars.
Yep. And that's the namesake for the plane, Jaguar.
Jaguar, okay.
I got it.
I thought it was a Marine thing.
Oh. Judge Advocate General.
Hey, that was a good show, man, all right?
As I've mentioned before, Mobile is quite an aerospace center as well.
Yeah. Really?
Yes, big Airbus facilities down in that part, and a number of suppliers are based in the greater Mobile area. Alabama always brings a huge delegation. Whenever I go to air shows, you see the Alabama folks there in force, trying to attract industry to Mobile as a great place to build aircraft and parts.
Incidentally, some of the best paint shops are there too.
Well, it's a heck of a Mardi Gras that they've thrown on there as well.
Yeah.
You know?
Also have pretty dang good museums down there. They have the USS Alabama. Fantastic museum. Coming in.
Huh.
Oh no.
Wow.
Wow.
Pilot over control, baby?
That looked very similar to when they had an attempt before.
It's so hard the stress is so high.
Oh yeah.
I've been flying for more than 20 years at DBF as a pilot, and it's challenging, right?
Yeah.
You get the wobbly knees no matter what you are.
Yeah. You feel like an experimental aircraft pilot?
Absolutely. Absolutely.
Everything you flying's got a little different feel to it.
Yep. How can you get more experimental than this? Look at that.
Oh.
It's like the Dutch roll mode is very lightly damped.
Yep.
And I wonder if actuating the rudder gives a lot of roll to yaw coupling.
Coming in smooth here.
Come on. Or just a low pass. Okay. No. He's got it.
Yeah, grass field landing.
Yeah?
Hey, all right.
All right.
Oh, works fine.
Counts.
All right, big applause.
Oh, that was Aiden.
Yep.
Have you talked to Aiden?
I have not.
An amazing dude, right? He's flown for years for a bunch of different teams. He's one of the guys that expert pilot, right? If it can fly, usually he can fly it well. And then he's just been a volunteer and has flown sometimes for 10 to 15 teams out of DBF.
There you go. All right. Cool. Well, I can hear by the chants, Chris. I think we know which team is next. Who do we got?
Up next is the team from San Diego State University, team number 61. They're flying their plane, the Hutzlin, and they'll be attempting mission number 3 with a 96-inch banner. And the team has asked me to make a special announcement, so I'm going to read this off, and I hope I can get through this. We dedicate our final flight to our chief engineer, Jonathan Kalt, who could not travel with us for this competition. You have been a great leader. We think the best there ever was. No one will compare to you how great you are. Trust us, we know. Whether we are in Liberal, Dogwood, or somewhere in between, you keep us moving forward. We thank you. We love you. See you later, cheese.
There we go.
Jonathan, good shout out.
Awesome.
All right.
All right, commentary quickly on the design. A tapered wing, a straight taper, and then no taper on either of the tail surfaces.
Yeah. But those tail surfaces are really far away from the center of gravity here.
Yeah, so it doesn't have to be very big because small area, long MoMA arm gives a decent tail volume.
Now, is that banner, is it lateral?
I think so.
Yeah.
And I'm amazed at that choice to have a transverse banner, but how it goes.
All right, here we go. It should be okay, they've opted to go through the 360-degree turn here.
Do you have to deploy after the turn, or can you do the turn?
I think it's somewhere on downwind.
Okay, somewhere downwind.
Yeah. Again, so there's some series of things that happen where it doesn't unfurl properly. That's why parachute packers have to be certified, I suppose.
Yep. And that's, that's what
he's just shaking it out now. Right?
Yeah.
There we go. Something came off.
Something came down. I think he might have lost a fastener there or something. Oh no! Oh dear.
Oh, looks like it's hung up.
Yeah, I think it's spinning now.
Yeah.
I think they're gonna make him release. They lost an attach point, I think, on that one.
Yep.
So you were talking before about the force on that.
Yeah, so the opening, the shock loads, right? Yeah. As you go in, and now you have to suddenly stop it, and plus the amount of drag. So both how much force there is and where along the fuselage you choose to have that attachment point. Just fascinating choice. I don't know what it was that fell.
I don't know. It's a shame though, because they got it deployed properly, and then it was the other attach point that made it dicey there because it was spinning.
Right.
You get to see the unladed Hutzel in here flying around. It does fly real well.
Yeah, it's a beautiful plane. All right.
Good touchdown.
Very nice.
Was SDSU having a little bit of trouble with Mission 3.
Sorry for the Aztecs there. That was unfortunate. I think they could have.
That could have been a good run.
Yeah, I think it would have been a good run. That plane was performing well.
Yep.
Okay, Chris, who do we got next?
Up next is Team 62 coming from West Virginia University, flying their plane the Golden Goose. They're attempting Mission 3 with a banner of 58.5 inches.
Okay, opting for a smaller banner here, 58.5.
Got the Mountaineers from Morgantown here.
Yep.
Fuselage built for capacity. You can see how many, I think they can hold a lot of ducks in there.
Yeah.
39.
39?
Yep. 39.
Yeah, they had 39 and 2 pucks.
All right.
But this isn't a cargo mission, this is the banner mission.
The banner mission, okay.
Yep.
Guess rows of 3?
Yeah.
Again, with you talk with the noses up a little bit.
Yeah, I had this debate with my team on. They wanted a really tall gear. Like, why? It doesn't make a lot of sense unless you have ground clearance issues or you're having payloads that are hanging underneath. Tall gear generally doesn't do very well on aircraft, right? Which is why the F4U Corsair specifically had that gull wing.
Yep. Clear the prop.
And then in crosswind conditions, it makes it even harder to control.
Okay, Golden Goose is in the air for West Virginia University.
Did you notice that matching WV socks?
Oh, that's great.
Not bad.
I love it.
Okay, should be coming up on banner deploy here. There it goes.
At least.
Oh. I'm not sure what's going on up there.
No.
Looks like they got a good deployment, but the banner didn't unfurl.
Yeah. This is the forever the challenge of trying to make sure it doesn't accidentally unfurl.
Yeah.
But then it does on command.
Oh,
looks like it's coming out slowly.
Yeah.
There we go.
Very nice.
I'm not sure if that thing still. It's hard to say.
I think it's out.
Yeah.
He said 59 inches, right?
Yep.
Yeah, which is approximately the wingspan of the aircraft. That looks right.
Yeah.
And they're making a choice of how much line to have versus how long the banner should be. It is hanging surprisingly low.
I don't know. It looks like the banner isn't. It's lengthwise it's okay, but there's like a bar at the front of the banner.
Yeah, but I don't think it's extremely wide.
Yeah.
This one is it's less surface area, I think.
Yeah.
Oh, I wonder if it rode up on it basically.
Yeah. See, that's. Oh, they deployed it. That was definitely on purpose.
Nice and conservative, right? Take some laps, bring it in.
Yep.
No, nobody took like a triangular at the front either, right? A lot of them just did this square, kind of squared off front of the banner. I wonder if a triangle design would be.
So that's what our team tried to do, a straight leading edge, right, to go down to something, just a triangle. But they won't have the opportunity to try Mission 3 at all.
Okay, Golden Goose coming in for a landing.
I think they might have worn the sneakers for this one, the Golden Goose.
Oh boy.
Slow speed.
Oh boy.
Very nice.
Hey.
All right, very nice. The concern I have with any of those landings is you don't know anything about wind shear. If you get a gust of wind or a change and you're slow ground speed, right, or slow airspeed, and the wind shifts suddenly, then you're caught in a pickle.
Yep.
So usually better to bring it in a little bit fast.
Okay, West Virginia securing the Golden Goose. Chris, you back with us? Who do we have next?
Up now, we're at Team 63, the Missouri University of Science and Technology flying their plane Pelican. They'll be attempting to launch a banner of 137.25 inches.
137.25.
We got another counter-rotating prop on this one.
This plane sounds amazing.
Fascinating.
So there's two of those in this competition now. Yeah.
I don't quite understand the appeal, but
sounds cool.
Oh, it sounds great. More thrust from a fixed disc area or disc radius. I get it, but it's so big they have to actually elevate the position of the motor.
Yep. Now,
I think it's kind of tough looking.
I like it. I see why they called it the Pelican. Right.
Who is this again?
This is the Missouri University of Science and Technology flying their Pelican.
What's their mascot? I should know. This is a part of our system. You understand?
that one I do not know, and I'm pretty good with mascots. I'll have to look it up.
You are on the game.
Yeah,
pretty good. Oh, wind getting real bad. Okay, so this is a Mission 3. This is a banner flight. Now you're saying you don't understand the contra-rotating propellers. What's the benefits of using one of those?
So the nice thing, counter-rotating propellers, first of all, you get rid of any of the torque effects.
Yep.
Right? So there's spiraling slipstream, and there's P factor, there is gyroscopic precession, and counter-rotating takes care of all of that.
Yep.
And so, in a sense, that's really nice. And maybe that's one of the reasons. But you don't get nearly as much efficiency as if you had two separate motors of the equivalent disc area. By the time you have stages like a turbine engine, but you're gonna have losses between the stages. It looks like, by the way, they had to forfeit a flight there. Something became disconnected.
Oh no! The wind started blowing the plane back.
Yeah.
Well, they are the miners, just in case you were wondering. That it used to be the School of Mines and Metallurgy until 1964.
Cool.
All right, 9 minutes left.
All right.
Oh, is this University of Sydney? The Humpback?
Yep, this is Project Humpback. We'll wait for Chris for confirmation.
It's very nice. Livery's excellent.
All right, what do we got, Chris?
So up next to Team 66 from the University of Sydney with their Project Humpback. They're going to attempt to launch a banner of 189 inches.
All right.
Sydney did well in our rocket competition last year. I think they also did very well in the paper in a paper competition with us at AIAA.
Okay, so in case we have any viewers watching down in Australia, we see you guys. You guys probably have no idea how long that banner was from what Chris just told me. It's 4.7 meters long. Pretty big banner.
Yeah.
189 inches for everybody else that's watching in the U.S.
There's something special about a team that takes the time to really dress up their aircraft.
Oh yeah.
So the fact that they actually had a humpback-shaped fuselage delights me very much.
Yep. They also do have winglets on the end of the wings, though.
Yeah, absolutely.
Yeah.
take off. Barely half throttle.
Wind's getting real nasty.
I think I like that approach with the pilot standing just behind the aircraft.
Yeah.
You could have a good line of the line looking straight across the aircraft.
You turn the wrong way. It's a great perspective. In fact, we did a lot of work at the university, RMIT and then Monash University in Australia, flying in wind tunnels, and you can fly right next to your airplane in the tunnel. It's fantastic.
Cool. There we go, banner deploy from University of Sydney.
That was interesting.
Very
interesting. Yeah.
So it looked like it caught a U shape almost.
Yeah.
Yep.
I think this may be the longest leash from plane to banner I've seen.
Yeah, so it had that shock load, right? Because it separated and then it finally hit.
Yep.
Airplane is doing fine.
It's
and
like crack the whip when you water ski.
Yeah, exactly.
There you go.
Same kind of effect. Now they have, you can see where the attach points are, and then it goes to a single point, again like a handle on a water ski,
right?
But much more elongated.
Yeah.
But it seems to be a very effective way of getting that banner in the correct position.
Mm-hmm.
You know, we've seen a lot of it wrapped up on a single bar, and that's a different kind of design.
And a lot of them have that same failure mode. Their unfurling or their lack of unfurling happens in the same way.
Because it's rolled up around the center like a spool.
Right.
In this case, it looked like it was more in a kind of a pouch kind of thing.
Right.
It was pouched up.
Right.
And then that design, though, I think is quite efficient.
Did you do model rocketry as a kid?
I did not. No.
So
I did.
They have, you know how STs always tells you to roll up the parachutes in a very, very specific way.
Yeah.
It's like, well, why? And it turns out they've done thousands and thousands of deployments and they understand how things unfurl. And part of it is, Clay, to your point, is a folding and then a rolling.
Yes.
Right? Or something like that.
Yep. Yeah.
And so to just roll something and expect it to magically unroll in the air is going to get caught somehow.
Now, I did have those little paratrooper guys, right?
Oh yeah, those ninja men or parachute ninjas.
Yeah, they were
parachute army men.
Yeah, I don't know. They were kind of a gummy guy. And But how we rolled the chute, absolutely had a big impact on whether or not it deployed or not.
Absolutely, because you've thrown them up a couple times, and then just this little ball of plastic didn't help at all. Is that what we're doing for DBF next year? Infantry deployment, right, or parachute?
Don't get us started. I think that you could be giving some good ideas to the organizing committee on that. They're always looking for new ideas.
My problem is I can't contribute because I advise one of my teams, right? So they're like, we don't want your opinions anyways. I can do flyby and photography, right? That's my limit of my contribution here.
Okay, passing the 3-minute mark there. Announcement from the observer on the team.
I think if he wanted to bring it slow, he could just bring it to a stop in ground speed.
Yeah.
Wow.
Yeah.
It's kind of
just come in vertical landing.
All right.
Yeah, VTOL it.
Yeah, absolutely.
Oh, it's kind of like a big bird just, riding the thermals.
Yep.
Right, just sitting up there.
I mean, it is interesting. The inspiration is a whale, but whatever.
Hydrodynamic, aerodynamic, different fluid.
Yeah, it's fine.
Wait, you speak whale?
I do speak whale very fluently, sir. Absolutely. Absolutely.
Yeah.
I also am just rereading The Hitchhiker's Guide to the Galaxy with the whale materializing in the air, right? So. I was tempted to practice my whale, but not for the live stream, sir.
I don't think it would be. It's you don't want to break any eardrums.
Yeah, right.
Speak a little dolphin, no whale. Clearly my Spanish is not so good. No bueno.
No bueno.
Okay, clean release.
Okay. Project
City.
Yeah.
Here we go.
Doing real good. Okay, Project Humpback coming in for a landing after a successful banner deployment.
Here's coming motor off. Look at that.
Yeah, this is what I've been telling you. I've been seeing a lot of this, and I think it's a really nice technique on the landing.
Yeah.
Motor off.
Beautiful.
And just use that headwind to slow you down. And,
absolutely.
Yeah.
Cool, cool.
Very, very nice flying.
Yeah, clearly they were paying attention to some of the other flights.
Absolutely. Because some of these guys, it looks like they're reluctant to bring back the throttle. Yeah. They're blasting down the runway, and my man, draw the throttle back and bring it in.
Okay. Chris, how many more teams do we got?
And this is going to be our last flight today. So this is team number 68 coming from Rutgers, the State University of New Jersey in New Brunswick, with their plane, the Dragonfly. And they're going to attempt mission 2 with 9 ducks and 3 pucks. Good luck, guys.
Great flight.
All right.
Well done.
Yeah. Good job, mate.
I've been told to give a gift to whoever the commentator is.
Oh, really? That's me.
Australian treats.
You give me Vegemite.
Vegemite, awesome.
Oh, treat/punishment.
I like the Vegemite.
Take it how you
I'll
want.
take a Tim Tam if you got one.
Oh, I don't have any of
All
those.
right. I learned the Tim Tam Slam when I was down in Sydney.
What is that?
Tim Tam's like a little cookie that they have down there, and the Tim Tam Slam is a little bit like us dunking an Oreo.
Oh, I got
in a glass of milk.
I got you.
Yeah, so they do the Tim Tam Slam. That's their version.
Here we go, Rutgers with their cargo flight, mission 2, last flight of the day.
What's the name of this aircraft? Because I can tell you what it looks like.
The Dragonfly.
The Dragonfly.
What does it look like?
I think it looks a little bit like the Red Baron.
Oh, a little bit, yeah. It's a little Red Baron vibes.
Now it's a biplane, not a tri. Not a tri.
Hey, well,
not a Fokker.
A budget Red Baron, right?
Budget Red Baron on a budget.
We can go with Sopwith Camel here.
Yeah, right.
I'll stop with Camel. But it's got that dramatic.
No, you're right.
My school colors are red and black. I love it together. I think it's a great livery.
But there's all sorts of rules about how, if you're doing a biplane, what the stacking height should be. If you're doing a triplane, what the stacking height should be. And the Red Baron, just awesome, the Fokker DR1, right? Just stacks so high.
Yep.
These guys took a different approach. They're within a chord length of each other.
Yep.
Very stable in the air.
Oh, very nice. Yeah. Snoopy's at the controls. This is one of the airplanes that, the biplane choice and the choice of the relative size of the nose wheel to the main wheel. Yep. Don't understand, but it just looks beautiful.
Well,
or entertaining at least.
When Rutgers did their mission 1, their first attempt, they did have a problem with that nose wheel. It did just kind of wiggle around a little bit.
That's where they lost that one, right?
Yep.
Yeah.
So once again, last flight of the day. Rutgers flying in mission 2 with cargo here.
It's fascinating to see mission 1, 2, and 3 all in the same proximity.
Yep.
Because you get the mission 3, like, oh my God, it's going to deploy. You expect something to come out of the airplane. And then mission 2 is like, oh, they're just flying. You can't see the payload.
Yep.
But the pilot, the airplane's struggling on that weight.
Yep. Oh.
Wow, look at that. It's stationary.
Yeah.
Wow.
No ground speed. Plane looks real stable.
Yeah.
Hard to see from here where the pilot throttle stick is, but it doesn't look like he's trying to use too much power.
Yep.
I was trying to advise my team on.
Have you flown a biplane?
Yes, I've flown. A guy paid me to ferry an open cockpit biplane.
Oh, man.
So a Myers OTW from 1930s. It was a lovely airplane. They're neat, but you realize how garbage the visibility is. There's a wing everywhere you look.
And that's why they switched to a mono-wing design, right?
Well, that and drag, honestly.
Yep.
The additional drag of all the interfaces is not worth it.
Yep.
We were talking a little bit earlier about test pilots, and I'm friends with a few NASA astronauts because of my line of work, and I'm always just fascinated how these guys can jump into a new, because they're test pilots.
Yeah.
Most of these guys are test pilots.
Right.
And I'm like, how is it that you can jump into a cockpit of a plane you never flew and take it up in the air?
It's remarkable.
It is really remarkable and brave, I guess. I don't know. I mean, but they know all about it right before they get in.
But there, test pilot school teaches you that, right? It's study the material, study the pilot operating handbook, and then if it flies like an airplane, understand the systems, just fly it.
There you go.
So,
and that's what Rutgers just did, completing their mission 2. And, well, gentlemen, I think we're at the end here.
A fantastic day out here on the flight line.
Yep. All that's left is, I believe, the awards ceremony.
Yeah.
So,
we can get the live stream viewers to stick with us. Stay with us for the award ceremonies coming up. Everyone's making their way back to the hangar. We're going to have see who actually won this thing, first, second, third, and we got a number of awards also as well. Stan Powell Award for most improved resilient team that's out there, and some other fun awards. So stick with us on the live stream, and let's see how this thing turned out.
All right. Well, thank you for your comments.
Yeah, thank you. I appreciate it.
That was great doing the technical. That was fantastic.
Absolutely.
All right. We still got a little bit more, but for now, we're saying so long from the flight line here at the 2026 AIAA Design, Build, and Fly competition. Still a little bit more to come.
The AIAA gave me the tools to be ready for industry. As a student, you do get exposure to design, build, fly. You're building a plane from scratch with the support of mentors. You're exposed to the problems that we need to solve at the moment. The AIAA helped me build that passion.
At General Atomics, not only do we make remotely piloted aircraft, we engineer innovation. For over 30 years, our Predator, Reaper, Gray Eagle, and Avenger aircraft have offered long endurance, flight-proven performance, and versatility. Today, we continue to develop and manufacture state-of-the-art, remotely piloted aircraft, tactical reconnaissance radars, and surveillance systems for the U.S. Department of Defense and many of its allies across the globe. Electromagnetic Systems is a world leader in applying advanced technologies to launch and recover aircraft aboard carriers, as well as transforming innovative concepts in breakthrough surveillance and electric weapons systems. Our scalable satellite platforms support defense, civil, commercial, and academic mission requirements. From underwater to space, we support the future warfighting force. Since the dawn of the atomic age, General Atomics has advanced the full spectrum of science and technology. From nuclear energy and defense to medicine and high-performance computing. Because of our people, we continue to leave a legacy of exploration and innovation. Tasked to produce the center solenoid for the International ITER experiment, General Atomics has been entrusted to develop the world's most powerful superconducting electromagnet. Perfecting nuclear fusion in this lab demonstrates the feasibility of fusion power, a potentially limitless source of clean energy. With the freedom to explore, General Atomics delivers transformational technologies for the world. Innovation made real.
So my main project this summer has been working on interceptor reliability. What we're doing is we're trying to make it so that the battery on our interceptor can be hot swapped in the field without requiring additional calibration. So this is our flight cage. This is where we do all of our testing and preliminary flights for the drones. This is our dyno. This is where we secure the drone so that when we spin up the motors, it doesn't go anywhere. All right, so I'm running our interceptor on the motor dyno. What we're doing is it spins the motors, which spins the propellers up, and then from there it collects the data of what the motor offset values are, and then it calibrates it so that our interceptor can have its optimal performance. Working at Anduril is different than working at any other company, mainly because of the autonomy I have as an intern. I feel really empowered by my mentor and my manager to kind of do what I need to do in order to get my work done that week. It's also a lot different than other companies because I can see how my work as an intern over the summer directly impacts the company as a whole.
In aerospace, losing a major contract doesn't just mean missing revenue. It can shutter an entire division. Billions in potential business, gone. Because you don't get second chances to prove your design works. Traditional advanced design forces you to choose between speed and fidelity when both are critical. NTOP changes everything. Explore hundreds of design variants with high-fidelity physics in the same time as it used to take for basic estimates. With implicit modeling, you can create robust parametric models that never break, so you can quickly generate any possible configuration of your design. And get near real-time performance calculations that enable deep trade space exploration and generate high-quality performance data at a pace aligned with project timelines. Arrive at design reviews with comprehensive trade-off analysis instead of rough approximations. Because in a world where billion-dollar contracts are won on technical credibility, low-fidelity insight isn't good enough. When you're asked tough questions, you'll have real answers backed by real data. NTOP, design with confidence.
We are scientists and engineers. We are technicians and thought leaders. Collaborative, inspiring, innovative. Advancing aerospace and defense with a bold vision for the future. We are here to connect and protect the world, powered by purpose and driven to make a difference. We believe no challenge is too great, no question too big, no answer out of reach. We believe in pushing the boundaries of known science to meet the needs of the future. We believe in the power of people, the strength of community, and the importance of freedom. With passion and purpose, we shape the next era of aerospace and defense to create possibilities for better tomorrows. Collins Aerospace, Pratt & Whitney, Raytheon. We are RTX.
Back here in the hangar, my name is Kian Manafi with the AIAA Communications team. I am here with Riley and Alberto. What school are you guys from?
We're from UTK, go Vols.
All right, we're just here while we're waiting for the scores to be tallied. We're going to be interviewing some students, asking them a couple questions about their experience at DBF. So from UTK, how far did you guys travel to get here?
It was a 14-hour drive. I think it said 13 hours, but traffic, rain, 14, 15 hours, something like that.
Oh yeah, we know about rain from this weekend. Does your plane have a name?
It does. Our plane is the Smoky Mallard. Our mascot is Smokey the dog for UTK.
Smoky Mallard, I love it. Leaning into the Ducks. How many people are on your DBF team, here and not here?
There's only 8 seniors on the UTK DBF team because it's actually a capstone project for us. So we started early last semester, each designing our own plane, was what our professor had us do, and then we came together to decide what we were going to do for the whole plane.
Awesome, awesome. How many people came on this trip to DBF with you guys?
8 people, the whole team.
The whole team, awesome. If you had to describe DBF in one word, what word would you use?
Challenging. I think Kyle, one of our team leads, put it best, challenging.
Awesome. Alberto, what would you use?
I would say definitely an experience. I would describe it as an experience. Learned a lot of things, had a lot of fun. We'd do it all over again if I could, but I'm happy it happened.
The DBF experience. It's an experience. Any shout outs to anybody back home?
I want to shout out Austin Moore.
I want to shout out Alex and Oliver. Couldn't be here without you guys.
Of course, shout out my family. I'd never be here without my father, without my grandmother.
Awesome. All right, thanks you guys.
Thank you.
Thank you so much.
All right, coming in. Who do we have here?
My name is Samir Mui.
And Max Kazi.
What school are you guys from?
Texas A&M, College Station.
All right. Does your plane have a name?
Yes, it does. Rev Force 2 Aggie Bullet.
Where does that name come from? How'd you guys come up with it?
We were Rev Force 1 last year, and this time we put the 2 on it and put Aggie Bullet.
Awesome. How long did it take you guys to get here?
8 hours.
8 hours. Awesome. And if you could describe DBF in one word, what would it be?
Progress. 2 years ago, we were 89th. Now we were almost getting up there, so yeah.
Awesome, awesome. How many people are on your greater DBF team as a whole?
We have 40 people.
How many people made the trip down?
29.
Awesome. So a good majority of the team.
A lot.
If you had to describe DBF in one word, what would it be? Oh, progress. You said that already. Any shout outs to anybody back home in College Station?
Yeah, shout out to my parents who are watching right now, as well as our advisor, Scott.
Yeah, shout out to my mom and shout out to Paul Boers.
Awesome. Thanks, guys.
Thank you.
Thank you.
All right. Who do we have here?
My name is Alejandro Santana.
Alejandro, what school are you from?
I'm from the University of Washington.
Awesome. How many people are on your greater DBF team from UW?
We've got 59 people on our team.
And how many people made the trip with you?
I lose track every day. It's like 30-something.
Awesome, awesome. If you could use one word to describe your team's DBF experience, how would it be?
Really crazy.
Crazy. Awesome. Any shout outs to anybody back home?
I want to shout out my mom, my dad, my girlfriend Marissa. I want to shout out Nimit, Barry, Ken Chen, Ryan Fidelis, Josiah Villegas, Joshua Lomelli, BK, all of Mary Moore, Gabe Mountjoy from Common Fibers, and Sarah Olson for Blue Origin. Thank you so much.
Awesome. Well, thanks so much. All right, moving on, moving on. All right, who do we have here?
Us, Notre Dame.
What are your names?
Alyssa. Cassia. Vanessa.
Awesome. How many people are on your greater DBF team?
Like 30 to 35.
And how many people made the trip with you?
14.
Okay, how long did it take you guys? South Bend's kind of a drive.
Yeah, I was trained to Chicago, then the public transportation to the airport, fly here, get the rental cars. It's a day on each end.
Yeah, absolutely. If you could use one word to describe your DBF experience, what would it be?
I'm thinking rewarding.
Oh my gosh.
Oh.
Challenging. Satisfying.
I like that. Those are 3 really great words to use. Shout out anybody from your hometown. Any shout outs?
Well, we were going to shout out some of the upperclassmen of the previous years who really got us here. So Caleb Eisenbacher, Ricky Ortiz, and Isabella Field, especially.
Todd Taylor. Especially he supports women in engineering. Yeah.
It's very true. I have to say my parents, and I have to say the parents of all the people on the team. Of course, kind of generic, but I think it's important.
Awesome, awesome. Does your plane have a name?
Duck of the Irish, or Dottie for short.
I love that. That's my favorite so far. Awesome. Well, thank you guys so much.
All right, thank you.
Yeah. Moving on, moving on. Who do we have here?
I'm Ken.
I'm Timothy.
What school are you guys coming in from?
We are from Hong Kong, the Polytechnic University.
Awesome. How long did it take you guys to get here? It's a long trip.
It's around 17 hours.
17 hours. How did you guys get your plane here? Did you?
Yeah, and we ship it with our hand carry luggage and the oversized luggage.
Awesome. Does your plane have a name?
It's a short form. SLDPK. In full form is super lightweight, duck and plug carrier.
Oh, awesome. We love an acronym name. How many people are on your guys' DBF team?
It's around 15, and in here right now, 8 people coming from US.
Okay, so about half the team came. Awesome. If you could use one word to describe your DBF experience, what would it be?
Exciting.
Awesome.
Fantastic.
You want to shout out anybody back home?
Thank you for our department, our school sponsoring us and helping us, giving me experience and chances to come over here. And I have it's just so nervous. And thank you. Thank you for our policy volunteer for us and our supervisor and also for my good members.
Awesome. Well, thank you guys for coming.
Thank you.
All right, next. All right, who do we have here? What are your names?
Alex. Benjamin.
Awesome. What university are you guys here with?
We're representing HM, University of Applied Sciences from Munich, Germany.
Awesome. How long did it take you guys to get here? How long was the trip?
It was a 9-hour flight to our connecting airport and then another, 1 hour, 2 hours, something like that.
Oh my gosh,
So,
long trip.
long trip.
Does your plane have a name?
Our plane, we didn't even have a plane. We arrived without a plane because it crashed the day we were supposed to ship it to the US a couple weeks ago. Still showed up. Bit of a walk of shame, but we're good sportsmen here.
Well, we appreciate you guys coming out. There was a lot of fun stuff to come, even without a plane. So we're so glad that you guys could make it. Even without a plane, if you could describe DBF in one word, what would it be?
I don't know. Community, sportsmanship, it's great. Everyone is so nice. Showing up without a plane should be embarrassing, but it was great. It was a great experience. We're definitely going to do this again.
Yeah, we were welcomed with open arms. Everybody was really chill, and we're like, all right, they gave us tips for the next time. It would have been our first time at all, flying here. And so it was really nice just coming even without a plane, just for experience and the community.
Awesome. And correct me if I'm wrong, but I think that you guys were helping out another team kind of rebuild their plane throughout the experience. Is that correct?
We did some help here and there, but we don't want to take credit for anything, for any work that other teams have done. That's on theirs.
Absolutely.
Yeah.
Great answer. Well, thank you guys for coming out. Do you want to shout out anybody back home?
Yeah, why don't we shout out Johannes Kirchhoff, our biggest donor from the start, and Professor Alexander Knoll that helped us right from the start from the university side. Great support.
Thank you. Yeah, the same.
Awesome. Well, thank you guys so much for coming out.
Thank you, sir.
Thank you. Awesome. And who do I have with me now? University of Maine.
I'm Jesse.
And I'm Lana.
Awesome. So how long did it take you guys to get here? University of Maine is quite a trip.
I think it was about maybe 6 hours in total flying, so it was long, but it was a good trip.
Awesome. Does your guys' plane have a name?
Barely airborne, emphasis on the bear.
Okay. I was wondering because I didn't see it written down, but I heard the name and I was like, that's an interesting one. How many people are on your guys' DBF team?
We have 8 people in total on our team, and then 9 plus our advisor.
Awesome. And how many people made the trip out here with you guys?
All 8 of us.
All 8, 100% retention. We love that. If you could describe DBF in one word, what would that word be?
I would say friendship.
Okay. What about you?
I would say community.
I love that. Those are great answers. Do you want to give any shout outs to anybody back home?
Oh, I got this one. In terms of getting here, want to shout out UMaine Student Government and the Mechanical Engineering Department at UMaine, and then also shout out to our faculty advisor for the consistent support and just everything that he's done for us, and just also our team for putting in the effort, having such a good attitude through the trials and errors, and just, it was great.
Awesome. Well, I'm so glad you guys can make it. Thank you guys for coming out.
Thank you.
Who's next? Come on in. All right, what's your name, sir?
My name is Ethan.
I'm Kyle.
What university are you guys from?
We're from the University of Missouri, Kansas City.
Awesome. Does your guys' plane have a name?
Yes, our plane is George W. Bush plane.
Okay, can you give me some background into that?
So it's a bush plane competition, but two, our professor showed us a really funny meme earlier this year about George W. Bush with the flag behind him that says success right before they actually failed something really poorly. And so we decided to name our plane after that and say, let's maybe have the exact opposite.
Awesome, that's such a great story. If you guys could use one word to describe your DBF experience, what would it be?
Exciting.
Cool. I like watching the planes fly. I like flying them. So I think it's cool.
Listen, this is my first DBF, so cool is absolutely a word that I would use as well. How many people are on your greater DBF team?
So we actually have 5. We're a very, very small team.
Awesome, and I'm assuming all 5 made the trip?
Yes, all 5 of us made the trip. It's about a 3.5-hour drive, so it wasn't too bad.
Awesome. Any shout outs to people back home?
I'd like to first give a shout out to our amazing faculty advisor and wonderful pilot, Mujahid Abdul Rahim. He is amazing. He showed us the ropes and allowed us to actually succeed far better this year than we did last year.
There's also Brian. He runs the 3D printing lab at UMKC. He helped us manufacture a lot of our parts, like laser cutting all of the balsa and plywood used for our final plane.
Awesome. And to you viewers at home, you might know that name, Mujahid Abdul Rahim. He flew the smoke plane to kick us off here at DBF on day 1, and he was also on the live stream with EJ for a couple hours earlier today.
He's right behind us, right there.
A little behind the scenes actions there. Thank you guys so much for coming out.
Of course. Thank you so much.
Awesome. Come on in. Who's next? Awesome. What's your name, sir?
I'm Blake.
Ethan.
Leah. Cameron. Lucas.
And what university are you guys here representing?
We're from Embry-Riddle Aeronautical University in Prescott, Arizona.
Awesome. How many people are on your guys' greater DBF team?
We got about 35 members, and we brought 19 of them here.
Awesome. Okay. How far was the trip from Prescott?
16 hours of driving.
16 hours of just driving.
Just driving. We got a few people to fly, but most of us drove out here over that 16 hours.
Those of you who drove nonstop?
Yeah, nonstop.
So no Bucky stops?
No, but dinner and gas, pretty much. That was it.
Awesome, awesome. If you could use one word to describe your DBF experience, what would it be?
I'd say community.
It's an experience.
Exhilarating. You got so many highs and lows of this. Like, it's crazy. It's an adventure.
Just friendship and meeting new people. Stressful.
All right, the whole breadth of emotions there. Do you want to shout out anybody back home?
Yeah, let's do our 2 club advisors, Johan Dorfling and Joseph Smith.
Let's do our project manager and chief engineer. They're both Jacobs, so shout out both Jacobs.
We're also going to shout out our visual observer and our 2 pilots, which we have our visual observer and one of our pilots are here. So
we'll shout out Noel and the rest of our testing team for getting a plane that works and getting everything set up and ready for this year.
And then I'll be shouting out John Ward, who's our other pilot. He's unfortunately unavailable, but he did a great job as well.
Last question. Does your plane have a name?
Yes, it is Hail Mary.
Hail Mary. Topical Project Hail Mary coming out soon.
Yeah, very nice, yeah. We had a nice crash on Sunday afternoon last week, and we built that plane in a few days and decided to call it Hail Mary because it's our Hail Mary.
Awesome. Well, thank you guys so much for coming out and bringing Hail Mary to showcase with us.
Yeah, thank you.
Thank you, guys. All right, come on in, come on in.
Oh, hello.
Who do I have here with me?
Nathan from UNSW. Andrew.
Dave from UNSW.
Andrew from UNSW.
UNSW, what school is that?
So we're a school from Australia.
Okay.
We're particularly from Sydney. And yeah, that's about it.
So UNSW is University of New South Wales, if I'm not mistaken,
yes,
correct?
It is in New South Wales.
Awesome.
It was a long flight here. We went through Dallas. About, how many hours delay was it?
Oh, it took us like 24 hours to get here.
It took so long with all the delays, but thankfully we're here. We thoroughly enjoyed our time here also. Thank you very much for hosting.
Well, now that you're here, what is one word that you would all use to describe your DBF experience?
Particularly, it was challenging, but it was, well, I can't do 2 words now, can I?
Challenging, we'll end it there.
Challenging.
That's very insightful.
Ooh, I like that. That's a new one.
Let's go with electric.
Electric, I like that.
Rewarding.
Rewarding. Oh, these great answers. Y'all are cooking, all 4 of you. What does your plane have a name?
Yes, it does. It's Tomater.
Tomater. Oh my gosh! Shout out the Cars fans in the stream here. How many people are on your greater DBF team?
So we have around 30 members working on the plane. We want to thank our team also, obviously, ones that couldn't make it to the US, but your work is meaningful and we appreciate your work.
Speaking of, how many of your team members did make the trip with you?
So we have eight of us over here.
Okay, awesome. Do you want to give any other shout outs to anybody besides your team back home?
Yep, so we'd like to thank our school, particularly School of Mechanical Engineering in USW. We'd like to thank for funding us, for being able to sponsor our trip. And also ARC from USW, and thank you to our sponsors also.
Awesome. Any other shout outs?
Thank you to our supervisor, Sonia.
I'd like to thank my family, bro. You guys are the best. Supporting me through these late nights, it's crazy. Thank you. Yeah, I think just everyone who supported me, like my team, the school, my family. Yeah.
Awesome. Well, thank you guys so much for coming out. We appreciate it.
We also appreciate it. Thank you also for AIAA for hosting this, and thank you to Textron for also being able to sponsor this.
Awesome. Well, we appreciate you guys so much.
All right, thank you. Thank you so much.
We got one more coming? We got another team's coming in? Come on in. Come on in. Don't be shy. All right. Well, who do I have here?
Design Build Fly at UCLA.
What's your name?
Kelsey.
Sohan.
Peter.
Daniel.
Awesome. And UCLA, that's a shout out to the UCLA team. Represent. That's right. Loud and proud, baby. Oh, yeah. Does your plane have a name?
Its name is Goose.
Can I get some background? I need more.
Its full legal name is Duck Duck Goose.
Full legal name. Okay. And that's been like filed with your local government and everything, I'm sure.
Yeah.
Yeah, absolutely. How many people are on your DBF team?
We brought 34 to comp. We have even more at home. Yeah.
All right. If you could use one word to describe your DBF experience, what would it be?
Chaotic.
I gotta say sensational. I'd say challenging. Rewarding.
All right. I think we're sensing a trend. A lot of different emotions across these teams here. You want to shout out anybody back home?
Thank you to all of our alumni and my parents.
I'm also gonna shout out my parents and my brother.
Yeah, definitely my parents, my uncle, my grandmother. They're all watching. My cousins, my aunts.
Yeah, shout out my family at home who are watching.
Yeah.
Awesome. UCLA, family-friendly team. Woo! All right. Thank you guys so much for coming out.
Thank you.
Yeah. Come on in, next team. Awesome. Who do I have with me? What's your name?
Sarita.
William.
Ryan.
Min.
And what school are you guys representing here today?
We are the Ohio State University.
OH.
IO.
Awesome. And does your plane have a name?
Yes, we are here with Catfish 2. Catfish being, we were supposed to be here with Atlas. On the back here. But we are here with our foam board version of Catfish 2.
Awesome. And how many people are on your total DBF team?
We are traveling with 15.
Okay, and how many people are back home on your team?
Oh, much more. Probably upwards of 30, 35.
Awesome. If you could use one word to describe your experience at DBF, what would it be?
You want to say a word?
Anyone?
Anyone?
Bueller?
Amazing.
Amazing. We'll take it. We will take it. Do you want to shout out anybody back home?
Yeah. Our whole entire team back home. Hello. Great work, guys. We made it to comp. Yeah. Foam board plane in 2 days. Flying.
Let's go. Yeah. Made it work. And our advisor, Dr. Ritchie, Brian Ritchie, our best friend.
Anybody who couldn't make it, but they helped put that foam board together deserves a lot of credit.
Absolutely. Well, thank you guys so much for coming out. We really appreciate it. Awesome.
Thank you.
Thank you. Awesome. Come on in. Who's next?
Hello.
Hello, hello. Who do I have here with me? What's your name?
My name is Pablo.
Daniela.
Sophia. Valentina.
And what school are you guys here representing?
We're from the University of Antioquia from Colombia. Our team name is Icarus.
Awesome. And so that's your plane name, correct? Or your team name?
Oh, no, that's our team name. Our airplane's name is Scorpion.
Oh, awesome. Any background behind that, why you guys chose that name?
Well, actually, we have a swept forward and a T-tail. So in the end, it looks like a scorpion. It's like the clams and the tail of the scorpion. That's why we went with that name.
So interesting. It's a great, awesome design choice there. How long did it take you guys to get here? It's like quite a trip from all the way from Colombia.
Yeah, we came from Colombia last the 10th of April the 10th, and it's been a long preparing the airplane, testing it here in the U.S. You know, the density is different. We had a different performance, so we came here with this time to get our airplane ready for the competition, and we're so happy to be here today to represent our country, our region, and our university in the end.
Awesome. How many people are part of your whole DBF team?
Well, right now here we're 12, but in total we're 22. We want to send greetings and we want to say hello to them. We're pretty sure they're watching the stream. So thank you guys for all the work that you did with us, and that's thanks to you. We're also here today.
He stole my next question. Any other shout outs that you guys want to give?
Sorry, come again?
Any other shout outs that you want to give to people back home?
Yeah, to our families, of course. Their families, they're also watching the stream. They will always like paying attention to every detail of our competition, of our flight. So we want to also say thanks to them.
Awesome. Any other shout outs?
For my family or for my team?
Anybody that you want, yeah.
For my team? Hi, for my team. And for my family, for my mother, my father, my brother.
Awesome. Anybody else you want to shout out?
¿A quién le mandas saludos? Sí. My mom, my dad, and my team.
Anybody else?
Yes, my family, all my friends, and our team, of course.
Awesome. Well, thank you guys so much for coming out. Long trip, a lot of preparation going in. You guys came 4 days early before comp. Love to see it. Thank you guys so much.
Thank you very much. Thank you.
All right, who's next? Who do I have with me? What's your name?
I'm Julia.
And I'm Misha.
What school are you guys from?
We're from WashU, Washington University in St. Louis.
Awesome. How long did it take you guys to get here? A long trip?
Yeah, we drove 7 hours.
7 hours straight, right?
7 hours straight.
No stopping, no Buc-ee's runs, no nothing?
We did a Kava run. We're from the East Coast, so we had to.
Also an East Coaster, Kava is elite.
Yeah.
Does your plane have a name?
Our plane does have a name. Go
It's
ahead.
Psyduck.
But we had to rebuild, so now we're in its second evolution, which is named Gold Duck.
Pokemon fans in the chat, hit us up. How many people are on your DBF team?
At competition, I think we have 19, and in our team with like all members, probably like 50.
Yeah, 50, 60.
Anybody you want to shout out back home?
Yeah, I mean, the great faculty at WashU have always supported us. The rest of our team, who has been working so hard because we had to rebuild all overnight, whole new plane in 20 hours is insane. And our friends and family have just been so supportive.
Yeah, just thank you to our leadership team and everyone who's put in work above and beyond to make sure we could fly again on the last day, even when we crashed.
Last question. If you could use one word to describe DBF, what would it be? You look ready. You've been thinking about this.
Electric.
I was going to do 2 words. I was going to say limitless learning.
Limitless. Okay, we can hyphenate it. That's one word. We'll hyphenate that. Awesome. Thank you guys so much for coming out.
All right.
Yeah, this
All right, nice meeting you.
Who's next? Come on in. Don't be shy. How's it going? All right, who do we have with me? What's your name, sir?
Mark Laser.
I'm Susanna Perovich.
Madison Kaufman.
Melissa Adrian.
And what school are you guys here representing?
University of Akron.
University of Akron, Ohio, OH. Does your plane have a name?
Yes, she knows.
It is the Rue Express.
Okay, give me some background. What does the Rue Express mean?
It's actually a bus system that we have in Akron, and we thought it was perfect.
Awesome. That's very, very fitting considering, you guys are kind of like the ducks on the Rue Express back home. Yeah. How long was your trip down here from Akron?
14 hours.
14 hours, nonstop?
Yeah, we drove nonstop. We stopped at Buc-ee's in Ohio, though.
Our first Buc-ee's run.
Yes.
Note it, you heard it here first. How many people are on your guys' DBF team?
Oh, 23.
Yep, we have 23
or more.
at competition, a few more back at home, but probably about 27 max, maybe. Biggest year yet.
Awesome. Leads me into my next question. Any shout outs to people back home?
Oh, all my family.
Awesome.
I want to shout out to my mom and dad.
Yeah, all my family and friends, and I feel like our pilot, he's not back home, but wouldn't be here without him, so.
Yes, I would like to give a shout out to my mom, my little brother Liam, and my stepdad.
Awesome. Well, thank you guys so much for coming out. We really appreciate it. Love it. Thank you.
Thank you. Thank you.
Keep coming. Who's next? Hello. All right, who do I have here? What's your name, sir?
My name's Ryan. I'm Lucas. And I'm Ruben.
What school are you guys here with?
We're from the University of Sydney and we're here for Project Comeback.
Awesome. Project Comeback, what does that mean?
Well, basically when we were building the plane, it looked suspiciously like a whale. So we put whale decals all over the side and then obviously that became the name of the plane.
That is brilliant and I love it. Okay, if you could describe your DBF experience in one word, what would it be?
Amazing.
Exhilarating. Very stressful.
Again, long list of emotions going on here. How many people are on your guys' team?
So in the engineering team, we have about, is it 40 or 50?
Yeah. And we have 13 who came with us here to America.
Awesome. How long was the trip?
I think it was 16 hours plus another 2 hours for a stopover flight as well.
Okay, wow. All right, long trip.
Yeah.
Your plane does have a name, Project Comeback, correct? Any shout outs to anybody back home?
Oh, we'd love to give a shout out to Casey, Jeremy, Randall, Steve, our pilot who just flew for us today,
And Jimmy, our original pilot for today.
Awesome. Well, thank you guys so much. We really appreciate you guys coming out. Hope you guys had a good time.
Thank you so much.
Awesome.
Have a good
Thank
day.
you. Okay. All right, we're running low on time. Results are almost ready, so we're just going to do shout-outs. Shout-outs.
I like to shout out my parents and my brothers back home.
I'd like to shout out my mom, who's carrying me all this way to the University of Michigan, Natty Champs.
Shout out to my mom as well. Also, shout out Dusty May.
Shout out to my family and shout out to Yaxel Lendenborg.
All right, we're moving through.
154 ducks, by the way.
154. All right, next lightning round. Lightning round. Let's go. Shout-outs. Shout-outs. Here we go. Shout-outs.
My family.
Andre Leppert. Dr. Dorfling.
Wesley King.
BJ Uchima.
All right. Well, thank you guys so much for tuning in. We're going to send you back for the award ceremony. Up.
Selfie time.
Hold up, squat. 1, 2, 3. Beautiful. Thanks,
They issue guys back there.
Are you going to get up here too?
You want me to?
It's up to you.
Okay.
I don't want to make you stand up there.
I'm not going to speak very long. If you're going to stay, are you going to stay? You going to speak from up there?
Yeah, I was good.
I'm just going to introduce the OC, and then hand the microphone to you. Okay. So I'm going to just a couple of remarks. I'm going to introduce the OC.
We're live.
Right. Oh, okay.
Do they have the top 10 list for me yet? Or no?
They're still printing the top 10 list.
Well, I got yeah. All right. Well,
I can stop. I'll try to stop. Okay, I'll start. So we're going to do the two awards first.
Get going.
Howdy, everyone. That's what I wanted to hear. So, had a slow start on Friday with the weather. It's kind of out of our control. But we asked you yesterday and today to be expedient and help us get as many flights as possible. We did a lot on our side to make that happen, and you guys were great at making it happen too. So thank you very much. Give yourself an applause for that. The teamwork and the camaraderie this year has been as high as ever, and that is just another good thing. We love seeing that. But from the organizing committee, I'll introduce in a minute, our biggest thing is to make sure you take away learning experiences from this. So give me a shout out if you had a good learning experience this weekend. Perfect. So now I'm going to just take a few minutes to introduce all of ourselves here, because there's some guys you don't ever see behind the scenes all year, but we put a lot of work into this because we love it. But I want to first start off with, we have a few of our original organizing committee founders and the DBF founders here today, and I want to introduce them. First is Greg Page. He's right here with his hand raised. Then we have Brian Richardet. And Chris Bove, who is still on the committee and your flight line director. And then the rest of us that make this happen. Taylor Fazzini. Weedy Cutshaw, she had to leave early, but she was helping out in tech most of the weekend. We have Kyle Benson. And John Cutshaw. Chase Ashton, who's running over here back in the corner. Kelly Laughlin. Phil Butler, who does all your scoring inputs for you and manages that. Matt Angelo, who takes care of all your proposals and reports. And then Ed Feltrop, who makes it happen here at Textron. He's running around like a chicken with his head cut off, as they say, all week making this happen. So thank you, Ed. And my name is Russ Altoff. I'm the director of the committee, and we really thank it. And we always have a couple of folks here that aren't. Did I miss Chase? I mean, Rob, I'm sorry. I did. And Rob Rhodes. who organizes all the tech inspection staff and make sure that goes as smoothly as possible. And we think it actually did a little bit better this year compared to past. You may not think so, but we did. So thank you for helping. And we always have a few folks that are here just about every year. Where is Larry? Raise your hand, Larry. Eddie, right there. And a team of very young DBF alumni tech inspectors that just follow us around everywhere. So thank them very much too. Just a couple of stats to throw out there. On Friday, we had 20 flight attempts. By the end of the day, we had 197 flight attempts. So that just tells you how well you guys did. And of those 197, 143 were actual scoring flight attempts. So that was great, guys. You deserve a hand for yourself now. Now I'd like to introduce Clay Mowry. He's the CEO of the American Institute of Aeronautics and Astronautics, and he's going to say a few words for you.
Thank you very much, Russ. Did you guys have fun today? You learned something? All right, you coming back? Yeah? All right. All right. Look, an event like this would not happen without the support of our corporate sponsors. And Textron Aviation has been fantastic here to host us. You know, they own Cessna and Beechcraft here, and so please give it up for our sponsor, our main host. Our other big sponsor is RTX. They host us when we're out in Tucson. Give it up for RTX. Our gold sponsors that were here, and maybe you met some of these folks from Anduril, General Atomics, MathWorks, and Reliable Robotics. Thank you, guys. And then our bronze sponsors, AV Inc., Divergent, Fiberglass, and NTOP. Thank you as well. Look, this entire organizing committee has been doing this 30 years, before you were born, right? Before you were born. So they did an amazing job. The stories I heard from 30 years ago when they had 12 teams, just 12, and 9 of them actually flew out on this little island in the Chesapeake Bay in Maryland, and look at how far we've come. But we're still given the same Salisbury Pewter awards that we were from 30 years ago. So when you get that, the teams that win that award know that that's a 30-year tradition that they've carried on from the very beginning of this competition. Let me just thank a couple other people. You know, NASA Spaceflight was doing our live stream. EJ and the teams, thank you guys for doing an amazing job. I think you're coming back next year, EJ. I think you're coming back, yeah? All right. It was our first time doing the live stream, and so we didn't know quite how it was going to go, but we had a lot of fun out there. We had fun interviewing you guys here in the hangar. I think it brought a lot of texture and depth to the competition this year. And by the way, you know what? Secret, if you listen to the live stream, you can hear us commentating on some trends, some wind direction, some flight tricks for the pilots. So pay attention next year. I think it actually could help some of your flights. Look, River City Visuals did our photography this week. Thank you guys at River City. And you know, I have a staff of 75 people back in Reston, Virginia, but I brought a whole bunch of them here with me, and they make this event run fluidly and all this other stuff besides the actual work, the organizing committee. We're doing all that behind the scenes stuff to make all of this visually pleasing for you guys. All the swag that we brought here, all the things around the flights that we were showing and all the photography. So I'm just going to read off their names, and if you want to hold your applause to the end, we have Angelo, Mary, Alex, Carla, Chris, Jessica, Rebecca, Kian, another Chris, and, who was out on the flight line with us, Chris Wharton, Paul reporting from Aerospace America, and you know what? It wouldn't happen without Meredith. Woo! And let me just say, you know, I'm 18 months in the job here, but my constant theme is trying to re-engage the next generation of aerospace professionals. Psst, that's you guys, all right? You're the next generation of aerospace professionals. This is not just an adventure for college. It's not presenting your first paper with AIAA. It's not your first DBF. We want you as part of this organization, like these guys, through the course of your career. We want you to come back. We want you to be on a technical committee. We want you to chair a committee. We want you to be part of one of our volunteer programs. We want you to be a judge. So hopefully you will stay with us. So please try to keep your membership up. If you're a graduating senior, we would love to see you back and be a part of your career. It's about learning. That's what we're about. So please do that. A few other things here. This week was a story, I think, of both resilience, and I use that word a lot in my commentary, and sportsmanship. And really it shows through in everything that you did during the course of this week. Resilience, because we had a lot of teams that crashed. We had a lot, design, build, crash was I think the theme of the week, unfortunately. But really it's about learning from that crash, coming back, rebuilding your plane. Just a few stories. I think Ohio State University rebuilt a plane in 2 days. University of Maine rebuilt a plane overnight. I think 13 teams assisted the University of Maine, and they wrote the names on the plane. How cool is that? Congrats. Yeah, a lot of other teams had rapid, what is it? Rapid unplanned landings. So rules, we're calling them rules. They had rules failures. So congratulations to all you guys that were able to rebuild your plane, to fly again, to get back out on that flight line. That's what this is about. All the stories of help and assistance and of the camaraderie between the teams and meeting teams from all around the world. Thank you guys for coming here. So look, I'm gonna pass the microphone right now to Rob Rhodes. He's gonna do the first awards. Rob, you gonna help us out here? All right, here we go. Rob Rhodes, ladies and gentlemen.
Thanks, Clay. So we started a tradition. We're probably in our 5th or 6th year now at this point, but to memorialize Stan Powell. He was one of the original guys that helped out getting DBF going. And for those of us old timers like me, he was the guy that you kind of had to deal with when you got to the flight line. We didn't get the friendly face of Chase or Eddie. We got Stan, who you knew where you were with that guy every moment you talked with him, which is something I always appreciated. But he was all about the learning that needed to happen in this competition. Not the winning, not the one-upping one another, it was the lessons learned. And this weekend, there was a ton of lessons being learned across the competition. But whether it was, brand new teams like the Institute of Technology of Buenos Aires coming in and learning from all of you of how to do DBF, or it was Penn State who had passed tech and somehow got all the way out to the flight line and found out that their battery installation didn't pass tech. So they owned it, came back, fixed it, and went out there. But there was one team in particular that really shined through of kind of embodying what we're looking for of DBF, which is the perpetual learning and honestly having the right attitude to go through with stuff. Because let's be honest, what we do in aviation is hard. Human beings are not designed to fly, and it's a perpetually hard thing to do for all of us. And it also means that getting argumentative or pushing or having a negative attitude does not get you in a place you need to. But this particular team really embodied what we're looking for out of a team. And this team came in, had a pretty bad accident. And they were like, okay, everybody comment on the fact that their attitude, they crashed, they gathered up the airplane, they left. They came back, rebuilt it overnight, and best attitude and had a scoring flight on their next flight. This is something that we look for all the time. And the thing is that they were not quitting. They were learning as they were going along. And it was really their attitude that shined through. I'm sorry, 2 crashes. But their attitude really shined through with everybody, and it really exemplified what we look for. And that is the Washington University of St. Louis is this year's recipient of the Stan Powell Memorial Award. So if somebody from Washington University can come up here. We don't normally have everybody sitting, which we really appreciate so you guys can see, but of course, thank you guys. Come on up, come on up. Yep. But yeah, come here.
Our team didn't sleep, so they're sleeping.
Okay. Oh, yeah. Tell us where to go.
Great. All right.
You guys can say a few things real quick.
Yeah, we would just like to say thank you to all the teams who helped us, whether it was lending us materials. There was a team who helped us laser cut, who stayed up really late to help us laser cut. Everyone who offered kind words, it really meant a lot and helped keep our team going. And we would not have made it through a successful mission without all of you guys. And we really just want to thank you guys all. It was huge for us.
Hi, yeah, I'm Julia. You might know me from the group chat of sending that we needed help. Thank you all so much. Our pilot Max, thank you. All of the teams, both Ambry Riddles that lent us stuff and gave us stuff. Thank you all. Sorry the rest of our team couldn't be here. No one slept, so they're taking naps. But thank you all, and everyone did amazing today. Thanks.
Excellent, excellent.
Excellent, guys. Yep.
And here's the box.
And it has to come back next year.
Oh, okay. I'm graduating, but Theo will bring you.
The sleepers.
Thank you.
Thank you guys.
Yeah, great job, guys. All right. Excellent. So moving on to the the next award, which is the Best Paper Award. This is championed by the Design Engineering Technical Committee, and this year the Best Paper Award goes to the University of Southern California, USC. So if one of you could come up.
All right, thank you, Rob. Thank you, guys. Now we're going to go to the moment you've all been waiting for. We're going to look at who was the top 10. Who was the top 10 finishing teams. So from the home office in Wichita, Kansas, if you know the reference, here's the top 10. Drum roll. Can we drum roll? All right. At number 10, the Technical Institute of Buenos Aires. A fan favorite, the Flying Dorito, the Condor, but the Flying Dorito, amazing blended wing design. You guys, incredible. First time, by the way, first time competing at DBF, all the way down from BA. Thank you guys for coming. And in ninth place, the Tigers from Auburn University. I think we're going to nickname you the Flying Tigers, if that's okay. In number 8 position, Virginia Tech. Go Hokies. And number 7, the Ramblin' Wreck of Georgia Tech. Woo! Number 6, a team that right from where I hail from in upstate New York, Rensselaer Polytechnic Institute, RPI. Congratulations. And number 5, the Zips, the University of Akron. Go Zips. And number 4, and 4 is a tough place, right? Like number 4, you just finished outside the top 3, right? Number 4, but you know what? They're going to keep fighting because they're the Fighting Irish in Notre Dame. All right, Russ, you going to help me with the plates here? The beautiful pure plates. All right, number 3, and this team, amazing. I got to interview these guys on the floor earlier on. and brought a huge 4 vans of folks. They trucked out here from Southern California. It's the University of California, Los Angeles. Come on. Come on up, guys. Come on up, UCLA, come on up. Peter, congratulations. Come on up. All right, Russ is going to give you the plate.
This way, just a little bit. Perfect. Right there. Perfect. Okay. Everybody right here at the lens. Big smile. 1, 2, 3. And 1, 2, 3. That's nice.
Yeah, Peter. Well done.
Thank you so much, sir.
Yeah. Their plane was Duck, Duck, Goose, by the way. Well done, boys. All right. In second place, another place that I actually lived for 5 years of my life when I worked for Blue Origin, Seattle, the University of Washington.
Perfect, right there, okay? Everybody looking here, ready? 1, 2, 3, and 1, 2, 3. Congrats for them, that's 12. Go,
In our first place team, this plane was unbelievable. Unbelievable. And I'm going to see if I can pronounce their name without screwing up. Ljubljana. Come on up, guys. All the way from Slovenia. Unbelievable. Congratulations. Thank you. Yeah. Thank you. Hey, congratulations.
Thanks so much. All right,
the whole team coming up.
Everybody here, center up. Find a window. You can see me. All right, everybody looking right here at the lens. Big smiles. 1, 2, 3. And 1, 2, 3. And one more. 1, 2, 3. Nice. Oh yeah, you can use that.
Thank you guys for coming from near and far, for making the road trip out here. I hope you had a great time. We hope you come back. Anybody else to thank, Russ? We all good? All right, that's a wrap, guys. DBF 30. Thank you for coming. And we're out. Quick announcement, guys. There's a team from Nebraska that's missing a wallet with a brown rubber duck sticker. If you got that, please return it over at the desk over here. Okay, if you find a wallet with a rubber duck sticker on it. Thank you.
Okay, so that's going to put a wrap on the 2026 AIAA Design, Build, and
Haley
Fly.
Ty, if you are still in the building, we have your purse at the registration desk. Haley Ty.
Haley, get on that. It's important. Okay. Okay. I think we're clear.
From Nevada.
Nope. Never mind. Okay. So that's how this entire weekend has been, but it has been fun. So to recap the winners, we got the University of Ljubljana taking the gold, University of Washington Seattle taking silver, and UCLA bringing up third place. The Stan Powell Award.
Hey, folks.
Okay.
We don't want to take all these ducks and pucks home with us, so please come help yourself to all the ducks you
Hold
want.
on, what?
But one puck per
Free
team.
ducks.
One puck per
Free
team,
ducks.
one
I'm
puck
out.
per team. Okay? And if there's any left over, you can come back and get
They're
some
going
more.
over
Thank
there.
you.
We've been vacated. It's fine. And then the top design award going to University of Southern California, USC Trojans. Okay. So it's still a little rowdy here in the hangar, but it is fun. This is great. I would advise anybody that wants to do this to come down and do it. It is fantastic. This is my first time being here. It was amazing. Now, here you go. Here we go. You know the drill. All right. We got to thank Textron. Textron coming in here, giving us this venue to host this awesome event. We want to thank the Textron Employees Aviation Club who gave us this hangar. That's where we do all this.
To Kennedy.
And
Oh my God, yes.
all the AIAA members and volunteers that helped make this happen. We couldn't do it without you guys. And speaking of unsung heroes, everyone out there that's watching on the AIAA live stream on YouTube and over in my neck of the woods on Twitch. Thank you very much for watching, everybody. We do appreciate it. This was fun. I'll tell you, this is a blast. I love it. It's great. Seeing all these planes fly, I could do this for another week, easily. I mean, hopefully they allow us back. We'll see. We'll see. I mean, Clay, call me. All right? We're good. All right, so, this is...
OC members, DBF OC members, go to the awards area. We're going to take a quick photo of us. Thanks.
You guys got to get on that. You got to go over there. Heard the PA announcement. But anyway, all right, we're going to put a bow on the 30th annual AIAA Design, Build, Fly competition here in Wichita at Textron Aviation's facilities. This is where we leave you. You don't have to go home, but you can't stay here, right? That's the saying. I nailed it. All right. Be sure to like and subscribe on the AIAA YouTube channel and on Twitch. You could hit that follow button if you want. I don't know. I'd prefer it if you went over and follow the AIAA YouTube channel. All right. And all the viewers at home, thank you very much for watching. Have a great night and a great rest of your weekend. See you guys. Thank you.
Demonstrations, and as they say, I was hooked.
I found that day super inspiring, and it was like a little spark in me that said, hey, if he could do it, so can I.
AIAA has helped me in my journey from a student to a professional, and now I'm like a mid-career type person.
I got encouraged to pursue graduate studies. They just really exposed me to the broader aerospace community.
AIAA helps to bring this cross-collaborative, multidisciplinary teaming together.
There are so many initiatives to empower younger people to enter the industry.
AIAA offered me the opportunities to come and present my work.
It's a great way for disseminating information, exchanging information, and being able to contribute directly to the future of aerospace.
I think everyone should join.
I'm Crystal Pasilio.
I'm Lauren Newton.
I'm Priya Abiram,
Principal Technical Advisor,
a student,
PhD candidate,
and I am an AIAA member.
AIAA gave me the tools to be ready for industry. As a student, you do get exposure to design, build, fly. You're building a plane from scratch with the support of mentors. You're exposed to the problems that we need to solve at the moment. The AIAA helped me build that passion.